On behalf of the Department of Civil Engineering of University of Moratuwa. The Department of Civil Engineering at the University of Moratuwa stands as a peak of excellence and innovation in the field of civil engineering education and research in Sri Lanka. Founded on a rich legacy of academic tradition, the department has consistently delivered world-class education and cutting-edge research since its inception under different subject areas with a flagship undergraduate program and several postgraduate and research programs. Research and innovation in civil engineering are vital for creating sustainable infrastructure, adapting to challenges, and meeting future demands effectively. Undergraduates and postgraduates of the Department of Civil Engineering of University of Moratuwa undergo various research which often lead to innovative findings and pioneering techniques in the field. The Civil Engineering Research Symposium provides a platform for these enthusiastic undergraduates and postgraduates to showcase their latest and groundbreaking research endeavors. I'm Dilanjali Thordanya, the co-host for today's proceedings.
I'm Dineth Wijayasekara, your co-host for today's event. Ladies and gentlemen, as you know, we have an eventful day ahead of us, and it is a delight to see all of you present here. Before we start off today's proceedings, please rise up for the national anthem. Thank you. Ladies and gentlemen, let us begin the Civil Engineering Research Symposium 2023. Light symbolizes knowledge, purity, and is the dispeller of darkness. Ladies and gentlemen, to start off this monumental event in an auspicious note, we would like to invite the following dignitaries to kindly join us to light the oil lamp. The chief guest, His Excellency, Chargé d'Affaires of High Commission of Canada to Sri Lanka and Maldives, Mr. Daniel Bood.
Keynote speaker for today, Dr. R.C. Karunawardena, Director General, National Building Research Organization.
Registrar of University of Moratuwa, Mr. Dishan Jayantha. Deans of University of Moratuwa.
Head of the Department of Civil Engineering, Senior Professor Chinta Jayasinghe, and other department heads.
Conference chairs, Senior Professor Tishan Jayasinghe and Professor Jagat Manatunga. Retiring professors, Professor Malik Ranasinghe, Professor Anura Nanayakara, Professor Atula Kulatilaka, and Professor Ruwan Veerasekara.
Conference Secretary, Professor Udeni Navagamua. Representing the academic supportive staff, Mr. Charaka Sathirasinghe. Representing the presenters, Mr. Madhura Hasaranga. Thank you, dear sir and madam, for joining us in lighting the oil lamp.
Before we start off the proceedings of the Civil Engineering Research Symposium 2023, let me invite the chief guest, His Excellency, Mr. Daniel Bood, Chargé d'Affaires of the High Commission of Canada to Sri Lanka and Maldives, keynote speaker, Dr. R.C. Karunawardena, Director General, National Building Research Organization, the Head of the Department of Civil Engineering, Senior Professor Chinta Jayasinghe, Conference co-chairs of the Civil Engineering Research Symposium 2023, Senior Professor Tishan Jayasinghe and Professor Jagat Manatunga, and Conference Secretary Professor Udeni Nawagamuwa to the head table. Thank you, sir. Thank you, madam.
Recognizing the profound impact of visionary leadership on the Department of Civil Engineering's remarkable journey, we acknowledge that great leaders play an indispensable role in shaping our department's achievements. As a visionary leader in our field, her guidance and support have been instrumental in nurturing the spirit of innovation and research within our department. These precious undertakings would not have transpired without an inspiring leader at the helm. At the forefront of these triumphs stands the head of the Department of Civil Engineering at the University of Moratuwa, Senior Professor Chinta Jayasinghe. Her steadfast leadership has been instrumental in steering these initiatives towards resounding success. Ladies and gentlemen, it's an honor to invite Senior Professor Chinta Jayasinghe, the head of the Department of Civil Engineering at University of Moratuwa, to welcome our esteemed gathering on this special occasion.
Thank you. Very good morning, everybody. The Chief Guest, Charge Affairs of Canadian High Commission in Sri Lanka, Mr. Daniel Bood, the keynote speaker, Dr. Asri Karnavardhana, the deans of the faculties, the registrar of University of Moratuwa, and heads of departments, distinguished retiring professors, esteemed colleagues of civil engineering and other departments, academic support staff, non-academic staff, and my dear students. I stand before you today with a profound sense of pride and gratitude as the head of the department, as we come together to mark not just an ordinary day, but an extraordinary one. We gather here to honor and bid farewell to 4 remarkable individuals who have dedicated their lives to the pursuit of knowledge, to the advancement of their fields, and to the nurturing of countless young minds. Today, we pay tribute to our retiring professors. It is my distinct honor and privilege to extend a warm and heartfelt welcome to the Charge d'Affaires of the Canadian High Commission in Sri Lanka, Mr. Daniel Bood, and his esteemed delegation. We are truly delighted to have you with us today as we celebrate and strengthen the collaboration between our department and the Canadian universities, especially, and Canadian High Commission as well, in pursuit of shared research. In fact, 2 of our retiring professors obtained their PhDs in top-class universities in Canada. That's University of British Columbia and University of Calgary. So it is a testament to the mutual respect and shared vision that binds us together. I also would like to extend a warm welcome to our keynote speaker, Dr. Asri Karnavardhana, who heads one of the largest research organizations in the country, NBRO, National Building Research Organization, Sri Lanka. He always facilitates collaborative research with our department. Further, the NBRO had very close research links with 2 of our retiring professors as well. So we as a department really value your presence at this important occasion, and I'm sure this will further strengthen our research collaborations. I would also like to welcome the deans of the faculties, the registrar of the university, all the heads of departments in the university, all other esteemed colleagues of civil engineering and other departments within the university, and also the academics from other universities. So who are present today, coming from faraway places. Thank you so much. industry participants, and the non-academic staff, and also a warm welcome to my dear students. As we embark on this research symposium, it's not just an occasion to showcase our department's academic achievements, but also to reflect on the immeasurable contributions of these 4 pillars of our institution: Professor Malik Ranasinghe, Professor Anurana Nayakkara, Professor Atula Kulatilaka, and Professor Ruwan Weerasekara. Collectively, they have shaped the course of our department, guiding it with wisdom, integrity, and an unwavering commitment to academic excellence. Today, we celebrate their retirement. Let us remember that retirement does not mark the end of a journey, but the beginning of a new chapter. These professors may be leaving our daily academic lives, but their legacy will continue to inspire us. Their passion for research, their commitment to teaching, and their dedication to the betterment of our department and the world at large will serve as an enduring source of motivation for us all. Over the course of this symposium, we will have the privilege of witnessing some of the latest research endeavors from our department. It is a testament to the vibrant intellectual community they have helped foster. We will also have the opportunity to hear from our retiring professors themselves as they reflect on their careers and share their invaluable insights. So let us use this moment not only to celebrate the past, but to look forward to the future. Let us carry the torch of the knowledge that these retiring professors have lit, and let us continue to build on their remarkable legacies. As we bid them farewell from their official roles, we also welcome them into the esteemed ranks of our department's emeritus faculty, where their wisdom and experience will continue to guide us. Thank you for joining us today to honor these exceptional individuals and for being a part of this special occasion. Let us embark on this research symposium with gratitude, enthusiasm, and the shared commitment to carry forward the legacy of excellence that defines our department. Thank you very much.
Thank you very much, Madam, for your words of inspiration. As always, it drives us to strive and become the best versions of ourselves.
Canada, with its rich history and diverse culture, has always been at the peak of academic excellence, and a significant number of our undergraduates are currently pursuing higher studies in Canada, symbolizing the commitment to fostering global academic connections. It's worth noting that 2 of our retiring professors obtained their PhDs from renowned universities in Canada, which further highlights the exceptional quality of education system in Canada. We aspire to continue nurturing this educational connection and research collaboration with Canada in the future, fostering innovation and knowledge exchange. Now, it's with distinct privilege to invite our esteemed chief guest, His Excellency Mr. Daniel Booth, the Chargé d'Affaires, the High Commission of Canada to Sri Lanka and Maldives, to share his insights with us.
Professor Jayasinghe, head of the Department of Civil Engineering, senior professors, distinguished guests, students, ladies and gentlemen, good morning. I would like to thank the University of Moratuwa for their warm welcome, and it's really a pleasure for me to be with you here today. And first things first, I understand about today's symposium. CERS 2023 will be dedicated to the 4 senior professors who are retiring after 40 years of long service. So that's Professor Ranasinghe, Professor Nanayakara, Professor Kulatilaka, and Professor Weerasekera. I first wish to convey my appreciation and admiration to them for their dedication to the fields of education, research, and engineering. I wish all four a very happy and enjoyable, well-deserved retirement, and a big well done, professors. And I was particularly pleased to hear that out of the four, two of them obtained their doctorates from two of Canada's fine schools, the University of British Columbia and the University of Calgary. Two great Canadian schools, and of course something to keep in mind for those of you who are considering further studies overseas. Though my field of study was in the area of social sciences and management, I have long been fascinated by the field of engineering, in large part because I love learning about the development of structures, about the materials used, and so on. I love the melding of creativity, science, mathematics, and problem solving, leading to innovation that can be found in the field of engineering and all of its subfields. And I think this fascination of mine came to me by way of my father, who was also an engineer. In his case, a mechanical engineer who specialized in aircraft. For many years he worked at Canadair in Montreal, which later became part of Bombardier, and he focused on the development of a variety of different aircraft. And what I noticed about him was that he truly had an engineer's mind, you know, an engineer's eye for things. And I'll give you an example. You know, when some people try to close a lid or a door that stubbornly refuses to be closed, or try to open one of those water bottles and it just drives you nuts. You know, I'm a bit like that, and people like that easily get frustrated, impatient with such things, and they try to force it, right? But my father was the type of guy who would intervene to stop them from forcing it because they could damage things. Often, you know, threads on screws get destroyed, and you know, doors get damaged, and so on and so forth. So he would intervene like that, and then he would painstakingly examine the closing mechanism or the opening mechanism to look for the obstructive cause. And once found, he would address the cause directly. And if you were an impatient kid, this would drive you a bit nuts. But he was always able to fix such problems, making things better for all. So, and perhaps that is what I found the most appealing about the engineering profession. Engineers have the opportunity to make real contributions in support of a better quality of life for all. And I saw that in a very small way with how my father approached things. And for me, this ideal of making a contribution for a better world is a key reason why I entered the field of international relations and diplomacy. And I'm fortunate to represent a country that more often than not looks at international problem solving with an engineer's eye. Historically, Canada has had a strong development-oriented relationship with Sri Lanka, and there are many examples of far-sighted investments supported by Canada, including airports, railroads, higher education institutions, irrigation projects, all of which were aimed, in those early days at least, at boosting Sri Lanka's developing economy. More recently, in line with our feminist international assistance policy, we have sought to help the poorest and most vulnerable communities in Sri Lanka through support for food security and entrepreneurship. And by the way, it is a feminist international assistance policy because we carefully examined poverty and noticed that the majority of those living below the poverty line around the world are women. So the logic is, in order to alleviate poverty, you need to address the issues that negatively affect women, primarily. We also work to safeguard human rights, including the rights of women, children, people with disabilities, and the LGBTIQ community. Since I arrived in Sri Lanka back in 2021, I've managed to travel all over the country. And it's a beautiful country. I love Sri Lanka. And it continues to fascinate me and keep me intrigued. And I'm still learning about all things Sri Lankan. But the more I learn, the more I appreciate this country's rich heritage and its beauty and its diversity. And I've come to see the connections between Canada and Sri Lanka, particularly when it comes to diversity and pluralism. And like Canadians, Sri Lankans are from diverse ethnic, religious, linguistic backgrounds. And like Canada, Sri Lanka is working through its own reconciliation process. And Canada continues to grapple with the hard truths of our own past and to work with Indigenous peoples to address long-standing injustices. And we remain ready to draw upon our own experiences in support of Sri Lanka's efforts toward meaningful and lasting reconciliation in this country. We have long supported a peaceful and inclusive Sri Lanka, and will continue to do so because this is what Canadians expect our role to be. And indeed, it is the path by which Sri Lanka will achieve its true potential, and a great potential it is. Over the past decade, we have funded demining efforts and worked to advance language rights, drawing on our own bilingual experience. I've also, in my travels, heard firsthand about the hardships that many Sri Lankans yet face as Sri Lanka recovers from its economic crisis, and we were pleased to support this recovery through our membership in international organizations and through our provision of humanitarian support. We also focus on commercial sectors, right, where progress is key to Sri Lanka's economic recovery, and this includes agriculture, which plays a vital role in food security, and where Canadian expertise and reputation as a top agricultural producer and exporter can be helpful. Another is education, which the head of department previously mentioned, in which several Sri Lankan institutions are partnering with Canadian counterparts to bring education to students who remain here. And then we've also noted some Canadian businesses are outsourcing operations to Sri Lanka, taking advantage of favorable operating conditions, including the availability of young, educated, and diversity in the workforce. Looking ahead, we have both new and long-standing priorities to focus on. Recently, Canada launched its Indo-Pacific strategy to guide its global engagement, and our priorities include the promotion of peace, resilience, security, as well as the building of a sustainable and a green future. Issues such as climate change and the pandemic have shown us the extent to which nations have become interdependent, and the problems we face now are the ones we need to resolve together. And Canada values working with Sri Lanka, both bilaterally and in multilateral fora. And I am confident that if we are willing, we can indeed resolve formidable problems. If we take the time examining each problem with an engineer's eye, and the requisite patience also, so as to understand the root cause and thus arriving at a solution and contributing to making the world a better place. So thank you for having me, and I wish you all a most constructive, and illuminating day. Thanks again.
Thank you, sir, for those words of inspiration and making this event memorable with your presence. We are honored to have you with us today. Mary Bateson once said, "We are not what we know, but what we are willing to learn." Ladies and gentlemen, that is exactly what we are here for today, to learn, showcase, and prosper. So let us now move on to one of the most significant items of today's agenda, the keynote address of the Civil Engineering Research Symposium 2023 by Dr. Asri Karunawardena on the topic and insight into the advances of geotechnical engineering in landslides and soil improvement technology in Sri Lanka. On this momentous occasion, I would like to apprise our audience that two of the exceptional personalities bidding farewell to us today have worked in a close relationship with the National Building Research Organization. Not only that, even at the present state, multiple researches are carried out in collaboration with the department and the National Building Research Organization. Without further ado, to introduce our keynote speaker of the day, I cordially invite Professor Nalin De Silva on stage.
Thank you very much. Good morning to all of you. Our chief guest today, Mr. Daniel Wood, head of the Department of Civil Engineering, the deans of the faculties, retiring professors, distinguished guests, my colleagues, ladies and gentlemen. I'm truly honored to have the privilege of introducing our keynote speaker for today, Engineer Dr. Asri Karunawardena. Dr. Asri is a renowned expert in geotechnical engineering, a visionary leader, and an inspiration to many in the field of civil engineering. Dr. Asri Karunawardena is the Director General, Chief Executive Officer of the National Building Research Organization, known as NBRO of Sri Lanka. As you may know, NBRO is the main focal point in Sri Lanka for landslide disaster risk reduction, and it is taking a leading role in promoting resilient and safe infrastructure construction in the country. As the Director General of NBRO, Dr. Asri is leading a team of multidisciplinary professionals to reduce the losses due to disasters by integrating disaster risk reduction into the planning and development processes in the country. Dr. Karunawardena is a proud product of the University of Moratuwa. He is graduated as a civil engineer in 1998 and obtained his master's degree in geotechnical engineering from the same university. He obtained his doctoral degree from Kyoto University, Japan in 2007. His major fields of work includes, but not limited to, landslide risk reduction, geotechnical engineering applications, and resilient constructions. He has engaged in many large-scale infrastructure development projects as a geotechnical expert and authored over 10 peer-reviewed technical papers on various aspects of geotechnical engineering. His doctoral thesis, titled Consolidation Analysis of Sri Lankan peat clay using elastoviscoplastic theory, is regarded as one of the most comprehensive study conducted on Sri Lankan peat soils. He is a chartered engineer and a member of the International Society of Soil Mechanics and Geotechnical Engineering. Today, despite his busy schedule, we are fortunate to have Dr. Asri here to share his expertise and wisdom with us. I hope his keynote, titled An Insight into the Advances of Geotechnical Engineering in Landslides and Soil Improvement Technology in Sri Lanka, promises to be enlightening, engaging, and thought-provoking. So, without further ado, please join me in giving a warm welcome to our keynote speaker today, Dr. Asri Karunawardena.
presentation ikutin.
Good morning, everybody. His Excellency, Mr. Daniel Wood, Charge Affairs, Canadian High Commissioner, Canadian High Commission, Professor Mrs. Jai Singh, Head of the Department of Civil Engineering, retiring professors, senior professors, academic staff, distinguished guests, ladies and gentlemen, and dear students. I am honored to be invited to give a keynote speech at this Civil Engineering Symposium organized by the University of Moratuwa, which is leading university in Sri Lanka, leading university in the field of engineering in Sri Lanka. So, topic here is today I am going to talk about is an insight into the advance of geotechnical engineering in landslide and soil improvement technology in Sri Lanka. As you heard of the introduction, so NBRO is carrying out multidisciplinary research in order to build a safe built environment in the country. So that include many areas, landslide, geotechnical engineering practices, building material, environment, and the human settlement planning, so wider areas. So in today's context, so I talk about this landslide and how geotechnical application are involved to solve these problems. At the same time, so I consider this as a very important event because today's this research symposium organized to recognize of this retiring of these senior professors. So these senior professors are very closely work with NBRO. At the same time, all these professors has teach me in the undergraduate level, and later in the higher studies, Professor Pulatilaka has guided me to this geotechnical field, and I'm sure that he's the one of the main person who is helped me to become this position. So I offer my gratitude to Professor Pulatilaka and all, Professor Nana Aikara and Professor Malikran Singh and all these senior professors. So coming back to today's subject, so significance of geotechnical engineering and resilient construction. So NBRO is a mandatory organization for this landslide disaster as well as promoting resilient construction in the country. So in landslide management, this geotechnical engineering plays a very vital role. So as you know, geotechnical engineering is a branch of civil engineering that deals with behavior of earth and earth material and their interactions with the structure and infrastructure. So due to the non-homogeneous nature of this soil, so it's always very challenging. It's not like concrete. Soil is a non-homogeneous material. So when we try to predict the behavior of soil, so it's always challenging. And due to the rapid development of the country, so good lands are almost limited. So we have to use this land as the problematic soil. So in that case, understanding of geotechnical behavior of these soils is very important to have safe built environment. At the same time, when you talk about the resilient construction in Sri Lanka, we have a lot of natural disasters. Because of that, there are a lot of loss and damages. Every year, we in the Ministry of Disaster Management, so we are paying billions of rupees for these, disaster damage. So in that case, the resilient construction is very important at this stage. So to have this kind of, a resilient construction as well as, disaster risk reduction works. So application of geotechnical engineering is very important, and I am going to talk about some application in my presentation of these geotechnical applications. But my presentation mainly talk about the application. So Of course, I'm not going to talk about complex engineering phenomena, but how we simplify these complex engineering phenomena and how we apply this geotechnical engineering principle to safeguard our people. So I will briefly explain in my presentation. So coming back to the landslides. So as you mentioned, the NBRO is the focal point for the landslide disaster management. So landslide is one of the major disaster in the country. So if you look at these statistics, you can see landslide causes the most number of deaths. So these are the figures. On the other hand, flood gives a lot of economical damage, but landslide causes a lot of fatalities. And these are the graphs you can show. So when there is an extreme event, so always landslide is always landslide occurred and many fatalities happened. So 2003, 2014, 2017, you can see this one. And when you talk about the Sri Lanka, so about 20% land are prone to landslides. That is the central highland and suburb district, the other adjacent districts, and 30% population now live on that one. So that shows how difficult to handle this landslide disaster. And these are some photographs you can see. Previous landslide in 1986 and the famous Moratuwa landslide which disturbed the railway track in 1992. These are the landslides. So you can see that these are the deep-seated large-scale landslides. And these are some landslides which occur due to the man-made activities. The previous natural landslide, but these are mainly due to the man-made activities. And these are the, I think, recent photographs of some road failures because of the road widening. This has not been done up to the engineering standard or following the geotechnical principles. So these failures has occurred in the country, in the road structure of the country. And these are the very, the kind of recent landslide. This is, I think, 2014 media with the landslide. So many people died, about 37 people. And then these are the famous Aranayak OK Gold landslides. So this is a kind of landmark landslide. So NBRO has changed their strategies to tackle the landslide situation after this one. So you can see about 37 people has died, and this is a very long, long landslide, long and deep-seated landslide. And these are the 2017s. You can see the rainfall. I think within 6 hours time we received about 400 millimeter rainfall in the midnight. So that causes the many landslide in the southern part of the country, and about 2,070 people died. So many landslide occurs. You can see the this situation, the rain start 9 o'clock and continue up to 5 o'clock. During that time, the received rainfall is 400 millimeter, more than 400 millimeter, but this was not predicted. So many landslide occurs. So you can see some photographs. So, and you can see the damage. And these are very recently, last 6 months ago, just before the Sripa, the season started, this landslide door cutting failure occurred in Nalatani area. And now I'm going to just explain about what is the NBRO strategy to manage this landslide situation in the country. First, we try to understand the landslide potential area by hazard zonation mapping. Then we carry out the special investigation when there is when the landslide symptoms occurred, and then of course we identify the communities and their risk levels, and we do some kind of early warning, mitigation of landslides, and construction approval process to reduce the damage due to the man-made activities. So in today's presentation, I mainly consider about this landslide early warning and the structure mitigation of landslides, which involve the geotechnical applications. So this is the landslide hazard zonation mapping. So you briefly explain. Now, when you look at the mountain, so it's the duty of NBRO or NBRO scientists to predict this mountain is going to landslide in the rainy days. So it's very challenging. And some theories are there based on the slope angle. They categorize there is a possibility of landslide, but in Sri Lankan geology it is not possible because we have this steep mountain with the bedrock, so the slope angle itself not give the correct interpretations. So because of that, we have some kind of scientific studies. We consider 6 factors. So, slope angle, bedrock geology, soil thickness, landform, land use, hydrology, and so on. So we have done some research, and we have given some scoring system, and we integrate these maps and formulate the final maps. Based on that, we have categorized high hazard, moderate hazard, and low hazard areas. So that is a strategy, because that kind of study is needed, because by considering large area. So these maps are available, and for the local levels, so the minimum size is 1 to 10,000 at the moment. The minimum size is the 1 to 50,000, and based on the 150,000 map, we develop 1 to 10,000 maps, and maps are distributed in the divisional secretariat areas. So you can see this kind of map. So once you develop this kind of maps, so it's our, we try to provide the kind of exposure map or risk map. For that, we overlay the building layer on the top of that one. From that, we identified how many families are living in the high hazard area, how many families are living in the moderate hazard area, and how many families are living in the low hazard area. So these are the statistics. So we realized that about 15,000 families are living in the high hazard areas, and about 90,000 families, houses are in the moderate hazard areas. And so this database is available. This is in NBR website. You can find all this database. This is we call the risk information portal. So it's an online, you can download it online and get all the information. This gives the how many families are living there, what is the number of, the house, what is the type of house construction, all these things, because that is important. That happened during the media with the landslides. So it was very difficult to identify how many families are living in those areas. Because of that, now we have the database, which all the data. So all the information can be shared with the other organizations, and they can do other, relief and all these things when the landslide disaster occurs. So then our initial map only considers landslide initiation areas. So like this kind of initiation area. So now we extend that to the flow path after observing this Aranayaka landslide, because landslide occurs on the top of the mountain, but it comes down about 2.5 kilometers, and all the houses buried due to this one. So now we extend this our landslide hazard zonation map by considering the debris flow area. And these are the maps we developed with the help of the JICA experts. So now we have the hazard zonation map, which considers some Japanese practice, red zone and yellow zone practice, and which give the guideline what you can do and what you cannot do in these areas. So these guidelines are now used in the local level approval, but now this is in the kind of cabinet decision, but now we try to legalize this system, then we can have a kind of control settlement pattern in the country. So let's talk about this risk reduction option. As I explained earlier, once we find out the element at risk or risk level of each families, we try to control the risk to the acceptable level. So our strategy is high hazard area, these 15,000 families, we try to relocate in the safe area. So there's a program going in the government. And then the moderate risk areas, so we try to control the risk or reduce the risk by the mitigation measures, because these areas cannot be relocated. The important infrastructure like a hospital, schools, and the roads. So this area we apply some kind of mitigation measures and try to reduce the risk up to the acceptable level. The larger area, so it's we adapt the concept living with landslides. So we try to give the early warning, awareness, and education program, and educate best practices to safeguard these people in these the moderate risk areas. And this is the early warning system. I think when there is rain, so you might have heard that NBRO has issued the early warning in these areas, maybe amber, red, or yellow warning. So this is the process. So we have installed about 330 rain gauges in the all catchment, landslide prone catchment areas, and every 10 minutes time, so we can receive the rainfall. And even now we can visualize as well as spectrum where it is raining and get the decision. So we have developed some threshold limit, 75 millimeter, the first warning will be ready, and the 100 millimeter per day, 24 hours, ready to evacuate. And we, from our studies, we understand when the rainfall exceeds 150 millimeter within 24 hours, there is a possibility of landslide. So you issue the early warning. So we issue this early warning to the disaster management center, and they disseminate. This is the process. Of course, this now process is now with the modern facilities. There is an app, and of course some user-friendly program to understand this landslide early warning. And this is very important. So we have some very critical infrastructure in some location, those areas that regional early warning is not sufficient. So in that case, we have the site-specific early warning. This is a fully automated system. So we have the inclinometer, we have the water level meter, we have the extension meter. So we can measure the deformation of soil. From the deformation soil, and we can measure the rainfall. We have the model to calibrate when this slope get disturbs. So that message directly come to the NBRO server and the relevant people. So we can directly issue the warning based on the soil deformation. So this is a very advanced system, and many of the areas in Sri Lanka is covered by this system, and this is functioning at the moment. So for that, of course, we have the geotechnical model, so which consider the reliable geotechnical theories, and we calculate deformation, and we calibrate this deformation threshold, and based on that we are giving that one. And then these are some photographs. You can see this inclinometer and the water level meter. So once this water level rises more than the critical water level, so we issue the early warning. This critical water level is calculated by the geotechnical analysis. And then coming back to the advanced research on landslide stress reduction, so we are fortunate to have this SATRA project in NBRO with the Japanese universities. So we try to automate this system. So what you mean by automate? So we try to predict the rainfall 1 day ahead. This is with the Sri Lankan Met Department. It's a collaborative work. So this system is extensively used by Japan, and they use this one for the Tokyo Olympics. So this same system we try to predict in Sri Lanka. So because most of the disasters occur because we have not predicted this rainfall. So we thought of try to do some mathematical modeling to predict the rainfall with the meteorology department, and then we have the 1 day rainfall, rainfall prediction 1 day ahead, and then we have the model, the geotechnical model based on the two softwares, program called LS Rapid and the slide model. So then we predict critical pore water pressure because in Sri Lankan landslide mainly due to the rain-induced landslide. So why landslide occurs? So we calculate these threshold limits and give the early warning, and then of course the platform to disseminate using the augmented reality methods. So this is ongoing. Now 5 of NBRO staff are doing the PhDs on this subject. Some have already completed. So I am sure that within coming years, this system will be implemented in Sri Lanka. And these are some photographs of this, how we predict the 1 day rainfall ahead. And we simulate this in the Arnayaka landslide. This reasonably predict. So we start from the 72 hours, 48 hours, and 24 hours. When it comes to 6 hours, so it's give the reasonable predictions. So this is challenging, and this work is collaborated done by the Sri Lankan Met Department. And then to simulate the rainfall-induced landslide, we based on the geotechnical principle. So we consider deep-seated landslide and the shallow landslide. So you can see the initial stress, and when the rainfall intensity increases, so pore water pressure get increased. Because of that, shear strength of the soil get decreased, and it smooth the failure line. So that phenomena is trying to predict from the landslides. For that, we have to get the geotechnical parameters. From the geotechnical parameters to get from the sliding surface, we use this kind of sophisticated equipment. Now very recently we have obtained this, we got this one. This is the ring shear apparatus, and this is also untrained triaxial test apparatus. Maybe Dr. Nalin is expert on these subjects. So NBRO has fully equipped those equipment now. In Sri Lanka, I think this is the only place we have this one. So I invite all the university students to come and here and experience this sophisticated instrument. So we get the soil sample from sliding surface, and we try to simulate the soil properties from that one. And once we have these soil properties, we have the LS Rapid program, and of course we calculate the initial pore water pressure or critical pore water pressure which need the landslide sliding. We call the critical RU value, and then with the rainfall intensity we simulate this when the landslide occurs with this water pressure increase. So that is now almost we completed the studies, but we have to have some kind of geotechnical layer in the landslide prone areas. So once we have this one, we can fully automate system with the before the incident occurred. So these are some simulation. You can see how we predict for the Arunachal landslide. You can see the you can see the landslide occurs in the top part, and we reasonably able to simulate the landslide flow path. So this is done in the many sites now. It is been success, and we want to apply for the other areas. And so you can see these simulations, and these mainly based on the geotechnical principle. And then, of course, one of the important subject is structural mitigation of landslides. So you know, in NBRO we have the geotechnical engineers and the geologists mainly for the landslides. So geologists go to site and they said, oh, this will come down in next rain. So then the engineer's task is to quantify that one. So the geologist has experience, so they predict there will be a landslide and all these things. So then as engineers, so we try to quantify this one. So based on the geotechnical principles, so landslide mitigation can be brought into three except hydrological methods, geometric methods, and the chemical and mechanical methods. In most of Sri Lankan landslides are mainly due to the hydraulical methods, hydraulical phenomena, because of water rise and the groundwater increase. So these are the landslide mitigation procedures. So first we have to investigate the site area to get the parameters. Then we have to perform the stability analysis and select the appropriate countermeasures. And then of course we have to construct the countermeasures, not like the building. Once you construct the countermeasures, during and after we have to monitor to see the effectiveness of countermeasures. This is very important. So these are the procedure. And so I will explain this one because this is important, because typical slope failure or the shallow landslide is a kind of mitigation is straightforward. You can apply retaining wall or soil nailing, but to mitigate the deep-seated landslide like Moratuwa or Kahagolla recently is challenging. So you need the extensive knowledge of geotechnical engineering. So this I will explain. This is recently we completed in the Kahagolla area. This Kahagolla landslide is identified in 1957, and this was up to 2000. I think this was mitigated on 2015, and time to time road has to be closed during the heavy rain period. This is a creeping landslide. This road is get damaged and upheave. So we investigate this landslide. You can see the landslide boundary. This you can see the road damage. So we investigate this landslides, and this work and with the borehole investigation and geophysical surveys, we found out this information. So these are the I'm not sure this is clear. So these are the typical landslide area with the contour map, and these are the result of geophysical survey. And these are the instrumentation. So by identifying the deformation of the field, so we install some field instrumentation in the critical area. So we identified this deformation and the deformation with the rainfall pattern, inclinometer, and the ground using the inclinometer and the extensometer. So that helped us to identify the landslide behavior. So this landslide, we have the multiple landslides, about the 5 landslides. So block A, block B, block C, and block D. So out of that, block A, very close to the road, is the most active one. So once the block A move, of course there will be other movement of the block A, B, and C, and D. So so we understood that it is very important to mitigate the it is very important to improve the or mitigate the block A as well as the other blocks. So this identification is based on our studies. And then these are the borehole we carried out. From the borehole, we have identified the slip surface from the geotechnical point of view where the sliding can occur. So we identify that one, and of course the sliding area, I mean the boundary of these landslide masses. And these are the identified slip surface in the each block. You can see block A, I mean up to the block 4, section 4. So and the critical, I mean the surface. And then so we analyzed this one, so to get the parameters. Of course we had the laboratory testing, but laboratory parameters seem to be more conservative. So then we have the back analysis, and we consider the critical safety factor and the critical water level. And once the safety factor is 1, is the once the safety factor less than 1, we get the critical parameters. So using these critical parameters, we analyze for the mitigation options. So this is the mitigation options. Once we have the soil anchoring at the top, so we can get the satisfactory safety factors. And then we go to the more detail, and this is the procedure when there is a this is the procedure of mitigating multi-slide landslides. So you can see, so we start with the critical water level, and then we consider the high water level, and we consider the slip surface of the each blocks. So once and our target area is 1.2, because to achieve the 1.2 is sufficient for these areas based on our studies. So we consider finally combination. So we have to have the earth removal work at the top, then we have to have a counter berm at the bottom, at the top of the embankment, and then we have to have drainage well to lower the water table, and then we need some ground anchored support to satisfy all the requirement. So these are the typical design countermeasures. And these are the how we apply. From the top we have the soil removal work, and that soil come to the bottom below the road, and that work as a counter berm. And then we have the soil anchoring near just above the road, and then we have the drainage well to lower the water table. So always we try to keep the water table below the critical water level. So these are the typical mitigation measures, and these are the like a sectional view. So we I mean the mitigation measures applied. So these are the photographs of the constructed mitigation measures. So you can see in the first time in Sri Lanka we consider this soil anchoring, and then some drainage wells, and some other downside of the road lightweight filling embankment. So all these technology we learned from the Japan, and I'm happy to say now local contractors are practicing all this technology. And after this work with the Japanese, so our local people are doing this one. This is the beauty of the work, and this is the what NBRO want to do. We promote this technology, and this landslide field mitigation is dominated by the local contractors, not the foreign contractors. So, and we have the knowledge, and this has been a common practice, and because of that, the cost involved in the landslide mitigation has come down significantly. And recently, with the help of the University of Moratuwa and ADPC and World Bank, so we promote this technology because of the considering the economic situation in Sri Lanka, this hard mitigation is very expensive. We try to promote this bioengineering techniques for the landslide mitigation. This is very important, and we study the existing ecosystem, and based on their stability, we select the root type and the root strength. So based on that, we have identified the areas that can be mitigated from this bioengineering techniques, and what type of plant that we have to adapt it. So this research is mainly done by the Professor Kulatilak and Dr. Navagama with the help of them, and now NBRO is practicing this one. And this Lankagama road to the Nilua. So we apply this method to mitigate these areas, these bioengineering techniques. And now the second part of my presentation. So very quickly I rush on to that one. This is the subground improvement work that we carried out in Sri Lanka. So this subground improvement technique, we before the highway construction started, we practiced very minimally, I think only the port access road. But when the highway construction started in 2004 or like something, so the subground improvement technique has widely adopted in Sri Lanka. So you can see the highway trace from the Kottao to Kurunduga Southern Highway. So many of the roads are on the soft areas, especially the soft layer in the Panape and the Bentota river areas, about more than 10 meters. So constructing the embankment of these areas is very, very challenging. So, this subsoil has a very poor properties like a high compressibility, low shear strength, and the creep behavior. And these are very adversely affect the, functionality of the highway, especially once you travel on the 110 kilometer, more than 100 kilometer, road surface has to be very smooth. Right? For that, we have to improve the ground, at acceptable level. So you can see if we not improve the road, so what will happen? So you can see this one. And these are some structures we constructed on some areas without ground improvement. And so this work, in the Southern Highway also this happened. I think the Professor Jai Singh also involved and corrected these situations. So many structures got damaged because of some sort of some sort of incident. The people have not properly studied the situation, but now it has been corrected. So this is what happened if you construct the structures on the highways without improving the ground. And so this application of this ground improvement mainly we need for the highway embankment as well as the construction structures. For that, of course, this procedure we have to have the ground improvement methods to investigation to understand the soil behavior. Then we have to have the subground improvement design, and subcontinental improvement plan, because in the highway, throughout the highway, we have to have the same settlement. For that, we have to have the subground design, match with all the areas. Then of course we have to construct and we have to have the method statement, and during the and after construction again we have to monitor and see the performance of these applied mitigation measures, applied subground improvement measures. And these are the the methods that we adopted very briefly. So I'm not going to discuss about the designing procedure, but I just explain the methods. So we use the rock replacement in the shallow soft layer thickness area. We remove and replace with the good soil. This is the traditional methods. Now other methods like a surcharging. So when there is a thin inorganic clay, we use the kind of surcharge. If the surcharge is not sufficient, or it takes longer time to consolidate, we use the surcharge with the vertical drains. Then if the soft layer is very very thin or very thick, if the embankment height is very high, so there will be stability problem and settlement problem. In that case, we use the advanced technique like a heavy tamping, vacuum consolidation, gravel compaction file, and sometimes we use the file embankment. Those are the things that we already adopted. So this work we extensively adapted in the Southern Highway and the Outer Circular Highway. And so these are the typical design procedure. So the two criteria is covered, settlement and the stability. So settlement we consider after 3 years after handing over the highway, the settlement has to control, total settlement has to be controlled below the 18 centimeter, and the gradient 3%, has to be the 0.3% change in grade over 6 meter length to have the smooth riding surface. This is the settlement criteria. And the stability during the construction 1.2, long term 1.3. So based on that, these criteria, we have developed the flow chart. We starting from the simple methods like a surcharge, and then if the surcharge is not satisfied, the settlement and the stability, we come to the surcharge with the band drain or surcharge with the geotextile. If it's not satisfied, then we come to the other methods like gravel compaction file, vacuum consolidation, and the file embankment. So this is the typical procedure of the ground improvement methods. And these are some photographs of replacement and the surcharging methods. In surcharging methods, what we are trying to do, we try to control we try to 100% eliminate primary consolidation settlement. I think you know what is primary consolidation and what is the secondary consolidation. And we try to completely eliminate the primary consolidation and try to limit the secondary consolidation, because we can't completely eliminate the secondary consolidation. We try to control the secondary consolidation as required by the design. For that, what we have done, we overload the soil, and during the service life, so this overloading will help environment to behave in the over-consolidated stage. So as you know, in the over-consolidated stage, settlement is less, as well as the secondary consolidation also less. So that is the basic principle we adopted here. Based on that, we have done the subground improvement design, and based on the available technology, we select the appropriate ground improvement techniques. And these are some photographs. The band drain, and band drain help to reduce the consolidation time. Then the vacuum consolidation, we use the Southern Highway from Kurunduga Hatamma to Dodangot to Kurunduga Hatamma. This is one of the advanced techniques. So this help to build the embankment rapidly, because the vacuum itself create inward, enhance the inward stability. So this help to have a rapid embankment construction. So this was used in the Southern Highway construction. And this is the heavy tamping method. So we have a kind of tamping methods to improve some areas. And this is the gravel compaction file. This is the one of the methods we use in Japan to reduce the liquefaction effect. But in Sri Lanka, this was used for the have a stable, the embankment transfer load to the hard stratum. So we model this one using the composite ground element method. So this was widely used in the highway construction, this gravel compaction file. And these are the instrument monitoring. This is very important. During and after construction, we have to monitor the embankment through sophisticated instrument. For that, we use the piezometers, extensometers, and the displacement gauges. So from that, we calculate we compare the observed settlement and predicted settlement. We always see whether our design assumptions are correct. So these are some photographs. You can see this is a continuous monitoring and data acquisition system we use in the Southern Highway. So from that, we confirm that embankment has sufficiently improved the level. And not only that, we have carried out the investigation. We have the data from the before the improvement, and we have the investigation data after the improvement. We compare all these things. From that, we confirm that Southern Highway, that the highway construction is up to the standards. And this one is very important. I think when you travel in the highways, sometimes you feel that during very near, very adjacent to the bridge, there will be upward launch. So you feel some, you feel when you travel in the vehicle. This is because, the bridge is built on the piles, the settlement is zero, whereas the embankment built on the soil, so there will be a settlement. So we have to control this one to the reasonable extent. So this was applied in the many locations in the Southern Highway and other highways. And so what we did, so we have some kind of file embankment and transfer settlement to the, some other distance. Most of these bridge approaches is we have constructed this file embankment, but some was not constructed due to the time lag and also economical reason. So those areas what client promised us to do, they overlay this highway, this area every 6 months or every 1 year. So that is in practice. And so this is maybe the one last slide. So before I come to my presentation, NBRO is doing, many applications. So when there is a landslide, of course, the people consult NBRO. When there is a building collapse, people call NBRO. And when there is a garbage field collapse, people call NBRO. So every time, so NBRO in hotspot. So why? What is the reasons? The reason is that, so we try to apply this engineering knowledge into the practice. That is what is lacking in the most government institutions. And how we do this one? So we have the NBRO staff, and we have a good collaboration with the staff like University of Moratuwa. So you are the experts. So we are the practicing people. So once you get together, so we can solve any problem. So that is what I want to explain here. So this garbage field collapse in New Year Day. So there's a lot of panic and in the people. And so when, of course, we have not done the garbage field stabilization, but we know what is the principle behind that one. So we get together, and I think Professor Mahesh Chavir also there. He also helped us for the environment part. Then we have the geotechnical team. So, and we, of course, we got assistance from some Japanese experts. So we calculate all these things, what is the possible impact area, and what is the houses, what are the houses that we have to relocate, and all these things based on the geotechnical analysis. That is how it happened. So this is my last slide. So what I want to say, so once you apply these basic geotechnical principles, and we can solve many problems. So, and for that, we have to have the very good collaboration with the universities, and so that will help NBRO to develop, and that will help country to, have a safe built environment country. Thank you very much.
Thank you very much, dear sir. I think our audience gathered a vast amount of knowledge by learning the significance of landslide identification and risk management and mitigation. It was quite delightful to listen to such an insightful delivery. As we extend our heartfelt gratitude to the chief guest and the keynote speaker, I hereby request His Excellency Mr. Daniel Bood to be present on the stage once again to accept this token of appreciation. On behalf of the Department of Civil Engineering of University of Moratuwa to award our heartfelt appreciation, I cordially invite the Head of the Department of Civil Engineering, Professor Chinta Jayasinghe.
Thank you, sir. Thank you, madam. To extend our heartfelt gratitude, I hereby request Dr. Asiri Karnavardhana to be present on the stage once again to accept this token of appreciation. On behalf of the Department of Civil Engineering of University of Moratuwa to award our heartfelt appreciation, I cordially invite the Symposium Co-Chair, Senior Professor Tishan Jayasinghe.
Thank you, Dr. Asri Karunawardena. Thank you, Professor Tishan Jaisingh. Ladies and gentlemen, this event would not have been as extravagant as it is today if it was not for the vital support of the sponsors of Civil Engineering Research Symposium 2023. I take this opportunity to express our deep gratitude to the following organizations for aiding us to make this event a resounding success: Inci Cement, Langwa Ceylon Steel Corporation, Nippon Paint Lanka Private Limited, International Construction Consortium Private Limited, Engineering and Laboratory Services Private Limited, and last but not least, Civil Engineering Society of University of Moratuwa.
Ladies and gentlemen, with that, we have come to the conclusion of the first session of the Civil Engineering. I apologize for that. And we would like to welcome the Deputy Vice Chancellor of University of Moratuwa to the occasion of the symposium of the Civil Engineering Department. Ladies and gentlemen, with that, we have come to the conclusion of the first session of the Civil Engineering Research Symposium 2023. We will be commencing the second session at 10:30. We would like to invite all the participants to enjoy the morning tea and refreshments arranged for you by the department. All the distinguished guests, academic staff members are kindly requested to proceed to the staff common room, while the undergraduates and postgraduates are kindly requested to proceed to the lobby area of the department.
Good morning, everyone. I am going to present you my research on analysis of curve crease origami structures, and I am Lasit Kuruppu. So if we move on to origami structures, what is origami? Origami means the art of paper folding, which was originated in Japan, and with the development of technology, it influences the development of small-scale metamaterials to very large-scale space structures. Deployability, scalability, and self-actuation can be considered as very advantageous aspects of origami structures that can be used in deployable space structures like these star shades. Not only in space structures, in civil engineering structures, as you can see in the sunshades at Medina of Saudi Arabia, these origami-inspired structures have been used. So considering the crease type, we can categorize origami-inspired structures, origami structures into two types. One is straight crease origami, and other one is curve crease origami. So in the case of deployable space structures, the packaging efficiency is a very important aspect, and so you can see a large scale 160 meter by 160 meter star shade need to be compactly stored in a very small volume of a tip of a rocket. For that, we can use origami and use that inspired technology to compactly store them. Most of the origami structures currently we are use straight crease origami patterns, but now scientists are moving into using curve crease origami structures. So there are several disadvantages in using straight crease origamis. One is we require high number of folds, therefore it takes longer production time, and ultimately the required the quality of the deploy service get reduced because of the high number of folds. Next important thing in deployable structures is the thickness of the membrane, because the packaging efficiency is a crucial factor in the deployable structures. So thinner structures allow for more compact folding, but only the thicker structures give more strength and rigidity to the overall structure. So we need to understand how would the thickness affect for the overall structure's behavior. As you can see in the picture at the bottom, if the thickness is increased in a foldable structure, it either does not fold or there will be membrane stretches. So my research is basically focused on curve crease origami structures, and curve crease origami means primarily a origami structure with a curve shaped crease, and it involves both sheet bending and sheet folding behavior. Because of that, numerical simulations is somewhat challenging. So in the slide you can see straight crease origami Mura pattern as well as curve crease origami Mura pattern. So as I mentioned earlier, now we are moving into curve crease origami structures, and thickness is a very important aspect in the deployable structures. So we need to understand how would the thickness affect for the curve crease origami structures. So my main objective is characterization of folding and deployment behavior of curve crease Mura patterns with respect to varying membrane thickness in the range of 0.1 millimeter to 1 millimeter. So the methodology followed was, first I did a literature survey, then I found analytical equations for the folding simulation of the curve crease Mura patterns, then the numerical modeling was done, and the numerical model was validated using an experimental method. Then finally the results were generated and analyzed. So the analytical characterization of curve crease folding, here I have presented two set of equations given by Gattas and Yu and Lee, where they have simulated the folding of the curve crease origami structures, but in these equations they haven't accommodated the thickness. So it is important to understand how would the thickness affect. So before starting the numerical simulations, first I need to construct the geometry. For the construction of geometry, first I need to construct the curve crease. For that, I follow the method proposed by Gattas and Yu, where a straight crease Mura pattern is converted into its equivalent curve crease Mura structure. So the first step is to construct the curve crease. By changing these parameters, an elliptical curve is generated, and then it is projected into the two sides to generate the curve crease Mura structure. So in the numerical modeling, the main important aspect that need to be modeled is the curve crease. For the curve crease modeling, I use Abacus finite element software, and there we have joint plus rotation connections, and the stiffness values for the crease is taken from straight crease experimental results. So to insert crease stiffness to the rotations, first I need to find the crease stiffness value. I found it from straight crease experimental setup. Here you can see the apparatus where I loaded the perforated ATGSM printer paper, and the crease stiffness values were taken from the gradient of the graph, and it was inserted into the rotational connector. So for the folding simulation, I used Abacus Finite Element software with explicit solver, and this was modeled under quasi-static simulation, and the material properties included to the software I presented here. So first I need to start from the undeformed shape, then I have to move into the final deformed shape. To start from the undeformed shape, first I need to direct the structure where to fold. That is called pre-bending. So it helps to prevent unnecessary deformation in the structure. So this was done by applying a single point load at the midpoint of the crease, midpoint of the edge curve, and then for the actuation of the structure, two bending moments were applied along the two edges. Then to get the final folded state, two pin end connections were applied to the midpoint of the edge curves, and then I get the final folded state. Since now I have modeled the numerical model, now I need to validate the model. For that, I need to compare the values with an experimental specimen. For that, I need to 3D construct the curved surface in the MATLAB environment. So I used LiDAR scanning. LiDAR scanning is basically a method which uses lasers to 3D construct a point cloud of the surface. So I created a curved crease origami structure with an ATGSM paper, and then it was scanned using a LiDAR sensor in iPhone camera, and then Polycam application was used to take out the point cloud, and then all the surfaces were inserted into MATLAB for the processing and the comparison. So here is the comparison in the MATLAB environment. So as you can see, the white color is the LiDAR scanned surface, that means the experimental setup 3D point cloud, and blue color surface is the surface extracted from the Abacus Finite Element software. So in the product graph, you can see that in the concave side, at the edge curve, there is a good overlap. But if we move into the convex side, there are differences in the Z value in the Z direction. So I came to the conclusion that the proposed modeling technique is suitable for analyzing the concave side, while further improvements need to be done for the convex side. So then I move into my primary goal, where I need to analyze the how the thickness would affect for the folding. For using the validated model, I compared the concave side edge curve variation. So I used three thicknesses: 0.1 millimeter thickness, 0.5 millimeter thickness, and 1 millimeter thickness. So as you can see in the results, in the 0.1 millimeter thickness panels, it has the best overlap. If we move into 0.5 millimeter, there's a good overlap in the concave side, while convex side, there's a displacement in the Z direction. But if we move into the 1 millimeter thickness, the model resists folding beyond 142 degrees, and therefore I couldn't achieve the fully folded state. So this clearly indicates that this affects the overall deployability of the structure, and if we consider the fully tessellated origami structure, it affects the overall deployability and folding system. So now I move into my conclusions. So the proposed modeling simulation technique captured the overall deformation of the 1 millimeter model, but models with increased thickness showed greater resistance against folding. So membrane thickness plays a significant role in deformation of curved crease structures, and we need to identify what is that. So the analytical equations I mentioned earlier should be modified to account for the thickness variation of these membranes. These are some of my references, and thank you very much.
Good morning everyone. I'm Madhura Hasaranga and my research is developing a masonry block using glass waste. So this is the content I will be following throughout my presentation. As we all well aware, the modern construction industry faces numerous challenges. These include material scarcity, rising material prices, and the environmental damage in extraction of natural resources. For instance, the extraction of river sand not only depletes resources but also cause issues like declining water tables and riverbed erosion. Similarly, the manufacturing of cement leads to greenhouse gas emission and it contributes to global warming. To address these pressing challenges, we must explore sustainable alternative construction materials. When we examine the past studies, a wealth of research indicates that we can effectively utilize industrial waste materials such as fly ash, quarry dust and cement clean dust as more sustainable alternative in construction. Here, I have listed some of these industrial waste materials. When we consider glass waste, literature reveals that approximately 2.03% of the solid waste in Sri Lanka consists of glass. In India, only 45% of glass waste is recycled. During my visit to a glass recycling company in Sri Lanka, I observed their process of collecting glass waste from across the Sri Lanka. Initially, the glass collected waste undergone a washing process. It's important to note that during this washing process, particles less than 12 millimeters are get rejected. Those rejected particles are often deployed in nearby landfill site. I have included some images for your reference here. I utilize these rejected glass particles for my research. Some of you may wonder whether glass waste has used as a construction material before. The answer is yes. Here I have compiled some key findings from previous research studies. For instance, when we incorporate glass powder in cement mortar, we observe improvement in strength characteristic. Additionally, this approach can lead to longer settling time and enhance the durability properties of both cement mortar and concrete. While many studies in my literature review have focused on use of glass waste in cement mortar and concrete, there is a limited body of research exploring its potential as replacement for fine aggregates. In this study, we aim to address this gap and make the valuable contribution to the sustainable development of the construction industry. Moving on to the aims and objective, the aim of this research is to use glass waste as a sustainable replacement for aggregates in concrete masonry unit to create a durable and strong building material. To fulfill this aim, we have established two specific objectives: developing optimum mix design and evaluating material performance. In our methodology, we commence with an extensive literature review to establish a strong foundation for our research. Subsequently, we conduct an industrial survey to identify a base mix design. This base mix design serves as our reference point. Building upon this foundation, we introduce 4 additional mix designs by varying the percentage of fine aggregates. We then casted block for each of these mix designs, paving the way for our experimental program. With the experimental data in our hand, we analyze our result, ultimately pinpointing the optimum mix design. These are some of the materials I have used in our research. Before using glass waste as fine aggregates in masonry block casting, it is essential to ensure that the particle size distribution of the glass align with the specification given in BS code. To do that, we conduct sieve analysis on glass waste and manufacture sand following the BS 882 standards. By analyzing the particle size distribution, we found that both materials meet the specification out in BS 882 code. After conducting industrial survey, we propose a base mix design subsequently. Subsequently, we introduce 4 additional mix design by replacing varying percentage of manufactured sand and quarry dust with glass waste. In the first mix design, 25% of manufactured sand was substituted with glass waste. In the second mix design, 50% of manufactured sand was replaced by glass waste. In the third mix design, while maintaining a 50% of manufactured sand with glass stays, 25% of quarry dust was also replaced with glass waste. In the fourth mix design, 50% of both manufactured sand and quarry dust were substituted with glass waste. Before implementing this mix design, we calculate the moisture content for each materials and adjust the mix design accordingly. In the sample preparation process, we begin by sieving the glass waste through a 5 mm sieve to remove any larger particles. Next, we carefully measure each raw materials and loaded them into a backhoe loader. Subsequently, these materials were transported to the batching plant. Next, the materials were unloaded into the mixer, where we introduced glass waste and water into the pan mixer. After a thorough mixing process, we proceed to cast the blocks, and you can see the blocks dimension in the right hand bottom of this screen. Following the casting process, the newly casted blocks were carefully arranged on the wooden deck, and the curing process was carried out by covering them by goni cloths. A continuous spraying of water was applied to maintain the necessary moisture level for proper curing. Moving on to the testings. The initial test was conducted was compressive strength test according to SLA's 855 code. We placed masonry block from each mix design into the testing apparatus and loaded the rate at 1 newtons per millimeter square per minute until the failure occurs. The results reveal compressive strength value ranging from 7 newtons per millimeter square to 15.4 newtons per millimeter square for mixed design containing glass waste. Notably, the SLS 855 code indicate a required strength of approximately 3.7 newtons per millimeter square for load-bearing masonry units in two-story houses. Therefore, we can confidently state that we have achieved the desirable compressive strength value. Moving on to the next test, we conduct water absorption and moisture content testing following the guidelines outlined in SLS 855 code. For this test, we measured wet mass, oven dry mass and air dried mass for each block from each mix design. We then use following equation to calculate water absorption and moisture content value. Interestingly, the test results revealed that as we increase the percentage of glass in the mix, both water absorption and moisture content values exhibit a significant reduction. To assess how the blocks would perform under harsh outdoor environmental conditions, we conduct a spray erosion test accordance with SLS 1382 code. During this test, we exposed 150 mm diameter area of the block to 50 kPa water pressure for an hour. The water spray was directed from nozzle position 500 meters away from the block. We calculate the scale of factor using following equation, and you can find out other relevant data from the right hand side of the screen. In these images, you can observe the block surface before and after testing. Noticeably, there were no evidence of pitting, and the scale of factors remained very small. This leads us to conclude that the blocks will not sustain damages even under harsh environmental rainy conditions. Utilizing ASTM C140 guideline, we determine the oven dry density, air dry density and the wet density of the block from each mix design. The equation employed for this density calculations are shown in right hand side of the slide. Upon examining the result, it becomes evident that as the glass percentage increase, the density value decrease. This outcome holds significant benefit for the construction industry. In summary, our research findings indicate that incorporating glass waste into masonry block mix design offers several advantages. These include higher compressive strength, improved moisture resistance, enhancing durability, and excellent erosion resistance. Furthermore, all the blocks made dimension is standard, although density values were generally lower. Noticeably, the crushing strength of glass waste based mix designs exceed the required strength for construction. Therefore, we recommend these sustainable materials for various construction applications. In moving forward, our research suggests several key aspects to further explore the potential of glass waste in masonry block. In summary, our recommendation include conducting long-term durability tests, assessing structural performance, ensuring fire resistance, analyzing cost effectiveness, and evaluating the environmental impact. These steps pave the way for more sustainable building materials. These are some of the references I have used in this presentation. Thank you very much.
Good morning, everyone. I'm Tulitha Nelaka, and I'm here to present my research presentation on the topic of vulnerability of Colombo suburb for Kalni River floods. Considering the damages causes, floods are the foremost and expensive natural disasters in Sri Lanka. Since Sri Lanka is located in a geographically vulnerable position and experiences heavy rainfall in central highlands, is highly susceptible to devastating floods. Firstly, let's move into the problem statement. Understanding flood levels, discharges, and duration is crucial for flood mitigation and risk management. Colombo suburbs face vulnerability to Kalni River floods if the flood protection system is overwhelmed. Without proactive measures and retrofitting, the bund breach and the gate failures can lead into catastrophic situations. Moving on, in this study, the lower basin of the Kalni River, which is nearly 400 square kilometers below from Hangwella, has been selected for modeling. In the first figure, the yellow color area indicates that the catchment area of the Kalni River, and the light green color in the second figure is indicate the lower basin of the Kalni River, which I selected as the study area for the modeling. The main objective of this research is to discuss the Colombo suburbs at the risk of flooding with the variation of flood levels, discharge, and duration, and the rainfall in the Colombo suburbs. The specific objectives of this research are listed as follow: to develop a suitable model for the Colombo catchment area using HECRAS, to check the adequacy of the existing flood bunds and the designing new flood bund heights for the present condition, to identify the critical locations, simulating possible hypothetical bund breach scenarios, and estimating the flood extent. Here outlines the methodology that I followed throughout this research project. During the literature review, I identified research gaps and selected a suitable hydrodynamic model. And after collecting data, analyzed the missing data and prepared data sets, then construct and develop the selected model according to the sensitivity analysis and optimize it. Finally, evaluate the model performance and took the final results according to the objectives. The detailed description of these steps are follows. The following section provides the description of the data that I use for the model simulation in this study. 1 meter resolution LiDAR DEM, hourly rainfall data at Colombo, hourly stream flow data at Hangwella and Nagalagam Street River Gauging Station, hourly tidal data at the Kalni River outlet, and the land use map. Then the analytic hierarchy process was used to identify the critical flood prone areas to establish high resolution grid for those locations. And this is the flood susceptible map which I generated using ArcGIS. The area black color in this figure are the most vulnerable for flooding. After reviewing available hydrodynamic models, HECRAS 6.3 was selected for developing the model. After preparing the river terrain, RASMapper was used to modify the specific branch beach locations. Then added geometric data and imported unsteady flow data by defining the boundary conditions. Here the Hangwella gauging station used as the upstream boundary condition and the river outlet used as the downstream boundary condition. Finally, perform the unsteady flow analysis. The sensitive analysis assesses the parameter impact on the model results. Identifying the sensitive parameters before calibration is crucial. The computational time step and the mesh size, the weighting factor, and the Manning's roughness are the identified 3 parameters. And these are the results of the sensitive analysis that I had finally obtained from the calibration and validated model, and they are very similar to the results of the previous researchers. Calibration optimizes the parameters and validation confirms the accurate representation. The parameters were fully optimized until satisfactory results were obtained through the trial and error approach. The flood events in 2008 May and 2016 May were used as the calibration and validation process respectively. The variation of simulation and observed water level at Nagalagam Street during 2016 May flood event is showing in this figure. And this table shows the objective functions results for the calibration and validation processes which were in the satisfactory limits. Before simulating a model, a flood frequency analysis was performed using Gumbel distribution. The inundation extents for the with the depth ranges were determined using simulating the model with the 50-year and the 100-year return period discharges at Hangwella. This figure shows the flood extent at the lower basin of the Kennedy River for the 50-year discharge at Hangwella. And this table shows the variation of the flood extent for the discharges with the flood depth. Then you can see how the flood extent increased with the discharge. To analyze the effectiveness of the flood bunds, the model simulates with the different discharges and measures the maximum water level along the bunds. The first graph displays the results of the analysis. The flood simulation reveals that a major portion of the right bank can handle up to 50-year return periods, but you can see the overtopping locations. However, the left bank flood bunds height is adequate for 100-year floods. In the second figure, it shows the identified vulnerable locations, and the red color line shows the existing flood bunds. This flood bund breach scenario was simulated by artificial resources at the digital elevation model using the RAS mapper. The first figure shows the flood extent for 50-year flood, and the second figure shows the flood extent for the 50-year flood with the bund breach. This gives a graphical idea about the increment of the flood extent due to bund breach. This simulation reveals that the total inundation area covers 108 square kilometers with the increment of 35%. That area experienced an inundation depth exceeding 2 meters for 50-year flood. To investigate the flood extent with the increment with discharge, the same model simulated with the 100-year discharge at Hangwella, and this table shows the flood extent in the left bank area with the bund breach scenarios. Hypothetically, breach Gothuru bund is showing in this figure. Then analyze the correlation between Nagalam Street and the rainfall in the protected area using the correlation coefficient, and the results are showing in this table. You can see that the results are positive values, so it gives highlighting the increased flood vulnerability in that protected area. This figure shows the inundation extent due to 50-year discharge and the rainfall with the bund breach at the Godatu bund and the railway embankment. Progressing to the discussion section, let's explore some key insights of this research. Areas in Kaduwela, Kolonnawa, Biyagama and Kelaniya are the risk of flooding during 50-year flood event at Hangwella. A 100-year flood extent the duration to Kelaniya and Sri Jayawardhanapur Kotte. In the bund breach scenario, Nugagedu is also affected. In the event of sudden bund breach in the left bank bunds, the flood extents can expand by 20 square kilometers. These are some conclusions and recommendations that I have found in this research. The existing flood bund heights of the left bank bund are adequate for the 100-year floods, while the right bank bund is adequate up to 20-year floods. During 50-year flood, the total overtopping length at the right bank is 300 meters, while it increases up to 650 meters for 100-year flood. If the bund breach if a button breach happened, it reached Nugegoda within 3 hours. To prevent flood during a 100-year flood, the existing right bank bund should be raised by 0.4 meters at the first section of 250 meters of the river downstream from the Oliyamulla and 0.6 meter at 400 meter along section downstream from the Gonawala. And thank you all.
Good morning, everyone. My name is Sanka Jayawardena, here to present my research on the development of an economical level of service estimation model using GPS data in a mixed traffic condition. So the concept of LOS, or level of service, is quite simple at its core. It's a system of grading for the quality of operations of roads and its surrounding infrastructure, and it should be comprehensible for both experts and non-experts. And it's mainly driven by the Highway Capacity Manual, which is under the Transport Research Board in the USA. So you can see, initially it was a very simple definition, and it has eventually evolved into a very complex definition, depending on the context in which it is used for. And the use of GPS here is mainly due to the economical, accurate, and availability aspects, as well as the ability to use real-time traffic data. So what's the problem here? The problem is the HCM definitions will not comply to Sri Lankan conditions because our road conditions, road geometry, as well as the type of vehicles that we have is different. So what's required is an economical approach to define level of service in a practical aspect in our condition. So, talking about the scope, Sri Lankan roads, the road network spans above 30,000 kilometers, and there are about 12,000 A and B class roads, and the majority of it are two-lane roads. So, within this research, I've decided to define LOS for motorized vehicles for two-lane roads. So the idea here is to represent a practical level of service estimation according to the HCM 2016 chapter 15-2. This is a table that it has represented within the HCM guidelines itself. So what I'm trying to do here is get our practical LOS and present it in the form of this table. So you can see there are 3 highway classes that they've defined, as well as 3 parameters, which I'll explain in a bit later. So when it comes to the 3 highway classes, there are class 1, class 2, and class 3. According to the definitions within the HCM itself, it's mainly for motorists traveling at high speeds, and the class 2 is for motorists that are not expecting to travel at high speeds. There may be junctions or like access roads coming into the road. And finally, the class 3 is a combination. There may be parts of both class 1 and class 2 roads within class 3, which is mainly for developed areas as well as junctions. So the methodology is quite straightforward. Data collection, I've decided to use floating car data, which is GPS with geotag video for cross-analysis, and data filtering, which is analysis of the data collected, especially the video data. And next up is the clusterization using a machine learning algorithm. And finally, the results, which is the arrangement of the results according to the HCM definition table structure. So in terms of the data collection, 2 types of data were collected. GPS data as well as geotagged video. I collected about 1.1 million data points spanning across Sri Lanka, as well as 270 plus hours of video data alongside with it. So the previously mentioned parameters that the HCM defines, there are 3 parameters. One is average travel speeds. So I directly used the GPS data that I've collected to calculate the average travel speeds. And the next parameter was the percentage time spent following, which is how much time you're spending following another car within a journey. I used the video data for this. And finally, the percentage free flow speed, which is the ratio of the average travel speed against the free flow speed of the particular road segment. This is especially relevant to the class 3 roads. So I considered 50 kilometers per hour as the free flow speed of the class 3 segments. So moving forward, the main thing I want to calculate is the percentage time spent following using the video data. So before the clusterization, I need to prepare the video data so that I can analyze how much time vehicles, our floating car data vehicle is following another vehicle in a particular journey or not. So for this, 2 image processing models were developed using the Google Collaboratory platform. One for determining if a vehicle is following another vehicle, and another for determining the type of road itself, whether it's class 1, class 2, or class 3. So this is a deep learning algorithm. So after that, the accuracy of the training data that I provided for it, I got was for both models around 90%, which is, according to previous research, adequate. After that, the next step would be the classification of the video data. So for this, another Python code was developed. So it inputs each video file, separates into single frames, 1 frame per second, runs it through the previously trained models, and outputs are obtained as CSV files. So after this stage, two types of process data were available, one from the GPS device, one from the one data bundle from the Python program, as well as the training models that were developed. So these are the 2 data banks that I was equipped with going towards the classification. So the clusterization, for this I used the K-means clusterization, which is a machine learning algorithm which is unsupervised. So since I don't know the exact ranges that I require, it should be an unsupervised machine learning algorithm, and I can define what sort of requirement or how many clusters that I require at the end. So 0.5 million from data points from all 3 road classes from the data banks were input for this, and the relevant HCM parameters were clusterized separately from each road class, and cluster ranges were obtained as an output. So these were the K-means cluster ranges that were obtained, and mind you that since each HCM parameter was input separately, the data points may not be clearly separated. So in order to visualize the separation and get the particular ranges, I used scatter plots and swarm plots with duplicates and non-duplicate data as well, in order to clearly visualize the separation. And notable observations are there may be instances where the percentage free flow speed may surpass 100% due to the unadherence of the free flow speed limit of the class 3 ranges, as well as the utilization of 50 kilometers per hour as the free flow speed limit as well. And the 5th cluster level must be checked to see if the road capacity conditions are reached as well. So these are both adjustable using the clusterization model itself. giving lower limits or free flow speed limits within the clusterization model. But essentially what I need to clarify is that this model can be used as a practical representation of level of service within the Sri Lankan context. So potential improvements is obviously a bigger data pool. A healthy data pool would be around 3 million data points. And the image processing model accuracy, the obtained accuracy was about 90%, but with additional distinct training images, we can go for about 95%. And better clusterization in terms of another parameter, a potential research question can be raised towards another parameter which fits all the other parameters and allows for multi-vector clustering so that superior clusterization can be obtained as well. So these are my references, and thank you.
My question is to Mr. Lasit Kurupu. My question is to Mr. Lasit Kurupu. You, in your presentation, you mentioned that to form the curve trees, you perforated the paper. Is there any other methods to create a curve trees, and if there are several ways to form a curve trees, why did you especially go for perforation, and can I have some explanation?
Structures we can use another method, but we use piecemeal structures. This is quite difficult because in the piecemeal structures the structure is curved, so only this one is making a picture. So we have that because we want to form the plastic. So because of that, they use the operations. This is basically used by researchers in Stanford University. So we can use the research method operations, but I cannot use that because I am using paper. Because of that, I use a rotary cutter which has pipes, and it is basically a operational wheel with spikes. So that I can do operations. Then after making the operations, I use it for 10 seconds. Answer your question, the business is the solution. Thank you very much. Any other questions?
These methods have separate that means basically PEC and DPL methods have separate equations to calculate the earth pressure depending on the soil type. The proposed obtained from finite element analysis were compared with proposed values obtained from different empirical methods presented in here. Due to the presence of laterite soil in the site, both sand and clay pressure diagrams were considered. Summary of the proposed comparison for borehole 1 is presented in this slide. Other than the DPL method assuming clay soil, all other methods provide closer proposals at the first prop level compared to the finite element analysis. They have lower proposals at the second and third prop levels assuming sandy soil compared to the results of finite element analysis. In both stage 6 and 8 figures, lower prop forces were observed for second and third prop levels with respect to the first prop level in all empirical methods when compared with the finite element analysis. PEC and DPL methods have provided closer results to the finite element results on prop forces when a clay soil is assumed. DPL method assuming a clay soil provide the highest prop forces in all stages. Simple beam method provides very low prop forces acting on the second prop level at stage 8 and it is highly deviated compared to the other results. At the last analysis, the earth pressure distribution was examined along the wall using the finite element analysis and compared with same empirical methods used to calculate prop forces as a part of verifying the prop force results. This slide represents the comparison of earth pressure distribution obtained from the software with the earth pressure diagrams obtained from DPL method and Terzaki and PEC method assuming clay and sand soils separately. Previously, we saw lower prop force values for second and third prop levels using the empirical methods compared to the results of the finite element analysis. It has been mainly observed for empirical methods where sandy soil was assumed in the calculation work. The lower earth pressure distribution obtained from the DPL and PEC methods assuming the sandy soil compared to the earth pressure distribution of the finite element analysis caused this result. The sudden reduction of earth pressure below the water table at -2 meters can be observed and it is mainly due to the replacement of submerged unit weight instead of using unsaturated unit weight of soil in the calculations. Talking about the conclusions of this research, wall deformation estimated from the finite element analysis becomes closer to the measured wall deformation when the actual elastic modulus of soil is increased by 2 to 4 times. Corner effect is severely increasing the wall deformation and may yield conservative wall deformations in the two-dimensional finite element analysis. Prop forces obtained using both the PEC and DPL methods have provided higher prop forces for the upper prop levels while lower prop forces for lower prop levels compared to the results of the finite element analysis. With that, I would like to conclude my presentation. Thank you.
Okay, thank you. So the next presenter is Arya Singha GNC and the topic is uncertainty quantification of homogenized material models. Over to you, Mr. Arya Singha.
Good morning. So, prediction and uncertainty quantification of mechanical properties of homogeneous woven composites, and my name is Nisal Arya Singha. So, speaking of woven composites, they have some unique properties which makes them famous among many industries. And one important nature of these composites is its hierarchical structure, which means the fiber and resin makes up the tow and the tows are intertwined to make the composite as a whole. So, to represent the mechanical properties of woven composites, the classical lamination theory can be used, and the ABD stiffness matrix gives the stiffnesses of the woven composites, and in this the A submatrix gives the extension stiffness, the B submatrix gives the extension bending coupling matrix, and the D submatrix gives the bending stiffness. And also it is important to highlight that woven composites are either transversely isotropic or orthotropic in nature. So in order to delve into our research, it is important to identify these keywords. So uncertainty is the unpredictability of outcomes of events, and uncertainty sources are the factors or conditions that introduce these uncertainties, and uncertainty propagation is the when uncertainties are introduced at smaller scales, they get propagated to larger scales, and uncertainty quantification is the final clear understanding of the range of possible outcomes. So let's further investigate uncertainty quantification through this concrete cube analogy. So concrete cubes have different uncertainty sources which cause the uncertainties or variances in the compressive strength. So one such uncertainty source is the aggregates. So the uncertainties in the aggregates can be in the form of shape, size, orientation, or material properties, which will result in the uncertainties in the concrete strength. So moving on to our problem statement, uncertainty quantification of homogeneous woven composites are often overlooked due to their computational costs and complexities. So the uncertainties which are introduced at the smaller scales will be propagated to the larger scales and will be finally reflected in the overall mechanical properties. So the uncertainty which we have introduced are the uncertainties in the material constituent properties. So these uncertainties can be in the form of the inconsistencies in the fabrication process or even the material itself. So our aim is to predict and quantify the uncertainties in the mechanical performance of homogeneous woven composites when the constituent material properties are subjected to various uncertainties. And our objectives are to understand how the uncertainties are introduced and propagated, to predict and quantify the uncertainty, to study the effect of different parameters on prediction, and to compare the predictions of the overall mechanical performance through different prediction techniques. So in order to achieve the set aim and objectives, first we have come up with a multi-scale modeling technique for the composite. Then we have chosen data-driven techniques for the prediction and uncertainty quantification. Therefore, data generation is carried out, then model training and validation, and finally quantification of uncertainties. So the main data-driven technique that we are focusing in this research is Gaussian process regression. Therefore, we need input data which will be used for model training, and finally the prediction as the output. So the uncertainty sources, as I said, are the material constituent properties of the fiber and resin of the composite, and the variance or the uncertainty which we are considering in this research is 5% variances in the material properties. So these properties will be introduced in the form of coefficients, and these coefficients are extracted through Latin hypercube quasi-random sampling techniques. So these uncertainties introduced in the fiber and resin will now be propagated to the tau properties, which will be then propagated into the composite. So we have used a representative unit cell to homogenize the composite, and with this we can obtain the mechanical properties. And the mechanical properties which we are focusing on is these 8 mechanical property outputs from the ABD stiffness matrix, 4 stiffnesses from the extensional stiffness matrix, and 4 stiffnesses from the bending stiffness matrix. So our inputs will be the coefficients of uncertainty which will be applied for the 8 individual taus, and the outputs, as I said, is the 8 stiffnesses from the ABD stiffness matrix. And a challenge of using Gaussian process regression is its curse of dimensionality, and this means for higher dimensional spaces we need high volumes of data. Therefore, we have produced 3000 data samples. Speaking of Gaussian process regression, it can be completely specified by its mean and covariance function. So we have the prior, and through model training we obtain the posterior. So in the prior, we use covariance functions to relate the input spaces with each other. There are hyperparameters which needs to be tuned in the model training, and these covariance functions is used to produce the gram matrix. So during the model training, the hyperparameter tuning is carried out through log marginal likelihood calculations, and in the posterior we obtain the prediction and the quantification of uncertainty. And for model evaluation purposes, we use normalized root mean squared errors, and for validation we use repeated k-fold cross validation. Moving on to our results, we can plot the model performance in the form of errors with the data sample sizes, and you can see that the highest data sample that we have considered, the 3000 data sample, has provided the highest convergence as well as the lowest error scores. And in order to compare Gaussian process regression prediction capabilities with other data-driven techniques such as artificial neural network and linear regression, as you can see, in this specific stiffness output, the Gaussian process regression has the lowest error, which means it has the best prediction capability for this specific output. So this is a summary of the comparison between the prediction techniques. So out of the 8 stiffnesses, 4 stiffnesses Gaussian process regression performed better than the others, and for the uncertainty quantification wise, the highlighted are the highest uncertainties observed. So for 5% material property uncertainty, a 2.3% uncertainty is observed in the predictions, and higher variances are shown for 10% and 15% variances, which are extrapolated predictions. So in our conclusions, the radial basis function, Maton function and dot product function had better predictions out of the considered kernel functions. Gaussian process regression provided better prediction for 4 out of the 8 mechanical properties compared with the performance of neural networks and linear regression. The model provided reasonable mechanical property predictions for extrapolated material uncertainties, and mechanical property uncertainty quantified for bounds with within 2.3% for 5% material property uncertainty. Thank you.
The topic is testing the utility of Okay. Good afternoon, everyone. I'm Namli Chaturanga, and I'm here to present my research study about developing a readiness tool to assess the construction organizational readiness toward the digitalization. Let's move on. Okay, let's have some introduction to the topic. When we talk about the construction industry, the construction product is essential topic to discuss. When we look into the past few years, the market sector productivity is continuously increasing. The main identified reason within the literature was the market sector operations are more highly capital intensive, or the most of the operations are automotive. When we talk about the construction sector productivity, it is still lagging behind other industries. The basic understanding or the identified reason was the construction sector operations are highly labor intensive up to now. So, to improve the construction productivity as well as reduce the dependency on the external factors because of the labor intensive behavior, we have to move towards the construction digitalization. Okay, let's talk about the problem we have identified. The problem I have identified, the construction industry in Sri Lanka is suffering from lower productivity rates. The feasible solution I have identified from the literature was the construction digitalization. That means there is a problem as well as there is a solution. But before we going into the construction digitalization, we have to measure our readiness levels towards the digitalization. For that, there is a lacking a tool to assess the readiness levels as well as to identify drawbacks and deficiencies of the construction industry towards digitalization. So this research aims to provide a developer readiness assessment tool which can use to measure the readiness level towards digitalization. Okay, these are the objectives I have developed based on my aim. First objective was to identify digital technologies and application to boost productivity. Second one, to identify the digital technology readiness indicators. That means I am going to develop a readiness tool. That means I want to have some readiness indicators to measure the readiness. Third one, to develop a readiness tool to measure the readiness, as well as fourth objective was to modify the developed tool for the convenient use. Okay, this slide shows why we need this research. As I previously said, there is a prevailing gap of the Sri Lankan construction industry. There is no tool to check the readiness of the construction industry toward digitalization. Second one, with this tool, we are able to identify drawback and deficiencies in construction industry in Sri Lanka, as well as from identified drawback and deficiencies, we are able to create strategic plans and measures to achieve digitalization effectively. This is the methodology I have followed within my research study. I have done a first preliminary literature review to identify construction productivity problems as well as to identify the research gap I have previously mentioned. Second one, I have done a systematic literature review to identify digital technology which can use to improve the construction productivity as well as to identify the readiness indicators. After that, I have done a data collection through a questionnaire survey followed by a pilot survey. As a final step, I have used robust data analysis techniques like descriptive analysis, fact analysis, and fuzzy synthetic evaluation technique to come up with the readiness tool. Okay, let's move on with the methodology, the specific parts. As I said, we need some readiness indicators to measure the industry readiness. I have identified 15 readiness indicators to the literature under two main frameworks. First framework is the TOE, or the Technology Organization and Environment Framework. Second one is the RWCSMO, Readiness for Workforce Strategic Change Management Framework. Under this TOE framework, I have identified three dimensions as technology, organization, and environment. Under the RWCSM, I have identified another two dimensions like leadership and workforce. Under these 5 dimensions, I have identified 15 readiness indicators to the literature. Let's look at the first indicator. It says that familiar with novel DT. DT means digital technologies and application areas. That means if some company is highly familiar with novel DT, their readiness level is high. That type of readiness assessment will be done, but through a systematic process. You can see under the technology dimension, I have identified 3 indicators. Under the organization, I have identified 6 indicators. Under the environmental, 2, leadership 2, and workforce 2. That means under 5 dimensions, I have identified 15 readiness indicators as in the slide. Okay, then we can move on to the data collection. As I previously mentioned, before the questionnaire survey, I have done a pilot survey to achieve this objective. First one, to ensure the suitability of identified readiness indicators in the global context to the Sri Lankan context. Second one, to ensure that all aspects are covered within the identified readiness indicators. As the third objective was to improve the wording of the questionnaire based on pilot survey participants' responses. Then we can move on to the questionnaire survey. There was the demographic data as well as the readiness assessment data collected to questionnaire. In the readiness assessment data collection, all the indicators were reproduced as statement. Just as an example, look at indicator 2, it says that education and training for employees to be technology competent. That means it is not directly understandable. Because of that, I have reproduced it as our organization provide adequate education and training opportunity to ensure that employees are technology competent. It is it is understandable. Then all the participants asked to rate all the 15 indicators in the 7-point Likert scale, which means strongly agree score 7 and strongly disagree gives score of 1. Okay, these are some of the highlights of the questionnaire survey. You can see all the demographic data and the readiness assessment data was collected to the questionnaire. Okay, these are some of the survey result I have got. Just see how the indicator 1 was rated by the participants familiar with novel DT and application areas. 18% of organizations said they are strongly agree with this statement. Some 43% agree with this statement. That type of rate, all the indicators were rated by the organization, and all these data were used in the following step of the readiness tool development. And just to illustration, I have indicator use this slide to as illustration indicator 1 and indicator 2, how they rate these indicators. Okay. Then we can move on to the readiness tool development. First, I have done a descriptive analysis to identify what are the critical indicators. I have used one sample t-test and identify all the 15 indicators are critical indicators and can use in further steps. Also, mean value was used to rank the critical indicators based on their criticality. Then I have employed factor analysis. The specified factor analysis technique I have used is the principal component analysis. That means we have initially 15 variables of readiness indicators. I want to reduce the dimensions. So I have employed principal component analysis and take that into two-dimensional space of two principal components. First one is the indicator group 1 and the second one is the indicator group 2. You can see what are the indicators out there in two groups. Then I have employing fuzzy synthetic evaluation. That means we are collected the questionnaire survey data. That means those are subjective evaluation like strongly agree. But we have to develop a readiness assessment tool. That means we have to do the objective evaluation. To take that transform, the fuzzy synthetic evaluation is a good technique. In this thing, the step 1 was to calculate all the weightage values for the indicators. All the weightage values were calculated like in the slide based on their mean value. Then the step 2 is the creation of the membership function. To create the first level membership function, I have used the questionnaire survey data. Then there is something called second level membership function. You can see to develop the second level membership function, the fuzzy composition operation used for the between weighting matrix and the fuzzy evaluation matrix, which based on the collected questionnaire data. After that, I have the step 3 was to calculate the criticality index for each group. This criticality index means how critically it influencing the final readiness. And it, as the step 4, it is normalized to have a summation of 1. And you can see the final readiness model as a statistical model. It cannot be understandable in that situation. Let's see how this works. Just assume that there is a company A. They score themselves under this condition. The familiarity with novel DT and application area, they give 7 score. That means they are strongly agree with that. In the second statement, employee education, they are given 6 score. That means they are given, they are agree with that. Okay. That means they can comprehensively understand their behavior and score themselves, and there are weightage values, inbuilt value of the readiness tool, and they can find what is the weighted score for their indicator group 1. As following the same step, they can find the IG2 score, the indicator group 2 score. Then you can find their readiness level. This is the model I have developed or shown in previous slide. By using this equation, you can find the DT readiness score value. Then you can find the maximum score possible is 7. That means if some organization in 100% ready towards the digitalization, they have a score of 7. This company has 5.86. Then their readiness level is 83.7. Okay. As a summary, a readiness model was towards the construction digitalization was developed based on a questionnaire survey. As well as the construction organization can have a holistic view of digitalization with this tool. At the third step, It fulfills the prevailing research gap in the Sri Lankan context, as I previously mentioned, as well as based on these results, the construction organization can identify drawback and deficiencies and create a strategic plan towards digitalization. With that point, I would like to conclude my presentation, and thank you.
A very good afternoon to everyone. I'm Mishandi Alvis, and I'm going to Very good afternoon, everyone. I'm Mishandi Alvis, and I'm going to present the research on evaluation of environmental impacts of solar PV panels with life cycle assessment and recycling of end-of-life PV panels. Today we delve into a crucial topic that affects us all, the rapidly rising environmental impacts of high energy demand and fossil fuel usage. As a result of moving towards an alternative, there is a promising rise in renewable energy production, with a special focus on solar energy systems alone. As the solar energy generation industry grows, in 30 years of time, it is estimated to have tons of waste contributing just from PV panels. And Sri Lanka is planning to reach 1,000 megawatts capacity of solar power in the future. It is high time that we try to come up with a solution. Additionally, we'll emphasize the importance of proper disposal of PV panels due to their hazardous elements and discuss Sri Lanka's efforts in promoting solar parks, addressing the need for a robust policy framework for PV panel-based management. Just to get a basic idea of what we are going to talk about in the next few slides, let me show you a visual description of a PV panel. What you can see on the screen right now is a portion of the most important component of the PV system, the PV panel. As you can see, it is made from elements that need raw material extraction such as silicon, copper, aluminium, etc. So why do I base this research on PV panels alone? This is a literature study about 16 impact categories. I'm not quite sure whether it's clear, but 16 impact categories of PV systems using CIMA-Pro, a modeling software that is used for life cycle assessment worldwide. The dark blue segments show the proportionate figure of PV panels with regard to 16 impact categories of the environment. Here it is quite visible that PV panels have the most profound impact to the environment. The research aims to have a conceptual life cycle assessment on carbon footprint of PV panels. Basically, life cycle assessment is a systematic approach to assess environmental impacts of a certain product from cradle to grave, as in from when it's made to when it's getting disposed of. With a review of recycling practices that are going around the world, we will try to apply those policies, regulations applicable to Sri Lanka. On a special note, I must emphasize that this is mainly based on secondary resources. Also, you can see the main resources that have been used on your right side of the screen. As of now, Sri Lanka does not produce a significant amount of solar energy considering countries like India, China, Germany. So therefore, with the lack of raw data available in Sri Lanka, I would like to move my interest towards New York, United States of America. When you consider New York State, there are few hundreds of solar parks that produce 10 megawatts each, which is a scenario that Sri Lanka can relate to, if you ask me. As you can see on the screen right now, the right side of the screen, these are the solar parks that are present as for now in Sri Lanka. And most of them are around the capacity of 10 megawatts. Even though some parameters aren't applicable, we can assume a hypothetical scenario and make proper adjustments. And with the convenience of access to database from NYSERDA, we can obtain the carbon footprint as well. Let's have a look at the methodology. It is quite simple to follow. First, we have the literature review and data collection, followed by an estimation of carbon, embodied carbon in each phase. Then comes the interpretation. Now we move to the review of international practices of PV waste management. With the knowledge gathered, we come up with the robust framework that will be adaptable to Sri Lankan context. You might be wondering what is embodied carbon. Briefly, it is the sum of greenhouse gas emissions released in each stage of life cycle. And here it can be called as carbon footprint as well, and the measuring units as follows. Also, for obtaining those coefficients, for the relevant coefficient, the following references were used. Environmental impacts of PV systems can be identified as follows. Even though PV panels have almost no environmental impact during their operational stage, manufacturing, installation, and end-of-life stage otherwise. As we discussed before, manufacturing requires raw material extraction, which will result in producing high energy levels to the environment. Also, it requires high amount of water usage as well. Installation and land use will ultimately result in wildlife degradation, which is irreversible. So, what if we can reuse the end-of-life PV panels for material extraction for the manufacturing process once more and keep that cycle going? That will eventually reduce the amount of carbon footprint that is being exposed in the manufacturing process. And here lies the conceptual life cycle assessment. So as you can see, that the installation and transportation show the highest amount of carbon footprint, but we have to understand that the transportation and installation carbon footprint can be much lower with regard to Sri Lankan context, since New York is twice the size of Sri Lanka, and as a solar panel exporter, China, for instance, as a solar panel exporter, China is much closer to Sri Lanka than New York. Therefore, the real deal stands between PV manufacturing and end-of-life carbon footprint. If we can use the material recovered from end-of-life PV waste, we can address the carbon footprint representing the manufacturing stage of PV panels and consequently reduce the landfills, resulting reduction of both manufacturing and end-of-life carbon footprints. Also, if you see the figures highlighted in green, the recovery of copper reflects a lower coefficient than the copper extraction coefficient. Copper recovery has a low embodied carbon count compared to carbon extraction, which also favors in our point. Please note that the electricity consumption and heat generation are not taken consideration here. Let's take a look at a graphical representation of the material recovery in terms of carbon emissions. Study shows that if we consider heat, electricity emissions and consumption, the carbon emission can be further reduced to almost 50% from the material recovery process. So what else we can benefit from recycling PV panels? With recycling and source recovery, we can sustain valuable resources such as aluminium, silver, etc. And over time, manufacturing PV using recovered material will increase economic growth substantially. Let's move on to the regulatory body of PV waste management that is proposed for the Sri Lankan context. With a thorough understanding of end-of-life PV management in other countries, we can break down the framework into three categories: accountability, financial support, along with recycle process. Here I will give you an overview of the framework that is being proposed. When it comes to accountability, the producer, consumer, and the community are held accountable for EUL management to flow properly. It's like a chain that have to be interconnected together. For instance, consumers and community should have a proper understanding of what needs to be done after the lifespan of PV panel. Also, the producer should be accountable for the product and where it's going to end up. Here, the producer are the parties who import and sell PV systems, and they should be legally binding for their accountability. For that, they need to be verified and registered in a government body. Some of the responsibilities of the producers, consumers, and the community should follow us, community, as stated as well. Establishing a financial support system, recycling process is briefly described here. Since we are running out of time, I will just address key points of the particular aspects. When it comes to financial support, government aid is much more important, as well as the fundings by legal provisions such as Sri Lanka Sustainable Energy Authorities. And when it comes to recycling, we can have regional, provincial collection points and extract raw materials using mechanical separations, which are more cost-effective method. And by standardizing that, we can tap into the PV panel markets for resale as raw materials. In conclusion, the installation and as we discussed earlier, the installation and transportation phases shows the highest carbon emissions. So the recoverable materials showed potential carbon emission savings if recycled and reused. And when it comes to the robust framework, collective responsibility of community, consumers and producers is vital for it need to be successful. And also the government support is crucial as well. So that would wind up my session, and thank you all for listening.
Thank you very much. Thank you very much. So that is the fourth speaker. So we finish all 4 presentations. Now we have question and answer session. So can I have all 4 authors here? Okay, I have a question for Adi Singha. Now, the way you have analyzed your model, you have used a reference point and an axis of symmetry, right? So that means that's how you got that equation for this force and the moment. Now, if you have time-dependent effects, can you include that?
The model that we have used currently doesn't account for time-dependent effects. So the model can be used, like updated to account the time-dependent effects, and then the same framework can be used for the predictions. So currently that aspect is not considered.
Any other questions from the audience?
I would like to ask a question from Mr. Sachin. In the presentation, you mentioned that you use the finite element method to calculate the proposals and earth pressure distribution. So why didn't you use limit equilibrium approach?
That means like what you are talking about, like limit equilibrium approach means like free end method, fixed end method, the basic methods.
Yes.
So basically what we are doing is in those when we are doing taking that approaches, we are basically taking moments. So when it comes to more than one prop, this structure will be statically indeterminate. In that case, there are different methods that have been created, like the Teresa-Ganpet method and DPL method, to assess the multi-proprietary structures. So that's why basically we don't evaluate multi-proprietary structures using free end and fixed end methods. We can evaluate cantilever and like reading structures with one prop level. I hope I answered.
Thank you.
Any other questions?
Elastic modular. Yes. In that slide, sir, I mentioned that it's from like Japanese literature. We use 7N, and N is basically the N70. So using the SPAT data, we can calculate the elastic modulus value using that equation, sir. that means the actual measurements. Those were like, basically I went to the field during the like 3-4 weeks I went there, but the measurements were taken not directly by me, by the experts. They are using inclinometers and take those gauges readings in every 2 reports, and they will prepare the report and send to us. So using those data, I plotted that actual deformation. Other than other 4 deformations, there are outputs of the numerical analysis, sir. Yes, sir. Yes, sir. It's not like basically done me. There are special skill person. They done that, but I said, sir. Yes.
Okay. Now we are behind time, so we have to limit the question and answer session. So I would like to thank all the presenters and then also the audience for participating in this session. Thank you.
Thank you all for a very insightful presentations comprising novel techniques and findings. Now it's time to recognize the effort and dedication of the presenters of today's second technical session who presented their methodologies and key findings with us. For that, I hereby invite the session chairs, Professor Ruwan Veerasekara and Dr. Kasun De Silva, to present the certificates to our presenters.
Finite element analysis of a deep excavation supported using a secant pile wall, a case study by V.S.S.D. Silva. Prediction and uncertainty quantification of mechanical properties of homogenized woven composites by G.N.C. Aryasinghe. Assessing the readiness for digital technologies adoption for enhancing productivity in the Sri Lankan construction industry by I.H.N. Chaturanga. Evaluation of environmental impacts of solar PV systems with conceptual life cycle assessment and recycling of end-of-life PV panels by A.R.I. Dialvis. Thank you very much, sir, for joining in for the awarding of the certificates. Ladies and gentlemen, we've just witnessed the incredible potential of our undergraduate students in shaping the future of civil engineering through their innovative research. Now, as we continue the journey of discovery, bridging the gap between theory and practice, we move on to another exciting segment of the Civil Engineer Research Symposium 2023. In the third research presentation technical session, research scientists from the National Building Research Organization will showcase their disruptive ideologies. Before we dive into the segment, let me invite our 2 distinguished session co-chairs who will lead us through these presentations. Session co-chairs, Senior Professor Atula Kulatilaka and Professor Jagat Manatunga. Sir, I cordially invite you to commence. Session co-chairs, Senior Professor Atula Kulatilaka and Professor Mahesh Jayavira. Sir, I cordially invite you to commence the proceedings of this session.
Good afternoon. Welcome to the third session of the symposium. In this session, we have 4 presentations from NBRO scientists, a special session allocated to NBRO. So we'll start with the first presentation by GKBM Gannorua, development of fiber reinforced paving blocks for outdoor sports surfaces.
Good afternoon to you all. I am Maheshi Gannorua from National Building Research Organization. My research title is Development of Fiber Reinforced Paving Block for Outdoor Sports Surfaces. This study is supervised by Professor Nanayakara. This is the outline of my presentation. In Sri Lanka, apparel industry generates approximately 44,000 tons of fabric offcuts per year. Spandex mix offcuts are difficult to recycle. Currently, it is incinerated in cement kiln. Spandex is a segment polymer containing segmented polyurethane, which has superior stretch and elastic recovery ability. Normally, polyester spandex consists of 5 to 40% of spandex and remaining part is polyester. Considering the fiber effect of yarn in the fabric, its elasticity effect and permeable characteristics, study was focused to development of paving blocks for outdoor sports surfaces. The main objective of this study is development of paving blocks with better walking comfort characteristics by embedding fabric waste containing spandex while satisfying relevant industrial standards. In the methodology of this study, first we carried out the literature survey, then analyzed the properties of polyester spandex fabric, then laboratory trials were performed for cement-based specimens while embedding polyester spandex fabric. Finally, determine the optimum mixers and production process for casting paving blocks with satisfied relevant industrial standards. As the materials for this development, we used polyester spandex fabric, ordinary Portland cement, manufactured sand, and two types of admixtures, polycarboxylic ether-based superplasticizer and cellulose-based viscosity modifier. At the initial trials, we cast cement paste prism specimens while embedding fabric pieces into the cement paste. In these specimens, we changed the size of fabric pieces and fabric incorporation content to evaluate its properties. Under the flexural test, here this bar chart indicates the flexural strength variation with respect to size of fabric pieces. In this chart, red line indicates the flexural strength obtained for specimens cast with mixed size of fabric pieces. Mixed size means size range from 0 to 10 millimeter. Considering the not much significant strength variation, for further testing, we are decided to use mixed size of fabric pieces, size ranging from 0 to 10 millimeters. When we consider the flexural strength variation, at 7 days and 28 days, up to 26% fabric incorporation, flexural strength increased, and thereafter gradual reduction was observed. This behavior shows that the reinforcing effect of fabric fibers in the cement matrix, and the optimum reinforcing effect was obtained at 26% of fabric incorporation content. When we consider the compressive strength of prism specimens, compressive strength also increased up to 25% of fabric incorporation, and after 26% of incorporation, it gradually reduced. This is due to the reduction of binder content in the mixture, and this behavior also shows the reinforcing effect of fabric fibers in cement matrix. Based on the flexural and compressive properties, we identified the optimum fabric incorporation content as 26% for cement matrix. When we consider the failure pattern obtained for flexural and compression load, it is not a brittle failure like conventional cement-based products. At the initial stage, it shows elastic deformation, and thereafter at failure point, it shows elastic deformation. Based on the optimized fabric incorporation content, we cast paving blocks while changing the cement content and sand content in the mixtures with the use of admixtures. With the increment of sand content, appearance of fabric pieces on the paving block surfaces were increased due to the reduction of binder content in the mixture. Then cast paving blocks belong to different mix proportions were tested for these parameters. Under compression load, the paving block is initially subjected to elastic deformation and thereafter plastic deformation. No clear failure point is identified. Therefore, for compressive strength estimation, we consider the failure point as elastic deformation region change in point to plastic deformation region. So that load was considered as failure load. With the increment of sand content in the mixture, compressive strength gradually reduced. When we consider the tensile split-in strength, it is performed as per BACN standard. As per the standard, its requirement is 3.6 Newton per square millimeter. Here also, with the increment of sand content, tensile split-in strength gradually reduced. When we consider in the standard requirement, we can incorporate 30% sand content into the mixture of cast-in paving blocks. Based on the compressive and flexural strength test results, 3 mix proportions were selected for cast-in paving blocks, and another set of paving blocks were cast while improving the compaction process used during the cast-in, and those samples were again tested for compression and tensile split-in strength. Then these selected mixtures were tested for abrasion resistance with the use of wide wheel abrasion tester. According to that results, selected 3 mixers shows abrasion resistance value as 17 and 18 millimeters, which satisfies the SLS standard requirement, which should less than 20 millimeters. Then to evaluate the slip resistance of the block, we perform the skid resistance test at wet condition as per SLS standard with the use of pendulum friction test equipment. According to that results, fiber reinforced paving blocks shows its skid unpolished slip resistance value as 80. As per the standard requirement, it should be greater than 55. In addition to the requirements specified for paving blocks in standard, based on the behavior of this block, we test its water infiltration capability with the use of constant head permeability test. According to that results, we identified that this block has the capability to infiltrate approximately 100 liters per square meter during 30 minutes time period at 1 bar pressure head. This water infiltration capability facilitates recharging underground water sources while reducing surface runoff. Based on the failure pattern obtained under compression load, we observe the shock absorption capability of this development. Therefore, its shock absorption capability was measured as per BACN standard while fabricating artificial athlete apparatus. Here, force reduction capability was measured with respect to conventional concrete paving blocks. Accordingly, comparative to conventional concrete paving blocks, this fabric embedded paving blocks has to absorb impact energy by 21%, which gives better foot comfort for its users. As a novel material, we incorporate fabric fibers into cement matrix in paving blocks. Therefore, we estimate its durability of fabric fibers in alkaline environment by performing 50 numbers of soak dry cycles as per ISO standard. Accordingly, the paving blocks subjected to soak dry cycles were tested for tensile split-in strength, and strength reduction was used to estimate soak dry performance criteria. According to standard, it should be greater than 7.75. These 3 mixes also satisfied that requirement. When we consider the conventional cement-based paving blocks, it is also 0.88. There is no significant difference of durability comparative to conventional concrete paving blocks in this development. During the soak dry performance, we observed the thermal comfort of this paving block. Based on that, we measure thermal conductivity of fiber reinforced paving block with the use of guarded hot plate apparatus. Accordingly, thermal conductivity of fiber reinforced paving block was estimated as 0.0175 watts per meter Kelvin. That value of conventional concrete paving block was 0.1259 watts per meter Kelvin. Accordingly, this development reduced thermal conductivity approximately by 84%. As a field application, we laid this developed fiber reinforced paving block on jogging track located at Panagoda Army Camp. Let's see a small video clip on that.
Actually, this is a very interesting, innovative research development for the sports field. As an athlete, we are expecting more effectiveness of energy use while running on a safe surface. So running on this surface is more comfortable for my joint, and I feel less tiredness when I running on this surface. The other thing is this surface has better grip than the other surface such as ground and grass tracks. So I think this development is a productive surface for the sport field.
Accordingly, we can conclude that paving blocks can cast by incorporating 26% of fabric pieces, 25% of manufactured sand and 49% of cement by volume with the use of admixture while satisfying the requirements specified in SLS and VSEN standard. As significant properties, this paving blocks has the ability to absorb impact energy, which gives better foot comfort. Water infiltration capability of the fabric embedded paving blocks leading to alleviate surface runoff while recharging underground water sources. Improved thermal comfort of fabric embedded paving blocks facilitate better foot comfort on sunny days. Based on the novelty of this development, we obtained patent under Intellectual Property Act of Sri Lanka in 2022. Thank you.
The next presentation is by EGHDP Illegama on development of ISO standards sand from local silica sand deposits for cement testing.
Good afternoon all. I am Allegama. This study was conducted under supervision of Professor Nanakkara and SSK Muthuratna. So I am going to present my presentation on development of ISO standard sand from local silica deposit for cement testing. When we go to the content, I going to present initially in introduction, then methodology, after then test result and discussion, after conclusion. So when we go to the problem identification, as you know, when economic crisis happened in Sri Lanka, government took many regulations to ban imported material to imported to country. So many testing institutions and the cement manufacturer face lot of problem to conduct their testings due to they have to imported these important material to conduct their testing. So standard sand is this kind of product used for the testing in their laboratories. So they face too many problems to purchase this material from different foreign countries. So MBRO received request from SLS to investigate possibility to produce this material, standard sand, from using the suitable local resources in Sri Lanka to cater the demand of this product. So when we go to the cement testing, two main properties mentioned on the test standard as mechanical properties and the chemical properties. When we go to the mechanical properties, they mention on four main mechanical properties as standard strength, early strength, and the initial setting time and soundness. When we go to the chemical properties, they mention on magnesia content, sulfate content, chloride content, and insoluble residue and loss on ignition.
When we go to the mechanical properties, main important parameter is the strength. Two strength parameters are indicated. This is standard early strength and standard strength. They are differ from the curing of the sample. When we prepare the sample for this testing, we should prepare the mortar sample. Mortar preparation sample is prepared with combining cement, distilled water and standard sand. This standard sand used based on our research study. So we initially conduct the market survey on standard sand. According to the market survey, we conduct this survey under cement for main cement manufacturers and main testing laboratory in Sri Lanka. According to the market survey, we identify around 40,000 packets were used in Sri Lanka in 2021, and its cost around 28 million. This material mainly imported from the France, Germany and China. After that, we conduct awareness program with SLSI and cement manufacturers to present our research study and take their idea and their problem on this material. So according to the literature survey, the requirement for the standard sand were given in ISO 679, called as method of testing determination of strength. In clause number 5.13, mainly mention of two properties as particle size distribution and moisture content. Requirements are given in these tables for the particle size distribution for each square mesh sizes, and moisture content should be less than 0.2%. According to the methodology, we initially conduct the preliminary study on standard sand, and we conduct testing on imported standard sand, and then we investigate the local sources. We find local sources and check their suitability for our production. After we initiate the local standard sand production, and we conduct many testing on the locally prepared standard sand with the imported standard sand. So initially we conduct these preliminary studies on the imported material. Particle size distribution, particle shape, weight content are the parameters we tested in our study. So according to the testing of imported material, particle size distribution are lie within the ISO 679 limitation, but some variation in ISO, some variation in source 2 in the CU size 1.7, which not in the our limitation. Weight content is around 37 to 39%, and particle shape is around rounded. And when we consider on the mineralogical composition, quartz is a main component of these materials. So when we investigate the local source, we mainly consider on the mineralogical composition of the material. So we conduct the XRD analysis. We identify the main mineralogical composition of the standard sand is a quartz, and we took the main quartz percentage material in Sri Lanka for our study. Silica sand and quartz powder are the main quartz content material in the Sri Lanka. So we conduct the XRD analysis on this material also, and we identify the quartz percentage of these local material more than the imported material. So we conduct our study on this silica sand and quartz powder. So this is the standard sand production. So initially we purchased the raw material, silica sand and quartz powder. Before saving process, silica sand is going through several processes, because silica sand dip on the land and there are so many impurities in the silica sand. So we have to remove the dust and wash them thoroughly to remove the mud. After then we conduct the sieving on these two sources. After the sieving, we vein in these materials, and after packing, and we conduct the order processing. So according to the test result and discussion, we conduct testing our locally produced sample with the imported material. Initially void content, according to void content, is found to be 34% 37, and it's not significantly differ from the imported material. And we conduct 28 days comparative test result with 10 sample from our manufacturer one and the imported one. According to the test result, the variation of average strength test result is less than 5%. So we conduct many testing on this material. We conduct 28 days compressive test result of imported material. According to the imported material, we obtain different variation on the test result of 3 sources, and we prepared the, our local manufactured sand with lie within the particle size distribution to each imported one. However, there are significant variations observed this test also. After we conduct the interlaboratory comparison test for our local manufactured standard sand, we select 6 laboratories, including 4 accredited laboratories, and we select 3 cement types: ordinary Portland cement, blended hydraulic cement, and Portland composite cement. And we prepared 6 sand sample. We conduct 2-day and 20-day compressive strength. These are the test results: 2-day and 20-day compressive strength. According to the Z score analysis, the variation level between laboratory is at a satisfactory level. So according to the conclusion, it was observed that there is a considerable effect on the particle size distribution on imported sand to the compressive strength of the selected one cement brand. Even their particle size distribution lie with the limitation given in ISO 679. Another conclusion is even the particle size distribution are same on both sources. There was a variation in the strength test results also. This happened due to the particle characteristic of each source, such as particle shape, texture, such things. So according to the interlaboratory test result of the different cement sample under the control condition, and the Z score test result are in a satisfactory level. So according to the final conclusion, the manufacture process of standard sand should be done under relevant quality control procedure and certification process for the production and the quality. So thank you.
Presentation is by VGD Gangani on roadside slope risk assessment in Sri Lanka.
Good afternoon. I am VGD Gangani from National Building Research Organization. Today I am presenting the research study on roadside slope risk assessment in Sri Lanka, supervised by Professor S. Kulatilaka. Here is the content of my presentation. I am moving on to the introduction. Sri Lanka has achieved a remarkable growth in the road sector in past few years through expanding the existing highway network and also constructing new expressway system in Sri Lanka. So as a result, more cut and fill slopes are created along the road network. In Sri Lanka, large-scale road development projects like expressway construction are done considering the long-term stability of the road cuts and fill slopes. But most road widening projects are done without paying due attention to the long-term stability of the road cuts and fills. As a result, considerable number of road slope failures are reported around the country. As you can see from this figure, these are some recent failures which were reported around the country. There are many consequences of such roadside slope failures, like road closure, property losses, life losses, and social, economical, and also environmental impacts. According to the current practice in Sri Lanka, slope risk assessments are carried out after such failure event, and subsequently risk mitigation, design, and construction are carried out considering only that particular failure location. But from this study, we are focusing on identified slopes with potential failure at the early stages of road construction and implementing site-specific risk reduction measures during construction in order to avoid future failures and such consequences. Accordingly, the primary objective of this research is developing a tool that can be used to assess the level of risk associated with roadside slopes. For that, we are maintaining a checklist with a scoring system which will be a compatible tool and have a simple and uncomplicated scoring system which will give a straightforward result. This is the methodology followed in this research. First, literature review, developing the checklist, and then the verification and modification of the developed checklist using field data. Stability analysis for selected model site in order to verify the results obtained from the checklist, and finally preparing a guideline for road slope risk assessment for general practice in Sri Lanka. Let me move on to the literature review. There are several checklists and scoring systems practiced in other countries. This one is from New South Wales, Australia. It is called the slope attribute score. This score is calculated by assessing these pointed parameters and giving some scores to those parameters. And similarly, this one is developed in South Korea, which is called the slope instability index for rock slope evaluation. Similarly, in this checklist also 12 parameters are assessed and scores are assigned for each parameter in order to come up with the slope instability index. This one is a rating system for assessing rockfall hazard developed by the Federal Highway Administration, USA. From this one also, they are assessing some similar features of the slope and assigning an exponential scoring system in order to come up with the rockfall hazard. After studying this checklist in literature, we have understood that the available checklists do not give acceptable results for Sri Lankan slope failures, because Sri Lankan slope failures are having special features like almost all the Sri Lankan slope failures are induced from rainfall, and also we have highly heterogeneous soils in Sri Lanka due to the metamorphic rock formation. And also high amount of colluvial soils are present in Sri Lanka. Also, we have encountered highly contrasting strengths and permeabilities in the rock slope boundaries. So there is a necessity to develop new checklist incorporating all these specific aspects to obtain acceptable result for the Sri Lankan slope failures. The disaster risk equation was used as the basic concept for the development of the checklist. In this equation, hazard, vulnerability, and capacity are incorporated in order to calculate a risk level. But in this study, we took the capacity as a constant, because the capacity of relevant organizations to reduce the road slope risk remains a constant for all road slopes. So a simplified version of this equation was used for the study. This is the developed checklist. First section of the checklist is location, collecting location details. It is incorporating the date of assignment, location ID, road name, road category, chainage, GPS locations. Likewise, we gather the location details and then field sketches. We are drawing some sketches at the field by observing the physical parameters like slope height, slope angles, failure boundary, length of the failure, etc. These are some sample field sketches that we can draw during the observation. And next part of this checklist is failure category. We are categorizing failure into 3 categories. First one is landslide and slope failures. Second one is slope cutting failures. Third one is rock slope failures. For the assessment of landslide and slope stability, there is a already developed checklist in NBRO, practiced by NBRO. So under this study, we are preparing a checklist for assessing soil cut slope failures and rock slope failures. These are the 3 types of failure categories. And next part of this assessment is hazard assessment. Under that, we are assessing these parameters thoroughly. Failure type, material properties, slope geometry, water condition, and any special features. And for the rock slope stability, the condition of the rock discontinuities are thoroughly assessed, and a hazard score and a level is assigned at this point. The next section is vulnerability assessment. Under this assessment, we are identifying the elements at risk and then categorize them into 3 categories: critical elements, moderate critical elements, and non-critical elements, and then separate scores are allocated for those categories as well. Under next section, we are assessing the risk by using the obtained scores of hazard and vulnerability from the previous sections, and assigning a risk value and also a risk category according to these tentative scores. The next part of this research was to apply the developed checklist to a selected model site. So we selected Kegol-Bolat-Kopiti Road for this assessment, and 30 locations were identified for this study, as you can see from these maps. And here I am presenting a sample checklist where we assess one location from the Kegol-Bolat-Kopiti Road. You can see some photograph of this location, and this is the complete checklist filled for that location. Since it is not clear, I am going part by part. First section is soil parameters. Soil properties are assessed with under several aspects, and a separate score is given for that. And also next one is slope geometry. We are assessing slope angles, slope heights, and assigning some scores for that also. Similarly, water condition and infiltration potential is assessed, and then special features are assessed, and hazard score is calculated based on those 4 sections, and we are assigning a hazard level, whether it is a low hazard location, medium hazard location, or a high hazard location. Then we are moving on to the vulnerability assessment. As I mentioned earlier, we are assessing the elements at risk and categorizing them into 3 categories and giving a separate score for that also. Then the risk factor is calculated based on the previously calculated scores, and the risk is also categorized as low, medium, or high. In this checklist, we are providing some final part for the proposed mitigation concepts as well. This is a summary of the study conducted in the Kegol-Bolat-Kopiti Road. You can see some the failure risk categories and some photographs as well. Moving on to the way forward, this developed checklist gives an acceptable result for the assessed road segment, but
This is a draft for the moment, so we have to apply it for more locations with different terrain conditions and geological formations to refine and update this one. So the verification of the result obtained from the checklist will be done using rainfall data and also slope stability analysis. These are some references I used. With that, I'm concluding the presentation. Thank you.
Good afternoon to you all. My name is Milind Amarasinghe, and my research is on validation of rain-induced landslides, landslide failure on unsaturated colluvium slopes. And this is a case study supervised by Professor Athra Kulathilaka. So this is the content of my today's presentation. So landslides can be considered as one of the most frequent natural hazards that affect the human lives, property, and the economy of a country. So landslides can be generally described as a mass movement of rocks, soil, or debris under the impact of gravity and the landform resulting from such movements. More than 90% of the landslides throughout the world are triggered by rainfall, and Sri Lanka has been identified as a hotspot for these rain-induced landslides. And Sri Lanka is ranked at number 4 in the list of number of landslides per 1,000 square kilometers. The central highland area of the country is highly susceptible to landslides, considering the elevation range, slope angle, and the heavy rainfalls received in this area. And 30% of the total population live in these areas, which cover about 20% of the total land area of the country. Often, the slopes in the highland area are unsaturated, where the groundwater table is well below the surface and weathering is predominant. The failure of landslide occurs due to the infiltration of rainwater to the subsurface and subsequent loss of matrix suction due to the increase in water pressures. The previously failed soil or rock fragments may get transported and accumulated at the toe area of the soil slope. So we call these accumulated soils as colluvial soils, which composed of soils, debris, and debris. So reactivation of landslides in colluvial deposits are a common incident, considering the looseness of the soil, low shear strength, and heterogeneity. So it is difficult to predict the landslide triggering mechanism and rainfall threshold in colluviums. So limited studies have been conducted on failure of landslides in unsaturated colluvial soils. Therefore, it is vital to study the possibility of predicting failure in colluvium layers for hazard assessment and early warning. So with that, aims and objectives have been formulated. So the aim of this research is to validate the slope failure with infiltration using commonly used techniques to evaluate the suitability for practical use in landslide prediction in colluvium. The first objective is to select 2 sites with slide type failure initiated due to rainfall and conduct a comprehensive assessment of geological and hydrological characteristics of the site. Then to develop numerical models to evaluate the infiltration and seepage for the critical slopes, conduct slope stability assessment using limit equilibrium and finite element methods with the water pressures from the finite element infiltration models, and final to validate and compare the results of the slope stability analysis with the failure event. With that objectives, we have formulated the methodology. First, an extensive literature review is to be conducted. Then the sites will be selected based on presence of colluvial layers and rain-induced landslides. Then the samples have to be samples were collected, and the material properties were tested using laboratory experiments. Then using geoslope stability analysis and Flaxis 2D stability analysis, the analysis were conducted, and finally validation and comparison of the results was conducted. So the 2 selected sites are Kitulgala landslide site in Kegol district and the Sobasirupura landslide site in Colombo district, Avissaville. So these sites are located close to the boundary between Vanni complex and the Highland complex geological zones, which are composed of interbanded metamorphic rocks. according to the 1:50,000 landslide hazard zonation map of prepared by NBRO, the Kitulkala landslide area has been identified as an area with modest level of landslide hazard, and the Sobasirpura area has been identified as landslides are to be expected. So with that, this shows the Kitulkala landslide area survey plan and the cross section and some locations showing you how we identified the failure, and the failure has occurred on 15th May 2016. We conducted borehole investigations during that period, and the subsurface can be idealized with 3 main layers. At the top, a colluvium, and then a completely weathered rock layer and a highly fractured bedrock layer. So the next side, the Sobasirupura landslide plan view, and this section is shown here with some features. And here also, with the borehole investigations, we have idealized the subsurface with 3 main layers, similar to previous one. And these tests were conducted using box samples collected from the colluvium layer. So these are the test results for the Kitulgala landslide area, and the soil type has been identified as the silty sand type soil. And for the Sobasirupura site, at the top area it was a silty sand, and at the bottom area it was a silty gravel. So in modeling, I have used 2 softwares usually used in geotechnical engineering assessment, geotechnical slope assessments, the GeoSlope software package and the Plaxit software package. So in GeoSlope software package, the infiltration analysis is conducted using the CEPW model, CEPW software, and we can use the infiltration results for the slope W analysis to calculate the factor of safety using limit equilibrium method. In Plaxis 2D, we can directly calculate the infiltration seepages using finite element method, and the using shear strength reduction method, the factor of safety can be calculated. So since we are considering the unsaturated soils, we need to understand the unsaturated soil mechanics. So the transient seepage conditions in unsaturated soils can be expressed using the Richards equation as shown here. So here the coefficient of permeability Kx, Ky, and the volumetric water content are highly nonlinear and depends on the matrix suction. So we need to identify the relationship between the matrix suction and these parameters. So we have to define the hydraulic conductivity function and soil water characteristic curve. So for the soil water characteristic curve determination, we use the there are different empirical equations, but the most commonly used one is Van Guchen method, and software is allowed to use this one as well. So we use this Van Guchen method for the volumetric water content determination, and with that and the saturated coefficient of permeability, we can obtain the hydraulic conductivity function. So these are the experimental results for the soil water characteristic curve determination conducted using the water potential meter. And the fitting of the soil water characteristic curve and the hydraulic conductivity function using Van Guchen method is shown here. And the unsaturated shear strength equation used in the is the extended column failure criterion, and here it's highly nonlinear, and the Vanapalli et al. 1996 method is used to derive the equation for the shear strength of soil. So these are the parameters used in the models for the saturated and unsaturated soil parameters and the shear strength parameters for the 2 sites selected. And let's look at the infiltration model for the Kitulgala landslide. So this is the model used with the finite element mesh, and the boundary conditions have to be defined, and at the surface an infiltration boundary with potential seepage review phase has been defined with the rainfall conditions. So here for the both sides we have considered 10-day rainfall before the failure, and we observed that with the rainfall conditions provided, the factor of safety was less than 1 on day 10, which indicates the failure at the toe area of the slope. And with in geoslope analysis, it gave us results where the failure surface extends towards the crown area with the rainfall in the preceding days. So when it comes to the Plexus 2D analysis results, it also shows that at the toe area of the slope, the failure occurs on day 10. And this is the summary of the results for the Kitulgala landslide site, where you can see on 10th day, the factor of safety is less than 1. And you can see that in Plexus 2D software, using the finite element method, the factor of safety is more sensitive compared to the geoslope software when considering with the rainfall, when comparing with the rainfall. So this is the infiltration model for the geoslope software for the subarachnoidal landslide, similar to the previous case. And these are the results for that case study. So here also we observed that the slip surface, the critical one, is consistent with the field condition, and a similar slip surface has been, critical slip surface has been observed in the Plexus 2D analysis as well. So when the results are compared, so the sensitivity has been identified in the Plexus 2D one, and the factor of safety was less than 1 on day 10. So finally, let's get the conclusion. So from the geoslope analysis for the Kitulgala landslide, with 10 days antecedent rainfall event, it was evident that the failure occurs on the 10th day, which is the failure date of the landslide. And it confirms the temporal probability of failure. And these slip surfaces were observed to be consistent with the field slip surface in using geoslope analysis, which satisfies the spatial probability of landslide. And however, only the critical failure surface can be identified using the finite element method. Therefore, the initial failure at the toe area was identified for the Kitulgala landslide using Plexus 2D software. However, for the subarachnoidal landslide, both geoslope and Plexus 2D softwares gave the critical slip surfaces consistent with the actual case, and it was evident that the failure in colluvium soil slopes can be modeled using the commonly available techniques such as the limit equilibrium and finite element methods with point-wise data for slopes, considering homogeneous soil properties for the layers, although the colluvial is highly heterogeneous. This can be used in hazard zonation to identify the triggering rainfall and the spatial area of landslides for the critical slopes in future. Thank you.
So I kindly request the presenters to come to the front. So it's up for questions now. We are short of this. We have only about 5 minutes for the questions. So please pose your questions quickly to the presenters. Thank you.
For the first presenter, there is a comment that I would like to give you. Whenever you work with the spandex waste fabric, what is most important is the acer dyes, so we call reactive and non-reactive dyes, which can leach out very easily under the influence of UV radiation when you go for outdoor sports activities. So therefore it would be good if you can do what you call this leachability study test, which will give you an idea whether these acer dyes could be easily leached out or not. Okay. No, I don't need an answer, but have you done anything on that?
No, sir. In paving block, it is fabric pieces totally covered by cement paste, not exposed to the atmosphere. Yeah. So it is not directly exposed to the UV light during the application.
There is no much difference. So I can remember Dr. Asiri, his presentation. Once the slides happen, the balance part or the leftover sections can be strengthened, or can be you need some chemical stabilization or something. So have you considered that part, that concept in your research? Because that is very, according to I observed it, it's very, very important, and it's actually a very good method rather than going for structures or the other things, because this area, the population is staggered, much damage would be for the moving traffic or the infrastructure. So if you stabilize that balance sections, I think that is a very good thing, and it's a very great thing for the area and the country. So research has to be done accordingly. So I just wanted to know whether you have considered that concept in your design, in your research.
Actually, this assessment is done for the conditions before failures. I think, as I understand, what you are referring is the mitigation part after the failures. For this risk assessment is basically focusing the condition before failures, I mean the potential failure sites. So the mitigation part is not actually much considered in this assessment. It is the actually next step of this process. First we identify the risk levels, and then we categorize in the risk levels based on the risk and hazard categorization. Then only we go for the mitigation. So in that part, the mitigation part, actually the consideration for your suggestion is taken during that mitigation.
Okay, thank you very much. Since we are running out of the time, so we wish to conclude this session at this time. And thank you very much for these excellent 4 presenters. And ladies and gentlemen, give them another round of applause. Thank you.
Thank you all for the remarkable and captivating presentation session. Let us now recognize the commitment and achievements of the presenters of the technical session who presented their key findings with us. For that, I hereby invite the session chairs, Professor Arthula Kulatilaka and Professor Mahesh Jayavira, to present the certificates to our presenters.
Development of fiber reinforced paving block for outdoor sport surfaces by G.K.B.M. Gannoruwa. Development of ISO standard sand from local silica sand deposits for cement testing by E.G.H.D.B. Allegam. Roadside slope risk assessment in Sri Lanka by V.G.D. Gangani. Validation of rain-induced failure of unsaturated colluvium slopes, a case study by M.P. Amarasinghe. Thank you very much, sir, for joining us for the awarding of certificates.
Ladies and gentlemen, that brings us to the conclusion of the morning session of the Civil Engineering Research Symposium 2023. We will be commencing the afternoon session sharp at 2:15. I would please encourage you to be back in your seats by the time. In case you have missed it, you can download today's proceedings and the book of abstract by scanning the QR code at the entrance of the auditorium, and you can give your feedbacks as well. And I would like to again kindly invite all the distinguished guests and academic staff members to proceed to the upper floor lobby of the department, while the undergraduates and postgraduate students are kindly requested to proceed to the ground floor front lobby. Thank you very much and enjoy your lunch.
140 years in, and we continue to fill the world with color. Our innovation has sparked opportunities and brightened lives. It all starts with groundbreaking research at our world-leading facilities and the synergy of our diverse Nippon Paint Asia family. We're proud of how we have worked hand in hand to emerge as Asia's #1 paint and coatings manufacturer. Through it all, we have fulfilled our brand promise.
Civil engineers
To
are
innovate with
essential
heart
in protecting and enhancing the natural
celebrate our
environment
people,
while ensuring
the
that
beating
the
heart of
society's needs are
everything we
met.
do. So we
Scientific
empower them
principles were applied
with the
by
skills
the
they need
ancestors,
to truly
which
soar.
supported to drive off engineering towards modern
and we
innovation
envision a
and
future
research.
where people and the
Civil
planet
engineering
can thrive
is the application
together.
of physical and scientific principles
dream
for the
big.
design, development
And in
and
bold
maintenance
technicolor.
of both constructed and naturally built
So we go
environment.
beyond producing coatings.
As civil engineers, we are going to
light
be
up
in a
as many
position to
lives
change
as
the
we
world,
can.
not just to study it.
Our coatings
we have to
have
think about
transformed
real
motor
problems
vehicles
and how to
all
address
over
those.
the region.
As an
And they keep
example,
industrial
on 6th of
powerhouses
February,
running smoothly
Turkey
and
and Syria
efficiently.
have been severely hit by a
And provide
7.8 magnitude
environmentally
earthquake.
responsible
The
protection
combined death
for
toll for
maritime
these two
vessels.
regions was more than 41,000,
Durable
which was
and
being
weather
recorded
resistant.
as one of the
They
deadliest
help
disasters
architects
this
and
century.
developers bring their visions to
What
life.
was the reason? The seismic
We
design
innovate
codes
ahead of
have
the game
only been developed
with
in
products
recent
that
decades
protect
for
us
the
in
regions.
today's new normal
Therefore,
and
all the
lay the
infrastructures
foundations for a
those
safer
had
future.
not.
We also give our consumers more than paint, offering them design services that truly turn a house into a home. We are Nippon Paint. We harness the brilliance of innovation because we
are inspired by you.
"140 years in, and we continue to fill the world with color. Our innovation has sparked opportunities and brightened lives. It all starts with groundbreaking research at our world-leading facilities and the synergy of our diverse Nippon Paint Asia family. We're proud of how we have worked hand in hand to emerge as Asia's #1 paint and coatings manufacturer. Through it all, we have fulfilled our brand promise to innovate with heart and celebrate our people, the beating heart of everything we do. So we empower them with the skills they need to truly soar. And we envision a future where people and the planet can thrive together. We dream big and in bold technicolor. So we go beyond producing coatings to light up as many lives as we can. Our coatings have transformed motor vehicles all over the region, and they keep industrial powerhouses running smoothly and efficiently, and provide environmentally responsible protection for maritime vessels. Durable and weather resistant, they help architects and developers bring their visions to life. We innovate ahead of the game with products that protect us in today's new normal and lay the foundations for a safer future. We also give our consumers more than paint, offering them design services that truly turn a house into a home. We are Nippon Paint. We harness the brilliance of innovation because we
are inspired by you.
ELS is a group of companies that contributes to the engineering and construction industry in Sri Lanka and overseas by diversifying its services in numerous specialized fields in the construction sector. ELS has proven its quality concern by achieving the ISO 9001:2015 and ISO 14001:2015 certified organization graded by CEDA as C1 in heavy construction, C2 in bridges, C3 in marine construction, GPP in piling and SP1 in soil nailing. Ever since its establishment in 1991, the company has catered to the increasing demand from the local and international construction contractors and consultants in various spheres in construction. The group specializes in environmental construction and disaster prevention, geotechnical instrumentation and monitoring, highway and marine infrastructure, geotechnical investigation and laboratory testing, piling on and offshore, over 200 precast and pre-stressed concrete products, and leisure sector. Today, the company has extended its services to corporate social responsibility by initiating a kidney disease prevention center in Kandy. ELS providing advanced solutions for complex problems.
Manage information. Civil engineering has entered the digital age with the initiation of innovation, collaboration, efficiency, and engagement. Artificial intelligence, augmented reality, building information management, drones, smart sensors, and mobile technology are the approaches to industrial digitalization. MAS intimates thoroughly. MAS intimates thoroughly is a visionary departure from the standard factory, which is the world's first clothing factory fueled solely by carbon-neutral sources. Its carbon footprint is assessed to be 9 tons per year, being one of the lowest worldwide. Thoroughly is a LEED Platinum rating building that stands tall as a symbol of innovation and sustainability in the hearts of a tropical paradise. One of the standout features of Thoroughly is its cutting-edge evaporative cooling system, which creates a thermal comfort zone using minimal energy. The structure delivers 40% saving in energy and 50% in water compared to other factory models. This impressive project was brought to life by the combined effort of MAS Holdings with Marga Engineering Private Limited at the helm as the main contractor. What's more, Thoroughly was conceived and designed with the help of top academics from our esteemed Department of Civil Engineering. Clearpoint Residencies. Clearpoint Residencies warmly welcome the future of high-rise living with minimum carbon footprint and lower maintenance cost, most significantly a product of innovative architectural design and cutting-edge technology. The design offers sophisticated urban living in a calm countryside setting. The green covering surrounding the entire building offers a calm atmosphere through its soundproofing nature and lessens the burden of air conditioning. Cross-ventilation mechanism is adopted to maintain indoor cooling. Rainwater harvesting is another appealing element combined with recycled grey water for sanitization and automated drip systems. Thus, it reduces water usage by 45%. With the intervention of our department, inhabiting this living tower would be more cost-effective in Sri Lanka. The Lotus Tower. Lotus Tower stands tall at a height of 356 meters, making it the tallest tower in South Asia and the 11th tallest tower in the world. The tower's design and construction were carried out by the China National Electronics Import and Export Corporation. This is a landmark structure in Sri Lanka that our department has been involved in. The construction of this marvel was not an easy feat. The tower's foundation is 20 meters deep and has been reinforced with 200 steel piles, each weighing around 20 tons. The tower was constructed using a self-climbing formwork system which allowed workers to climb up the tower and pour concrete at every level. It stands as a true marvel of civil engineering, attracting visitors from all over the world who come to marvel at its beauty and engineering ingenuity. Colombo Light Rail Transit. As the bustling city of Colombo continues to grow, so do the challenges of mobility and traffic congestion. The Colombo Light Rail Transit project is a transformative initiative aimed at tackling these issues and enhancing transportation options for the city residents. With 16 stations and a total span of 16 kilometers, this elevated rail system will connect key commercial, administrative and residential areas of the city, providing a quick, efficient and an environmentally friendly mode of transportation for over 14,000 persons per hour per direction, anticipated daily passengers during peak hours. This crucial infrastructure investment, which is being executed in collaboration with the Japanese International Cooperation Agency and the Sri Lankan government, has an estimated cost of $2.2 billion. Its completion is expected to not only improve mobility and reduce traffic congestion, but also boost economic growth and improve the overall quality of life of the people of Colombo. Flood refugee space. Sri Lanka is a country that faces frequent flooding with disastrous consequences. In response, disaster-resilient buildings have become essential, but designing an entire structure to withstand such events can be financially, temporally, and aesthetically challenging. That's where fully disaster-resistant rooms, also known as refugee spaces, come in as a cost-effective and easily integrated solution into the design. These rooms provide crucial facilities such as sanitation, storage, and kitchens, and can offer refuge spaces during extreme floods. They are also accessible from the roof level, which is cyclone-resistant and non-lightning attractive. This collaborative project involving the University of Moratuwa, the University of Bath, and the National Building Research Organisation of Sri Lanka is a prime example of successful national-level efforts to address this issue. Altair Building, a high-rise tower located in the heart of Colombo, Sri Lanka. The structural design of this building is a marvel of modern engineering. Featuring a reinforced concrete core and perimeter frame, the building also boasts a steel mega frame at its crown. This mega frame not only provides lateral support to the upper portion of the building, but also serves as a stunning architectural feature. To support the weight of the building, a raft slab foundation is used, supported by piles to distribute the weight evenly across the ground. The Altair building can withstand the forces of wind and earthquakes while also providing a unique and striking appearance. Rectification of the Ginigathena landslide. Sri Lanka is a country with a picturesque landscape and an extensive road and railway network. However, our engineers face a considerable challenge in mitigating landslides in the transport network, and sloping grounds in the country are formed of different rock types, making them susceptible to landslides, triggering an excessive rainfall. One such example of how Sri Lankan engineers rectified the Ginigathena landslide, which occurred due to an unplanned excavation to widen the road. The marsh area at the top was a primary concern, and Sri Lankan engineers lowered the groundwater levels by using surface and subsurface drains. The engineers used SeepW and SlopeW softwares for numerical analysis to ensure the slope stability after completion of all rectification. As the famous engineer Theodore von Karman once said, "Scientists study the world as it is. Engineers create the world that has never been." Welcome to the Department of Civil Engineering at the prestigious University of Moratuwa, which is one of the premier civil engineering departments in Sri Lanka, with a long history since 1972, where we produced more than 4,000 top-notch civil engineers to the world of work. Our vision is to be a center of excellence of higher learning, research and related activities with emphasis on national relevance, international recognition, innovation, and creativity in civil engineering. Our mission is to develop educational programs that provide educational, research, and professional experience that enables our graduates to become leaders in their professional careers, to pursue excellence in research, and to serve the profession, community, and the nation, and be competitive in the international arena. The Department of Civil Engineering boasts a sprawling complex that is teeming with state-of-the-art facilities designed to give students the tools and the resources they need to succeed. The department is housed in its own building complex at a picturesque site bordering the northeastern boundary of the university, fringed by the Bolgoda Lake. The Civil Engineering Building Complex has many features of civil engineering design and construction and consists of a total built area of nearly 8,000 square meters. The department complex is comprised of the main building, Civil Engineering Research Center, UNESCO Madanjit Singh Center of South Asia Water Management, Rock Mechanics Laboratory, and Pavement Research Building as the main components.
Welcome to the Department of Civil Engineering, University of Moratuwa. As you embark on this new journey, I would like to share some words of encouragement and inspiration as the head Department of Civil Engineering, University of Moratuwa. Civil engineering is a field that has the power to shape the world and improve the lives of people. As you can see, the bare land will be converted into usable cities. Unplanned cities will be converted into planned and greener cities. The most important resource in the planet, water. Who figures out water flowing from point A to point B? That would be civil engineers, whose job is to design, create, and build new, better infrastructure. That would be civil engineers. Buildings are the largest contributors to greenhouse gases. Who has the power to make better buildings, more efficient buildings? That would be civil engineers. What is required for us to enjoy cities full of self-driving cars with fewer accidents, less traffic? That is traffic engineering. It's a branch of civil engineering. Urbanization means we have less land on which to build, so we must go taller. Who designs tall buildings? That's smart civil engineers. To have a smart planet, we need smart cities, which require smart buildings. Who builds smart buildings? Smart civil engineers. So what do we do in the department? We have a good set of infrastructure and wealth of knowledge with well-qualified academic staff who obtain their PhDs and other postgraduate qualifications from top-level universities all over the world. And our degree is accredited by Washington Accord, which is a multilateral agreement on mobility of professional engineers. So we are fully accredited by Washington Accord through Institution of Engineers Sri Lanka. Our course is externally reviewed by a professor of University of Cambridge, United Kingdom. And we do have a well-balanced academic study program with 8 semesters, a sound industrial training program, field visits, survey camp, and state-of-the-art research reviewed by the industry. And not only that, we do have social programs and the career guidance and outbound programs. As you embark on your journey as civil engineering undergraduates, I encourage you to take the maximum advantage of all opportunities, both inside and outside the classroom. Embrace the challenges, learn from your mistakes, and never stop asking questions. So I have no doubt that with hard work, determination, and a passion for making the world a better place, you will go on to achieve great things and make significant contributions to the field of civil engineering. Welcome to the start of an exciting and rewarding journey. Thank you very much.
Starting college can be a daunting experience, especially if you're studying civil engineering. But don't worry, your degree can open up a world of possibilities. Are you worried that our civil engineering degree might limit your options? Think again. Some of our graduates have gone on to lead the teams that design and build the infrastructure that keeps our world moving.
Hi, I'm Chartered Engineer Samita Jayakoti. I have passed out from the University of Moratuwa with the first class honours in civil engineering. From the very inception, I embarked upon to the construction industry as a project engineer, that is at ICC. And at the moment, I render my services as a director at RDC, the oldest consultancy group in Sri Lanka in engineering. And I have contributed to more than 15 major projects as a team leader. Despite the temporary economic downturn, the civil engineers generally have ample job opportunities all over the globe. Today, the almighty answer is that we must seek the blue ocean strategy in exploring any sort of opportunities in all scales. So my advice to all the undergraduates is to take the fullest advantage of your much privileged free education system.
Hi, everyone. Greetings from Sydney. I'm Samit Gunasekara, and I'm a senior principal and a project director at Tetra Tech Coffee. Tetra Tech is one of the largest engineering consultancies in the world. I obtained my civil engineering degree from University of Moratuwa in 1987, and within 6 months of graduation, I had many offers from universities in Canada and the US to go and over there and study civil engineering. I believe the main reason why I got these offers with full funding to study for master's degrees was because the strength of the civil engineering degree that I obtained from University of Moratuwa. I'm very grateful for the decision I took to study civil engineering at Moratuwa, as it set me up well professionally and in life. I'm confident that those undergraduates who choose to study civil engineering will benefit the same way I did. I wish you all the best.
I graduated from the Department of Civil Engineering at University of Moratuwa in 1997 with first class honours. After gaining 2 years of industrial experience in structural design and constructions, I received prestigious IPRS scholarships from Australian government to pursue PhD and successfully completed my PhD in 2003. I joined Robert Bird Group in 2007, which is one of the leading structural consultancy firms for high-rise buildings in the world. Since then, I have led teams carrying out analysis and design for a number of iconic buildings projects in Australia and overseas, including Dubai, Malaysia, and United Kingdom. In fact, I had greatest privilege of being part of designing team of the second tallest building in the world, which is 118-story building, which is called Merdeka 118 in Malaysia, and also Sydney's tallest building, which is 72-story building for Crown Resort and Casino. My undergraduate training I got from Department of Civil Engineering at University of Moratuwa gave me the confidence to design these buildings. I believe Department of Civil Engineering at University of Moratuwa is one of the best in the world with highly qualified lecturers, and their guidance helped me to achieve my career aspirations.
Hello everyone, I'm Narmada Amarasinghe, currently employed as a Senior Design Engineer at Maga Engineering Private Limited. I graduated in the year of 2015 with a first class honours degree from the Department of Civil Engineering, University of Moratuwa. I was one of the few students to join the industry with a first class degree, while most of my batchmates decided to pursue for higher studies. But I still consider the decision I made at that time to one of the best decisions I have ever made in my career. A first-class degree obtained from the Department of Civil Engineering of University of Moratuwa is highly regarded and respected in the industry. The industry believes that the graduates from Department of Civil Engineering University of Moratuwa to be well equipped with theoretical and analytical knowledge. Even in my career, I found it very easy, and I was awarded with many opportunities also because I was able to integrate the theoretical knowledge very easily with most of the practical applications. Soon after graduation, I joined CECB, Central Engineering Consultancy Bureau, as a design engineer. I was one of the young members to join their design teams, and I was very fortunate because I was involved in many major national scale projects such as the construction of Kaluganga hydropower project, the design review of the Broadlands project, relocation of Mani Market project, and also rectification and rehabilitation of many iconic structures in Sri Lanka. I obtained my charter qualification in the year of 2020, and ever since I have been employed at Maga Engineering as a senior design engineer. Currently at Maga, I am mostly involved in designing of medium-rise to high-rise buildings while leading a team of young design engineers as well. So in my career, I always consider the confidence, the foundation and the knowledge that we obtain from the Department of Civil Engineering, University of Moratuwa to be the backbone of my career. So I take this opportunity to welcome all the young undergraduates to the department, and I wish you all the very best, and I hope to see you all very soon in the industry.
And it's not only in just engineering firms that are looking for your skills. Our graduates have also found success in the world of finance using their knowledge of infrastructure and construction to analyze risk and make better investment decisions. But wait, there's more. The tech industry needs your skills too. Our graduates have used their knowledge of complex systems to design and develop software and hardware solutions for the world's leading tech companies.
I entered the University of Moratuwa 20 years ago in 2003. Today I am a research scientist at a tech company called Autodesk. My job is to invent and implement AI tools that can design things better than humans. I've written software that have produced more efficient designs than even NASA JPL. Climate change is the biggest challenge facing humanity right now. So I'm now focusing on making AI systems that can design more sustainable buildings, use less material, last longer, and are more efficient. I can only do this because of the in-depth knowledge about civil engineering I acquired at the Department of Civil Engineering at Moratuwa.
Hi guys, I'm Mahesh Ramanayak. I'm an executive at IBM. I work for IBM in Australia now, but I joined IBM in Sri Lanka 30 plus years ago. What do I do at IBM? I provide solutions for extremely complex business problems. Now, you might be wondering why I'm talking to you, to a group of civil engineering prospective students about what I do at IBM. Well, the reason is I did civil engineering at University of Moratuwa. Now, the question is, did doing civil engineering at University of Moratuwa help me? Absolutely, right? It gave me a foundation, right, to think in a very, very logical way. The question that comes to my mind all the time is, would I have done civil engineering if I'm given a choice today? Absolutely, I would have done it.
Finally, some of our graduates have gone on to become researchers and educators exploring cutting-edge technologies like 3D printing in civil engineering, smart cities, sustainable infrastructure, and advanced materials.
Hello everyone, my name is Asita Ratnayaka and I am a third-year PhD candidate at the Department of Engineering, University of Cambridge. My research is on measuring and improving construction productivity, or the efficiency of utilizing resources such as labor, materials and equipment in delivering construction projects. This is one of the biggest issues facing our industry because compared to industries such as manufacturing, construction has consistently shown low levels of productivity, which leads to the waste of money and time and also high carbon emissions. Because of my passion for civil engineering, I chose the Department of Civil Engineering, and that was one of the best times in my life. We have one of the best panels of lecturers who have studied and worked all over the world. And the Department of Civil Engineering has a very good reputation among the global community of universities, because every year we send a number of students to study for masters and PhDs.
So, as you start your journey in civil engineering, remember that the skills you're learning have the potential to take you anywhere. You can make a difference in civil engineering project management, finance, IT, administration, academia, and beyond. Keep studying hard, and the world will be your oyster. As you have seen previously, the Department of Civil Engineering at University of Moratuwa has involved in many revolutionary activities. With that, you can imagine the extraordinary abilities of our department. The students in the Civil Engineering Department are not only capable in academic and technical activities, but also in teamwork, leadership, and creativity. Civil Engineering Society is the main official body looking after the students' welfare. Civil Engineering Society has done many things for the betterment of both the students and the department, such as running the CERS bookshop, photocopy center, department canteens, and providing financial support for students. In addition, CERS initiated Skill Up with CERS webinar series as a new event in 2021 for students to meet the professionals and discover more along curious topics in the field. Furthermore, CERS organizes the student competitions Spaghetti Bridge competition, the INSEE IESL Concrete Mix Design competition, where the best teams will get the opportunity to compete at the inter-university competitions. In addition to the events, those organized by the CERS, the staff and the students are keen in giving the prominence for the social harmony and strengthening the bond between different cultures. Civil engineering undergraduates are known for their dedication and hard work, but what many people may not realize is that they also have a great sense of humor. From building quirky structures to staging elaborate pranks, these students know how to have fun while still maintaining their focus on academics. In addition to the events shown previously, from here onwards, you can take a closer look at some of the memories of civil engineering students' life. Engineering students' batch trip videos showcase the excitement and unique experiences of traveling with a group of like-minded individuals. If you are looking to explore new destinations, build new friends, or have unique opportunities for personal growth, these batch trip videos will give you the best inspirations. Dear new civil engineering undergraduates, it is with great pleasure and excitement that we welcome you all to the Department of Civil Engineering. You have made a wise choice by embarking on your path, and we are honored to have you join our community of scholars, innovators, and problem solvers. As you begin your journey, we want you to know that we are here to support you every step of your way. You are not just students to us, but part of a family that is passionate about creating a better world through engineering. So, once again, welcome to our family. We look forward to seeing all the amazing things you will achieve in the years to come.
So we will be displaying only one. There were about 7 now. Really? Hello.
Good afternoon, ladies and gentlemen. We request you kindly to be seated. We will be commencing the afternoon session very soon.
A very good afternoon, ladies and gentlemen, and we hope you are very refreshed and well elevated for the final session of the event. Prior to our proceedings, we would like to welcome Emirates Professors, Professor Sohanu Chesekara, Professor L.L. Ratnayaka, and Professor Niranjani Ratnayaka to this special occasion. Research is a journey of dedication, but demonstrating the latest research findings in a creative manner adhering to a given time interval make it much more complex and demanding. The 3-minute thesis challenge was open to both full-time and part-time postgraduate students pursuing research degrees and master's degrees affiliated with the Department of Civil Engineering. Out of the impressive submissions we have received from the enthusiastic postgraduate students, we are thrilled to unveil the best performer who has conquered this challenge with an extraordinary research presentation. Before we announce the winner of the 3-minute thesis challenge, I cordially invite the session co-chairs, Professor Malik Ranasinghe and Professor Lalit Rajpaksha, to the head table, and I invite Professor Lalit Rajpaksha to briefly introduce us on the procedures of the competition and to walk us through the expenditure.
Yeah, very good afternoon to you all, distinguished participants, esteemed guests, and dear colleagues, dear students. Very good afternoon to you all, distinguished guests, esteemed invitees, dear colleagues, and dear students. as it has already been announced, this 3-minute presentation session is itself a challenge, because we know postgraduate study, master's, MPhil or PhD, that continues over a period of 1 year, 2 years, or sometimes up to 3 years or even more. So presenting everything what you have done over a longer period within about 3 minutes itself is a challenge. So if I am going to very briefly tell you how this was started, this is actually linked to water. So in 2006 or 2007, there was a long, very severe drought in the northwestern states of Australia, and then there were water cuts. The water supply authority, they wanted to control how much water the residents are using for their regular bathing. So normally they were used to have 30 minutes, 45 minutes of bathing time. So they introduced a 3-minute time for bathing. So what happened then was residents started using, they call it an egg timer. The small kitchen timer that was used to monitor the boiling of eggs in the kitchen. So they started using these egg timers in the kitchen. So it became a habit later on. So one of the professors who was tired with very long presentations, suddenly he thought that this could be a good idea, so why don't we introduce this to presentations. So that is how it came into practice. So one senior professor in the Queensland University introduced this 3-minute presentation, and now it has become a worldwide practice. So here we invited our postgraduate students to submit their outcome of their research projects compressed into a 3-minute presentation. So we had followed criterion marking scheme that was based on the comprehension and the content. There were 5 criteria, and then the engagement and communication, because the purpose of this 3-minute presentation was to, in the countries like US, Australia, even in Japan, they have a practice because they believe that the students' projects are funded by the government or the public money. So the students are supposed to enlighten the general public what they are doing in their research projects. So main purpose of this 3-minute presentation was to elaborate what they have done within a very short period of 3 minutes, but in a convincible manner, especially to the general public. So it doesn't have to be very technical, but you should cover what you have done. So based on that, we introduced a selection criterion. So based on the comprehension and content, 50 marks were given, and engagement and communication, whether the oration make the audience want to know more, was the presenter careful not to trivialize or generalize this research, and did the presenter capture and maintain the audience attention, and did the speaker maintain a steady pace, and also did the PowerPoint slides enhance the presentation, was it clear, legible and concise. So based on these criteria, we have selected 1 out of the submitted 8 presentations. Now I think we will display it to you.
Introduction to the competition. Hard work beats talent when talent doesn't work hard. But today we witnessed the extraordinary combination of both talent and hard work. Ladies and gentlemen, the winner of the 3-minute thesis challenge organized by the Department of Civil Engineering, University of Moratuwa is Engineer Supipi Kaushalya on the topic of evaluation of increasing shear strength of soil due to root water uptake. Let us now take this opportunity to witness the sensational talent and creativity of the winner of the 3-minute thesis challenge.
I'm Supi Kaushalya. Today I'm going to present my research and topic is evaluation of increasing shear strength of soil due to root foot uptake. My research supervisors are Professor U.P. Navagamon and Dr. Mrs. M.A. Pallewat. Tree roots. It can improve the mechanical and hydrological properties of the soil. It can reinforce the soil through their mechanical properties. It increases the suction through the root foot uptake and dissipate excess forward along the shorter paths. Many number of studies carried out only considered the mechanical behavior of the tree roots under saturated conditions with ignoring the implication of the soil suction. But the soil suction also influences the mechanical properties of root under unsaturated conditions. In this research, a detailed study was conducted to quantify the shear improvement with the tree roots for Sri Lankan context. For that, I investigated the influence of the suction on root reinforcement of the Alstonia macrophylla with Sri Lankan silty sand by following this methodology. As the sample preparation, 12 number of specimens were prepared only with the soil and another 12 number of specimens were prepared with the soil and plant. Then I developed the large-scale direct shear testing setup as per this image. Afterward, the root reinforced and unreinforced soil sample were tested under 4 different metric suction values with varying the normal stress from 10 kPa to 30 kPa. These are the final test results for the 4 different suction values as the large-scale direct shear testing results. There were 2 main observations. As the first observation, the effective shear strength parameters of the selected soil type can be obtained using the unreinforced direct shear test carried out under saturated conditions. As the above results, the effective friction angle of the selected soil type was 41 degrees and the friction angle of each cases have varied between the 40 to 43, which is approximately equal to the effective friction angle for the soil. So I can summarize that the effective friction angle of the soil does not change significantly with the improvement of the metric suction and the root reinforcement. As the second observation, the cohesion due to root reinforcement CR can be calculated by using 2 methods. Method 1 as the difference between the reinforced and unreinforced peak shear stresses under 3 different normal stresses for each metric suction, and method 2 as the difference between the apparent cohesion of reinforced and unreinforced failure envelopes for each metric suction. All calculated values are summarized in this table. Theoretically, these calculated CR values should be equal to the difference between the apparent cohesion of reinforced and unreinforced shear strength in saturated sample. However, the CR values have slightly increased with the metric suction in both ways. Finally, it can be concluded that the cohesion due to root reinforcement of the Alstonia macrophylla is slightly increased with the suction in the Sri Lankan silty sand. This observation also confirmed the finding with these literatures in various site conditions. Thank you.
As we recognize the hard work and dedication of the winner of the 3-minute thesis challenge, this invitation goes to Professor Malik Ranasinghe and Professor Lalit Rajapaksha to present the awards. Ladies and gentlemen, the winner of the 3-minute thesis challenge organized by the Department of Civil Engineering, Engineer Supi Kaushalya. Thank you very much, Professor Malik Ranasinghe and Professor Lalit Rajapaksha. Heartiest congratulations to Engineer Supi Kaushalya on your achievement, and we wish you all the very best on your future endeavors on behalf of the Department of Civil Engineering.
Ladies and gentlemen, we are now moving towards a heartfelt segment filled with nostalgia. As Charles Dickens quotes, life is made of so many partings welded together. It is with heavy hearts we acknowledge the end of an era in our department as we come together to bid farewell to 4 outstanding individuals who have been guiding lights of the Department of Civil Engineering. These exceptional personalities have not only dedicated years of their lives to the pursuit of knowledge, but also to sharing their wisdom, experience, and passion with countless students. Their wealth of knowledge and expertise in their respective fields shape the future of civil engineering while uplifting the Department of Civil Engineering of University of Moratuwa. Today, at the Civil Engineering Research Symposium 2023, we honor their commitment and express our heartfelt gratitude for the immeasurable service to the department and the university.
To recognize and honor the distinguished career, dedicated years for the advancement of the department and the university as a whole, and the mentorship provided for countless students within the department, let us now hear from these four remarkable personalities. First, I would like to cordially invite Professor Chinta Jayasinghe to introduce Professor Malik Ranasinghe for the first farewell lecture for this evening. Madam, over to you.
Thank you, Jilanjali. Good afternoon, everybody. Today, we gather here to honor and celebrate the remarkable career of an eminent professor in the field of civil engineering, Professor Malik Ranasinghe. With deep respect and gratitude, we pay tribute to a distinguished educator, researcher, and a mentor who has left an indelible mark on the world of civil engineering. Professor Malik Ranasinghe has dedicated his life to the pursuit of knowledge, the advancement of our field, and the nurturing of countless young minds who have had the privilege of studying under his guidance. As he embarks on his retirement, it is only fitting that we take a moment to reflect on his incredible contributions and the profound impact he has had on the field of civil engineering. Professor Ranasinghe was appointed to the Department of Civil Engineering at University of Moratuwa as an assistant lecturer in June 1984. In 1985, he won an Open Canadian Commonwealth Scholarship for his postgraduate studies. In 1986, he obtained his MASc degree, and in 1990, his PhD degree in Civil Engineering Economics from the University of British Columbia. After completing his PhD degree, Professor Ranasinghe returned to the University of Moratuwa in October 1990, and he was appointed as a senior lecturer. In June 1996, Professor Ranasinghe was promoted on merit as an associate professor in civil engineering. In August 2000, he was promoted on merit as a professor in civil engineering, and in August 2008, he was promoted as a senior professor. His research focus was to combine civil engineering economics, risk analysis, and environmental economics with project management. He has over 140 research publications, of which over 75 are international refereed publications. In April 2000, Professor Ranasinghe was appointed as the head Department of Civil Engineering. In March 2001, he was elected as the Dean of Faculty of Engineering. In November 2005, Professor Ranasinghe was appointed as the Vice Chancellor of the University of Moratuwa. He completed 2 successful terms as the Vice Chancellor of University of Moratuwa. Professor Ranasinghe is a former member of the University Grants Commission, a council member of the National Research Council, a former chairman of the Committee of Vice Chancellors and Directors, a former council member of the Association of Commonwealth Universities, and the former chairman, Center of Excellence in Project Management at the University of Moratuwa. He was a fellow at the National University of Singapore during his sabbatical leave. Professor Ranasinghe has been awarded many prestigious awards, including the CVCD Award for the most outstanding senior researcher in technology and related fields, including engineering. And also in, the CERS General Research Committee Award for Outstanding Contribution to the Sri Lanka Science. And also, he won the Professor E.O.E. Pereira Award for the Best Research Paper. And further, World Education Congress in 2012, Mumbai, India, honored him with the award for outstanding contribution to education. He was honored with the prestigious Education Leadership Award at the 4th Asia's Best B School Award 2013 held in Singapore. So it's a long list of awards. So then Professor Ranasinghe is a chartered engineer, international professional engineer, and a fellow of the Institution of Engineers, Sri Lanka, fellow of the National Academy of Sciences, Sri Lanka, fellow of the Institute of Project Managers, Sri Lanka, and a graduate member of Sri Lanka Institute of Directors. He is the chairman of the Information and Communication Technology Agency, that is well known as ICTA of Sri Lanka. Since 2003, Professor Ranasinghe has been an independent non-executive director of public listed companies, PLCs. At present, he is an independent non-executive director of Access Engineering PLC, Resource Engineering PLC, TJ Lanka PLC, and United Motors Lanka PLC. He is a former chairman of Sampath Bank PLC and a former non-executive director of the Colombo Stock Exchange, Hemas Power PLC, and Lanka IOC PLC. Professor Ranasinghe, together with the CODL, launched the open.uom.lk platform in 2022 to provide ready access to the education in many disciplines for the Sri Lankans. Today, the open.uom.lk platform has over 220,000 students registered on it, which is exponentially exceeding the modest expectations of University of Moratuwa had at its launch. While appreciating all his great contributions to the academia, to the industry, and to the country at large, I cordially invite Professor Malik Ranasinghe to deliver his important speech today at this symposium. Over to you, sir.
Thank you, Professor Jayasinghe, Professor Ratnayaka, Madam Ratnayaka, all the distinguished colleagues, dear students, ladies and gentlemen. I was a little confused when I was informed of this. I thought it was the last lecture. Then Chintak corrected and said, no, the last lecture is later on. This is just to share some of your experiences that you have had over the years. So I thought long and hard what I'm going to say without mixing the two. So I took a step back, and since it is going to be the end of my last day today, I thought I'll look at my career and is there any message that I could share, especially with the young ones and the young lecturers. And I thought I could. My message, which I'll explain as well, is when opportunities come your way, take it. Whenever possible, create opportunities. Don't sit back and let opportunities pass you by. I came to this university in 1979, long after the other three distinguished professors who are retiring today. Not because, to an extent I was 2 years late in coming to the university. 1 year because of my fault, 1 year because it was some other personal matter. So we came to the university in 1979, and in my second year, I did sports, most of you know that. I was asked whether I could captain the hockey team. It was not because I was good in hockey, Professor Bandara knows. It was a team that nobody wanted, because hockey was never associated with Moratuwa. So they had to have a team, they had to have a captain. None of the senior players were interested, so they said, can you captain? I said, sure. And it was the first time I realized that I took the opportunity that came my way. For those who doesn't know hockey too much, it's a team sport of 11 people. where you have to practice and learn your things. Unfortunately, when we asked people who were interested, we found there were only 5 people who have played hockey in their school days. And now we had to form a team with 11 players to send it to the inter-university games. So somehow we picked the 5 were very good. So built a team around them, picked up fairly big-made students, asked them to come for hockey practice, and we built a strategy. Our strategy was, don't score goals, but don't lose goals, don't give goals. I was the goalie, and that's my job to make sure that my career in hockey was in hockey. I had captained hockey at Trinity, so I knew what we were doing. And so Peradeniya, Colombo were the recognized places. So when the tournament came, we had played 2 or 3 matches, and they all played near we practiced in front of the quadrangle, which looks very, not the quadrangle, outside the VC's office. It was old timers will remember that. We practiced there. And I think we had one practice in a ground in Ratmalana just to make sure that we knew what we were doing, others knew. So our strategy was, there is 11 players, 9 were supposed to be behind the halfway line. They were not allowed to go forward. Your job is stop the others from scoring, from coming this way. Even if you have to hit the guy, it doesn't matter. So our first match was against Colombo campus. They had some very distinguished players from school days. None of them turned up. Some of my colleagues whom I played against. When we asked where they were told that they'll come in the evening for the evening match. That was the level Moratuwa was considered. So our strategy, nobody scored a goal, and then when it's a draw, there's a thing called a penalty scoop. The 5 of us had practiced the penalty scoops. So we won on penalty scoops. We went to the semi-final, did the same thing. By that time, the rest of the universities realized what we were doing. It was too late to do anything. We came with Peradeniya, was a distinguished team. Final, the center forward was scared to come because they hit him so much. He never wanted to come forward to try to score a goal. And of course, we won the inter-university championship for the first time. And that was, after that, of course, later on, our sports picked up. But to us, my message is, which I'll build on it, when opportunities come, take it, and do your best to try and make sure that opportunity is not wasted. So when I look back, it has been a case of my being ready to accept opportunities and then hopefully delivering to the best of my ability. When we finished our degree and when we all applied for our scholarships, that year both England and Canada gave Commonwealth scholarships. I didn't apply to England. I applied only to Canada. And I knew, since Professor Kalpage was doing, I felt that he might ask as to why I didn't apply to England. I was doing accountancy at that time, CIMA, or it was ICM at that time. So he obviously asked me the question, why didn't you apply to England, why only to Canada? I said, I want to do construction management. Canada is the more management-oriented things. He said, why? I said, I want to combine my accountancy and engineering. So I got my point in there. I saw him nod his head and I thought I had a chance. So that's how I think I got the opportunity to go to Canada. And when we were nominated, we were supposed to apply to universities. I didn't know who had construction management in Canada because I was focusing on America. Those days we all applied places. Fortunately, Gerard Canisius he had gone to UBC, he sent the application package for all of us. And in one of those, they said there is construction management. So my first choice was UBC. That's how I went to UBC. When I went there, only to realize they had just started the program and there was only one professor. So I didn't have a choice. But that professor, fortunately, turned out to be a really good one, with whom I had a long-standing relationship. And when I started my PhD, or halfway through the PhD, he was very honest. He said, for me to become he was associate professor at that time, I need 6 international publications. And I expect you to give me that, because I was the only PhD student. There was another Canadian who was not doing too well. So of course, I knew he was focused. So at the end of the day, we published 6 international journal papers, because he wanted it. And I learned how to publish papers. So that to me was an opportunity. When I came back, we didn't have a, we didn't have a tradition of publishing at that time. So I came, I didn't do much. The Canadian training did help me to learn, as Professor Ratnayaka could tell you, how to make sure your work that you did, you could break it and publish a lot of papers. That's what he taught me. And I came back, I created that opportunity of publishing papers, both in the engineering journal and whenever possible at international journals. And fortunately for me, I was in an area called risk analysis, which was brand new at that time. So anything you wrote went on, and it was a journal called Construction Management and Economics. We could get it published. So that was an opportunity that I really appreciated. And of course, as a result of that, suddenly I realized that I had enough points to apply for an associate professorship. So I applied. Not Professor Chandagirti wasn't very happy when I applied, but I did apply. And that's how this associate professor thing came, because there was enough, those days it was only publications, nothing else. So if you had enough points, you could apply. What I didn't know was, along with that, the journal that we are publishing was highly regarded in NUS. So to apply for a sabbatical, I wrote to them, and they sent a form. You know Singaporeans, it's very formal, everything was there. And then when suddenly I got this offer, which sounded very good. 2 years, a fellowship, with all these things. So I accepted it. Family was looked after, housing was promised. So I went to NUS. It was very good. It was at the time that NUS was trying to build up. And then when I went there, I was inquisitive. I asked, why was I selected? And the thing was that construction management was in that department a highly regarded journal. And you were supposed to submit your 4 best papers for the evaluation. And that's how they gave marks. So the opportunity that Professor Russell gave me to learn how to write papers suddenly paid off. It was a very lucrative offer for sabbatical, 2 years. It was very good. And so I spent the 2 years and I came back. And then when I came back in 2000, suddenly Professor Hettiarachchi told me that he was the head of department. When he finished, that I was supposed to take. I said, no, it's Priyan's turn. He said, no, Priyan is not interested. So it was not my turn. Suddenly I was asked to be the head of department in 2000. And then Professor Ratnayaka left for UGC in 2001. He told me, you better do this. So I said, okay, sir, and the opportunity was created. And of course, Professor Lucas it was Lucas's turn to be the dean. He said, no, he's not doing. So whenever opportunity came, I have accepted. I just did a review of my whole thing. And also in that process, before I did that, when I came back after 19, I missed that, I should also do. Professor GTF De Silva, as Vice Chancellor, asked me to be the chairman or the president of the Sports Advisory Board and to organize the University Games, which was coming to Moratuwa in 1995. And some of the students who were there would remember. We had absolutely nothing, and here the deadline was there. But he said, he was very nice. He said, I will give you all the support. I have very limited money. Try and organize it. And so we got hold of some of the final year students. Darshana Muthumani, I remember, and I think Danesh was also there. All of them chipped in, and we looked at what went wrong in Jayawardhanapura. And so what we did was, it was a very low budget event, but we involved all the young, there are lots of young staff members, all of us were young. So we assigned everybody a sport and said, your job is to make sure that no issues come. And I remember Dr. Gamini Kodigara was given hockey. It was one of the first matches, the first tournaments that was held. We had a rule that you must have your ID to play. So one of the teams from Ruhuna campus had come. One of the students did not bring his ID. It was not taken very seriously. Gamini said, nothing doing. Here are my rules. I don't know about hockey. My rules say if you don't have ID, you don't play. And from that we were told every IP, or the instructor of sports in every university, used to stay near the bus and collect the IDs before they came for the tournament. And despite that, I remember there was Mr. Dasanayake, who was our IP, who had gone to prayer the year. One of his students had not turned up, not brought up. Okay, I said, sorry sir, we have now followed this, and we continued. So that, in that context, Professor GTF gave us a lot of opportunities. I mean, that I really appreciate, because that gave me a chance to work with all the people, get to know the people, and an opportunity to do something different. And so coming back to the story, when I was dean, again talking about opportunities, my batchmate, Mr. Vajrakulatilaka, he was the MD at NDBIB. He was doing the IPO for Lanka IOC. So one day he called and said, Lanka IOC wants you to be a director in their board. I said, why? He said, in India they have a tradition, it seems. They have the Dean of Engineering in their board as an independent director. So I said, I know nothing about it. He said, you don't need to know. Just say yes and accept. So that's how my whole career, sorry, did I press something? Sorry. That's how my career in corporate sector was launched. I was the dean, and IOC's tradition, they come into Sri Lanka, and in India they have the tradition where a dean of engineering is always invited to sit on the board as an independent director. So I went, and during those days, Mr. Nivad Cabral was on our council. So I went, he was the only person I knew who was a director. I said, what do you do as a director? He said, you come home, so I'll tell you. So he took 3 hours with me, and he told me what is expected to be of a director. With that, I accepted, and suddenly it became another very good opportunity, which I'm still continuing, which I can continue till I'm 70. So I have 5 more years after retirement to work in the corporate sector. So along with all of these things, as I create, as opportunities come, I have always accepted it. So my message in this 20 minutes, I will do a detailed one, which is completely different when I do the final lecture, which is not about these things. But without mixing the two, my message to the young lecturers, especially the young lecturers, and the students, is when you get opportunities in life, accept it. Sometimes you may be reluctant or you may be scared. Take that chance. When you accept an opportunity, make sure that you build on it. So, to me, it has been a case of whenever an opportunity came, I have accepted. So, at the end of it, when I finished my lectures in 2019, I think Atul was the head of department, I discussed, and we said we'll hand it over to Leslie. I'm around for a year more before I went on my sabbatical, and then COVID came. And then I had nothing to do. Then this initiative, whether we can look at things online, the Vice Chancellor did ask me, he said, you started it when you were there, now here is a chance to relook at it with COVID. And that's how open.uml.lk came about. We didn't plan open.uml, sorry. We planned to develop the BIT program to make it online. That was our objective. And when with COVID, everybody was free or available, they all came online. So all the discussions happened weekly online. And then came this realization that there is a big vacuum that somebody has to fill. And so open.um.lk, which today has 225,000. Every week about close upon 4,000-5,000 join the program. Not that they all are doing it, but there is 225,000 students who have said they are interested in IT and they want to do this. And the philosophy there was, it has to be absolutely, we want it to be free. And it has, we have done all that with and the model we made, of course we looked very carefully in creating the opportunity. We said, we are not taking any money from the university, we are not taking any money from the government. We would find a sponsor, and of course Mr. Dhammika Perra through his DP education was very keen to join us. He gave 15 million The 225,000 students that have come, that are there, is from a 15 million investment. And recently I was asked to make a presentation to a set of investors who had come from Norway on IT. They were actually investing in Sri Lanka, and they were deciding whether they want to continue in Sri Lanka or take some of the companies that they were invested out of Sri Lanka. And their big question was, so I was asked to talk about education and capacity. So I did this, and then my finishing was on open.um.lk. We said that we have enough from both from the private sector and the public sector. I got the numbers from Professor Ratnayaka, and I took the numbers from UGC to say this is the amount entry in the IT industry or starting courses, but there is another 225,000 who are school children, working people, non-qualified, who are saying they are interested in IT. And therefore there is enough capacity in this country. I think they have bought the argument, and I was told that they have definitely made a decision to continue in Sri Lanka. So again, all along my career, if I have to say anything, is that whenever opportunities came my way, I have always accepted them. And if there's anything to learn or any message for me to give, is that when opportunities do come your way, don't give it up. Don't be reluctant. As professionals, as engineers, as people who are aspiring to contribute, whenever opportunities come, take them and do your best. Not that all will work, but it's important that you take opportunities when they come and you sort of grow onto the opportunities. Thank you very much for giving me this opportunity. I will do a much broader with pictures lecture when I do my final lecture, but this here I thought was how I would share some things in a short 10-15 minutes, especially after lunch. Most of you are not in the mood to listen to lectures. So given this opportunity, thank you Head of Department and the department for giving this opportunity. Thank you Professor Ratnayaka and Madam Ratnayaka for coming, for gracing this occasion. It is a real honor to have you here, and along with Professor Pusevela. Thank you very much, and of course my friend Professor Swan Wijayasekara. Thank you very much for all the retired people are coming, so it was like, thank you very much, and I wish you all of you all the very best. From today onwards, officially I am out of the university, but of course, since I am involved with the open.um.lk, we'll be still joining online, and that's the initiative we want to take it quite further. And on that, the project management has been launched, again, where we are going to offer a master's at level 6, a conversion master's. Four courses have been launched, and the beauty of thing like open.um.lk is that the moment you launch it, you open out to everybody. So when we launched it on June 23rd, in memory of Professor Wijayasekara, all 200,000 who on the network was opened out. And we right now have about 4,000, around about 4,000 people doing or registering and following. I don't think all of them thought of project manager, but the moment you open out and say, here's free, opportunities available, an email goes, and then it becomes, so that there is some, there seems to be a method in the madness with this online teaching, which I think we should look at seriously. And in doing the open.um.lk, since some of you are not aware of it, the principle was that it is going to be asynchronous learning. Synchronous learning is what we do. We do this lecture along in the same, on a fixed time. Asynchronous learning is we prepare everything and give it for the students to study whatever time they want. But the difference is, in preparing the content, asynchronous learning is a little bit tougher, or quite tougher, than doing our normal lecture. And when you go online, it's very important that plagiarism and all those copying issues are avoided, which sometimes we take from books to immediately do the lectures. That has to be very carefully looked at. So with those things, we have sort of learned a bit of lessons, but that has been the last opportunity has been a very rewarding opportunity at the end of the day. Thank you very much for giving me this opportunity.
Thank you very much, dear sir, for your inspirational words. Accept every opportunity you get and work on it at the best of your ability. and for the guidance you have provided throughout these years, which have illuminated the path for generations of students. Thank you sincerely for your unwavering dedication and mentorship. In recognition of your invaluable contribution, we invite Professor Malik Ranasinghe back on stage to accept the token of appreciation. On behalf of the Department of Civil Engineering at the University of Moratuwa, I cordially invite Professor Jagat Manatunga to join us to give away the token of appreciation.
Thank you very much, Professor Malik Ranasinghe, once again, and thank you very much, Professor Jagat Manatunga. So now, let me cordially invite Professor Chintaka Mallikarachi to introduce Professor Anura Nanayakara for the second farewell lecture of this evening. Sir, it's all you.
Good afternoon, everyone. Professor Anura Nanayakara entered this institute in 1977 and obtained his BSc Engineering Honours degree in Civil Engineering in 1982. He was recruited to the academic staff of the Civil Engineering Department immediately thereafter as an assistant lecturer. He proceeded to the University of Tokyo in 1985, from where he obtained both his Master of Engineering as well as Doctor of Engineering degrees. After completion of doctoral degree, Professor Nanayakara returned to the University of Moratuwa in 1990 as a senior lecturer grade 2. He was promoted to the professor on merit in 2006 and senior professor 8 years thereafter. Professor Nanayakara served as the head of the Department of Civil Engineering from 2013 to 2016. It was during his tenure the Department of Civil Engineering obtained the full accreditation from the Institution of Engineers Sri Lanka for its undergraduate degree, which granted recognition among the Washington Accord signatories. Professor Nanayakara's research in the area of concrete technology focuses on use of alternative ingredients, mitigation of early-age thermal cracking, and durability of concrete. The research carried out by Professor Nanayakara and his collaborators has impacted the Sri Lankan construction industry immensely. The use of offshore sand as an alternative to river sand, use of fly ash in concrete, both to utilize a waste material and to improve the concrete durability, and the mitigation of plastic shrinkage cracking in ready-mix concrete posts have all been driven by their research. His research collaboration with National Building Research Organization led to the patent on highly permeable and energy-absorbing paving block made from polyester spandex fabric waste, where he is one of the 3 inventors. Professor Nanayakara's research has led to many publications in refereed journals and conference proceedings. He is the recipient of many awards for his outstanding contribution to industry and the profession of structural engineering, which includes the President's Award for Scientific Research Contribution in 2010 and 2017, and an award for the best technical paper at the annual sessions of Institution of Engineers Sri Lanka in 2006, Professor Raghu Chandrakirti Gold Medal for the best paper presented at the annual sessions of the Society of Structural Engineers Sri Lanka in 2018. Furthermore, Professor Nanayakara was awarded the Association of International Education Japan Research Fellowship in 1999 and Commonwealth Academic Fellowship to the Imperial College London in 2004. Professor Nanayakara has contributed immensely to the development of national standards related to building materials over past 25 years, having served and chaired working groups and several sectional committees of the Sri Lanka Standard Institution. He was the chairman of the committee set up to develop the model code for concrete in Asia from its formative stages. Further, he has made significant contribution to the research and development program at National Building Research Organization over the last 10 years. Professor Nanayakara is a chartered engineer of the Institution of Engineers Sri Lanka and an honorary fellow of the Society of Structural Engineers Sri Lanka. He has been involved in many structural assessment projects for industry, which includes being a leading team member of the structural design review team of the Colombo Lotus Tower project. And an alumnus of University of Moratuwa, Professor Nanayakara counts over 40 years of uninterrupted service to the university in the fields of teaching, research, and consultancy. His commitment and excellence in research in concrete technology is unparalleled. On a personal note, Senior Professor Nanakara values act of producing high quality research over engaging in mere conversation. But sir, today we would like to listen to you before you officially retire from the active service of University of Moratuwa.
Thank you, Chintaka. Good afternoon, everybody. Nice to hear Professor Ratnayaka and Madam Ratnayaka and others, Professor Pussavel and Professor Shahan. Thank you for coming, and all the other invitees and dear students and staff members. So it is different to Malik's presentation. It is like a mix of two, my personal experience as well as I'd like to touch on my research experience. That is my passion. As you all know that, I joined the university staff to do research, right? That is why, I have selected the academic career. So, sorry, I had to repeat, Chintaka, what you said for the completion of my speech. What I am not a good public speaker, so therefore I have prepared speech here. So my topic is reflecting on 4 decades of my academic career. So today I am saying goodbye to the University of Moratuwa after more than 40 years of service. It all began in 1977 when I entered the Katubedda campus as a student. Those days it was called Katubedda campus. In 1982, I graduated from the University of Moratuwa, and in the same year, I joined the Department of Civil Engineering as an assistant lecturer. In 1985, I was fortunate to receive the Monbusha Scholarship to University of Tokyo, where I pursued my higher studies. I earned my master's in 1987 and doctorate in 1990. I returned to the University of Moratuwa in the same year and resumed duties as a senior lecturer, and I climbed the academic ladder, becoming a professor in 2006 and senior professor in 2014. So today marks the end of my 41-year journey at this university. While I have plenty of research experiences to share, I will save those for my last lecture. Instead of, I want to talk about my experience as an undergraduate student here, a graduate student at Tokyo University, and a staff member at the University of Moratuwa. So this shows the timeline. My journey through university, from innovative dreams to choosing civil engineering. Let me take you back to 1977 when I began my adventure at Katubedda campus. Since my childhood, I had a fascination with creating innovative things. When choosing a university, I had the option to select Peradeniya or Katubedda. I was excited to find a course I wanted, production engineering at Peradeniya. When I checked the UGC booklet listing all the courses offered at 2 engineering faculties, Peradeniya and Katubedda. At that time only those 2 faculties are the engineering faculties. It seems perfect for me, but there was a twist. My mother really wanted me to go to Katubedda because it is close to home. So I applied Katubedda as my first choice and I got it. In my first year, senior students asked me what I wanted to study. When I said mechanical engineering, they laughed at me and said, "Are you mad? There was a reason behind that one. Back then, it wasn't a very popular choice because there weren't many job opportunities in mechanical engineering in Sri Lanka. So, I have shown here some photographs. I don't know whether you all can recognize. In 1977, the intake to the Katubedda campus was 140, 120 for the engineering and 20 for the applied science. First year was common to all of us, and we learned wide range of subjects. Among them, I found immense joy in hands-on aspects of engineering. Workshop technology became my favorite, and I enjoyed the hands-on experience with machines like lathe. As I progressed in my studies, I became interested in civil engineering, especially because of the accelerated Mahavir project. So I ended up choosing civil engineering as my path. And that decision had a big impact on my life. Now, just to the highlights some, I don't know whether it is possible to recognize. Okay, so these photographs I had taken from my Students' Day record book. And these are very, I mean, you can talk lot about this picture. Now, this is a back gate, same type of gate we had as a front gate. And this post box, I checked today also, post box is still there. Professor Ratnayaka knows that one. We did the level line from that point to the front of the hostel. So this is during our survey camp, and one staff member is here, Premini, and this is myself. And this is a photograph, very few photographs I have during the convocation. And this is the next year convocation. As Western lecturers, we attended that one. Here you can see 4 of us here. Myself, Premini, Samantha, and Ruan, Bandar, and Kulatilaka. Okay. My time as a graduate student at Tokyo University, in 1985, I was awarded this prestigious Monbusher Scholarship to pursue graduate studies in concrete technology at University of Tokyo. My academic journey started at Concrete Lab in the Department of Civil Engineering at University of Tokyo. The lab was under capable leadership of Professor Okamura, and there were 2 enthusiastic assistant professors at that time, Professor Ueda and Professor Maikawa. At that time, there were 2 research groups at the concrete lab. One focused on developing constitutive models for reinforced concrete, the other one on fresh concrete. So you can see the fresh concrete group there. The Professor Osawa, he retired. He was at Tokyo University. And Professor Somnuk, he was from Thailand. And you can recognize the other guy. So 3 of us did research on fresh concrete under the supervision of Professor Okamura and Professor Maikawa. In 1986, Professor Okamura presented a range of new research topics for incoming graduate students. One particular topic that caught my attention was development of high-performance concrete. That is, that time it was called HPC. He proposed this project to address an issue in the construction industry in Japan. That is, there was a shortage of skilled laborers to place concrete, place and compact fresh concrete. So as you all know, the proper compaction of fresh concrete is one of the main factors that affect the durability of concrete. So you need skilled workers to compact it. So if you don't have skilled workers to compact, the quality of the concrete will be very poor and that will not last as expected. So he wanted to find a solution for that one. So that is why he proposed a self-compacting concrete where you don't need people to compact it. You just need to pour the concrete. Although this specific topic had already been assigned to another student, Diosawa, Professor Kumara kindly informed me that there were other related topics to this self-compacting or high-performance concrete. Sorry, don't be afraid. I'm not going to explain this one, right? So, after careful consideration and discussion, I selected a topic, computation model for pumpability of concrete, under the supervision of Professor Maikawa. This research involved various aspects such as flow visualization, using model concrete, two-phase modeling of fresh concrete, a theoretical study, and laboratory scale pumping test. It involved doing experiments with fresh concrete, even in very cold winters and hot summers. You can see that I was doing concrete pumping test with my friend Somnuk. It was tough, but successfully I defended my doctoral dissertation. Looking back, I take immense pride in my contributions, which have played a significant role in development of self-compacting concrete, a concept that has gained substantial popularity, particularly in Europe. Now, Professor Okamura is referred to as father of self-compacting concrete. So, what I want to highlight is this point. Innovative thinking is the most important one. Like Palik said, don't lose the opportunities come to you, accept it. And also, innovative thinking is very, very important, so that can make a big impact. So this innovative thinking of Professor Kamara has led to groundbreaking invention, this self-compacting concrete. Now it is very popular in other parts of the world. It involves doing experiment with, as I reflect on this critical period of my academic life, I am grateful for the opportunities that the University of Tokyo provided me. It was a time of growth, learning and contribution to the field of concrete technology. The experience I gained under supervision of Professor Okamura and Professor Maikawa molded me into the researcher I am today. Then the next period of my academic career, the researching with limited resources. After earning my PhD, I returned to University of Moratuwa to resume duties as the senior lecturer. It was early 90s. Back then, we had to work with limited resources, especially when it came to research equipment. Despite these challenges, we successfully conducted impactful research and produced world-class engineers. Let me share an example that illustrates our creativity during that time. In early 90s, we didn't have access to advanced data loggers and thermocouples needed to measure the temperature in concrete accurately. In early 90s, we didn't have the advanced data loggers to measure the temperature. Our sole digital thermometer was the multimeter, what you see on the screen, with thermocouple temperature probe. Today we have far more sophisticated data loggers at our disposal. However, we didn't let our limitations prevent us from doing research. I introduced finally a research project that aimed to study the temperature rise in concrete due to the heat of hydration of cement. Since we couldn't embed the probe directly into the concrete, we cast a copper tube along with the concrete. This allows us to periodically insert the probe to measure the temperature. While this method was not the most accurate way of measuring the temperature, it provided students with a valuable opportunity to enhance their understanding of temperature rise in concrete due to cement hydration. What truly stands out in this story is the dedication of our students. I don't know whether they are here. 3 female students took on this challenge wholeheartedly, even taking the concrete specimen to their hostel and monitoring the temperature changes throughout the day and night. This level of commitment is not uncommon among our students even now. Challenging the variety of specification given in codes of practice and standards. So this for the young staff and the students. As academics, it is important to understand the basis of specifications given in codes of practice and standards. This allows us to make informed decisions about their applications and to identify areas where improvement is needed. I would like to share a specific research study we conducted to understand the crack width limitation given in BS 800 for design of water retaining structures. A simple experiment setup shown in this slide was used to study the self-healing process of cracks in water retaining structures. The BS 8007 recommends limiting crack width to a maximum of 0.2 regardless of the pressure gradient across the width of the structural element. However, our investigation revealed a more complex reality. We observed that self-healing process of cracks as well as the complete sealing of the cracks depends not only the crack width but also on pressure gradient. I am happy that the current Eurocode 2 standard has taken this factor into consideration when recommending maximum crack width. This study reminds us not to blindly adhere to every specification in standards without understanding the underlying principle and their real-world implications. In conclusion, our role as academics extends beyond simply following established norms. It involves questioning, understanding, advancing the knowledge base in our respective fields. By doing so, we can contribute to the continuous improvement of the industry practices and standards, ultimately benefiting the society. Creating our own teaching tools. There was a time when we faced challenges in acquiring necessary equipment for teaching and research due to the lack of funds available. And the current financial situation has become even more challenging compared to the past. To overcome this challenge, we fabricate our own teaching equipment in the department workshop. What you see on the screen are 3 pieces of equipment we made in our workshop for undergraduate teaching. And guess what? It didn't cost us not more than 50,000 rupees. Similar commercially available equipment would cost us several millions. So this homemade approach not only saves us significant amount of money, but also allow us to have a tool we need to provide quality education to our students. In this in this slide, you can see students not at Moratuwa, but SLLIT. I don't know if Professor Ratnayaka can recognize this one. Using equipment we made for them in 2013. And I heard that they are still using it. So thank you, Gobi, I don't know whether he's here, for sharing this photo. So we made this one not for ourselves, but for the others as well. So I want to take a moment to express my gratitude to our workshop technicians, the past and the present, Gunasekara, Daudita, and Chandana for their hard work and contribution in making this equipment. I am certain that other staff members across the university have undertaken similar initiative to enhance the quality of teaching and research. Our commitment to excellence in teaching and research will always be our driving force, regardless of the financial constraints we may face. The way forward, the future of civil engineering. As university academics, our role is very clear. First and foremost, it is about creating knowledge through research. Then we share the knowledge with the world. But we should not do research just for the sake of it. Our research should always aim to solve real-world problems, especially in the field. Future civil engineering is getting more diverse and multidisciplinary, and our research should focus on different areas such as virtual reality, building information modeling, BIM, smart materials, smart building, 3D printing, and automation of construction process to minimize construction time and achieve high quality while using sustainable construction methods like PPVC. What you see at the center is the one local company move into this construction method, prefabricated, pre-finished volumetric construction. That is the future of building construction. A heartfelt thank you. As bring this speech to close, I want to express my deepest gratitude to everyone of you who has supported me throughout my journey. My heartfelt thanks goes to all my teachers here who have guided me, especially Professor Chandrakirti in the structures group, and Professor Okamura and Professor Maikawa at Tokyo University. I also want to acknowledge my colleagues, particularly Professor Priyandas and my research collaborators, Professor Asamoto from Saitama University. A special appreciation goes to my dedicated undergraduate and postgraduate students at University of Moratuwa and University of Sri Jayawardenepura, 2 of them are here, who have made significant contribution to creating knowledge. I am also grateful to government and private sector organizations such as NBR and ICC for their support and collaboration over the years. I would like to express my heartfelt appreciation to all non-academic staff, especially Madhushan here, for their unwavering support. Finally, to my dearest parents, brothers, sisters, and my wife Dhammika and son, thank you for Thank you for your unconditional love and support. You have made me the person I am today. Serving this institution for more than 4 decades has been an incredible honor and privilege. As I step into retirement, I do so with deep sense of fulfillment. May the University of Moratuwa continue to thrive as a hub of inquiry and a beacon of knowledge for generations to come. Finally, I must thank Professor Chinta Jayasinghe and the organizing committee for organizing this wonderful event. Thank you very much.
Thank you very much, dear sir, for sharing your passion and your experience with us today. You have always been an inspiration for us to be innovative thinkers. To extend our heartfelt gratitude for you, I hereby request Professor Anura Nanayakkara to be present on the stage once again to accept this beloved token of appreciation. On behalf of the Department of Civil Engineering of University of Moratuwa to award our heartfelt appreciation, I cordially invite Dr. Premini Hettiarachi on stage.
Thank you very much, Professor Anura Nanayakkara, and thank you, Madam. Ladies and gentlemen, as we continue with our evening, we approach the third farewell lecture. I'm pleased to extend the warm invitation to Professor Udini Navagamua, who will introduce our esteemed retiring professor, Professor Attula Kulathilaka. Professor Udini Navagamua, so the stage is yours.
Good afternoon. Head of the department, emeritus professors, retiring professors, invited guests, my colleagues, and students. It is my great pleasure to introduce to you my guru and my mentor, Senior Professor Siyambalagodage Attula Senrath Kulathilaka. Professor Kulathilaka obtained his BSc Engineering Honours in Civil Engineering from the University of Moratuwa with first class honours. I think I have disturbed this one. Yes, Professor Kulathilaka has obtained his BSc Engineering Honours in Civil Engineering from the University of Moratuwa with first class honours in 1981. He joined the Department of Civil Engineering as a probationary assistant lecturer in July 1981 and proceeded to postgraduate studies in 1984. On receiving a scholarship from Monash University, Australia, Professor Kulathilaka obtained his doctoral degree from Monash University, specializing in the field of geotechnical engineering. Upon his return, he was appointed senior lecturer grade 2 in April 1981. He was promoted to senior lecturer grade 1 in April 1997, professor on merit in April 2006, and senior professor in 2014. He is a chartered engineer since 2004. Professor Kulathilaka was the head of the Department of Civil Engineering from March 2019 to June 2021. He served the university as chairman of the Staff Development Center from September 2008 to September 2013, where a Center for IT Skills with 35 computers was developed with special funding from the University Grants Commission. Professor Kulatilaka pursued research in the areas of earth retaining structures, ground improvement techniques, unsaturated soil mechanics, rain-induced slope failures, and stabilization of slopes. He has supervised many undergraduate projects in these areas, and I was one of those fortunate students, and also number of postgraduate projects. He has published more than 100 refereed research articles in conferences and refereed journals. Professor Kulatilaka has guided the Road Development Authority and the National Building Research Organization, NBRO, through his expertise in the field of geotechnical engineering, in the construction of expressways in the country, in the areas of subground improvement, stabilization of cut slopes, and landslide rectification projects. He won the Commonwealth Research Fellowship to the University of Newcastle in the UK in 2004. Professor Kulatilaka has contributed immensely to the advancement of geotechnical engineering through numerous activities conducted by the Sri Lankan Geotechnical Society. He held the post of Honorary Secretary from 1994 to 2004, Vice President from 2005 to 2011, and President from 2011 to 2021. He organized 3 international conferences in 2007, 2015, and 2021 with the participation of world-renowned academics and practitioners and resource persons along with Sri Lankan geotechnical engineers. Professor Kulatilaka is among those who entered the portals of the University of Moratuwa, then a fledgling university, as a young undergraduate. His uninterrupted service of dedication and commitment to the university in the field of teaching, research, and consultancy for a period of over 4 decades is an inspiration to his colleagues who consider him a mentor and a role model. With this note, I feel like it's a very small note. I would like to invite Senior Professor Atula Kulatilaka to commence his farewell lecture. Over to you, sir. Thank you.
Thank you very much, Hudeni, for that kind introduction. And my presentation will be quite different from the previous two. So I will talk about my experiences over the last 42 years as an academic in the University of Moratuwa. First, I want to mention my teachers here, Professor Ratnayaka, Professor Mrs. Ratnayaka, and emeritus professors, and my colleagues in the department, and dear students, and the members of the industry. So I gave this title here, part 1, because I will be doing another thing a little later, another lecture a little later. So Malik talked about opportunities. So this is about the life is full of opportunities. As Malik said, we have to make the best use out of it. Quoting from a well-respected Sinhala scholar, Munidasa Kumartung Kunmartunga Munidasa, Lota Upane Putoba Yam Kisiwak Pinises, you were born as humans here to make a positive contribution to the world. We have to identify our role and make that way. Then taking a verse from a song that we sang in school, some of us, early morning, clad in white. There were two of this verse, Pevi Seve Nisa Veseva Pramada Novenu Telona Desase. Those who sang it may remember it. So serve with dedication, take swift actions in the path of Dhamma as a human being. So my mentor was my father, who was a dedicated school teacher and a principal in Horana. So he had many stories of how he guided the young children from my village and the neighboring villages to go up in the state, higher up in the status with education. So his work inspired me to to get into a teaching career. So teaching is a profession a service that one can conduct with metta, karuna, mudita and upeksha. Metta, the loving kindness to all without expecting anything, and karuna, you have to be compassionate and help the students with their difficulties and get them to achieve the necessary standards, and you can be happy about their achievements, and you need to take whatever the responses comes in your way, good or bad, with a equally balanced mind and get on with your duties. So the term Premia in Holy Bible encompasses all these four qualities. Now, this doesn't mean you have to pass the student getting 25 marks or accept a very inferior quality research result. You have to guide them, you have to tell them, show them what is the standard to be achieved and guide them to achieve that standard. So that is our duty as teachers. So in this journey, another phase that will be helpful is attanang upamankatva, that is put yourself in that situation to see when you are dealing with people, put yourself in that situation and see how you will feel and how you will react. So that will help you to get into the correct line of action in any given situation. So I was initially interested in my secondary school studies in learning chemistry and developing a career in chemistry, but then leaving engineering. But I was persuaded to do civil engineering, and then I ended up doing civil engineering here. And after completion of my first degree, I joined as an assistant lecturer in 1981. So we had a developing department with visionary leadership and dedicated academics. We had 4 strong professors, Professor Vijay Sekara, Professor Tennakon, Professor Senrat and Professor Chantakirti. And the syllabus was getting developed to be compatible with the industry needs. There were strong industry collaborations. So it was a nice environment to be working under the guidance of these senior academics. So as assistant lecturers, at that time, we had a lot of responsibility, do a lot of lectures. When I joined the department, Professor Tennakon was the head, and he had plans to develop the department. He suggested me to do transportation planning under Professor Chandana Veerasinghe. Professor Veerasinghe came here on a sabbatical and spent 1 year here. I was to work with him closely and get into the area of transportation planning. So he came, I helped him in whatever the needs, but I could not make up my mind to do transportation planning because my love was in the area of geotechnical engineering. So I declined the offer and then I had to wait for 3 years to get a scholarship on my own in the area of geotechnical engineering, because at that time Moratuwa was not very well known, so it is a little bit harder to get a scholarship. So as an assistant lecturer, we were involved in a lot of teaching. The period as an assistant lecturer was very challenging, interesting and rewarding, and I have done lectures on a number of these subjects. When we were students, the Part 2 survey was done by senior survey officials coming from the survey engineering the Survey General's department. So Professor Tennakon wanted me to take over that subject. So there were new areas like photogrammetry and so forth where we did not have any practical experience. So I went to the survey department, spent 2 weeks with the senior survey superintendents there, learned the subject, learned the process of aerial photogrammetry and air cameras, the flight planning and these analog plotting instruments and so forth. So I worked with them and mastered the techniques there and prepared, after referring to a number of textbooks, prepare a handwritten note. So last week I scanned some of these copies from my old note, handwritten, written on stencils, because at that time facilities were very limited. We did not have any typewriters here. Photocopiers were not seen. So we had to write this on a stencil. It has a tissue paper which can get easily damaged. With a particular type of used carbon pen, you can write very carefully and draw very carefully. So I have given notes in all my lectures done, prepared in this manner as an assistant lecturer. So the aerial photographs taken and maps developed through these analog plotting instruments were used in many development projects at that time. Now the things have changed. Now we take photographs using drones, flying at elevations of around 100 meters as opposed to 1,000 to 1,500 meters from a large aircraft. So the photographs are of much larger scale, and instead of the analog techniques, we are using analytical photogrammetric techniques with those digital photographs. And in the landslide, the rectification works that I now do with the NBRO, we produced 3D terrain maps with that and base our studies on that. So the technology has developed that way. So during this period, while doing this active work, I was applying for scholarships. I targeted mainly Canada and Australia, and then there were interviews for open Commonwealth scholarships offered by UK and Canada. So I have established some relations, some sort of good contacts with Toronto University. When the scholarships for Canada were advertised, I was quite hopeful that I might get that. So I went for the interview, which was chaired by, the panel was chaired by Professor Stanley Kalpage, the chairman of UGC and the secretary of the Ministry of Higher Education. So he's the main person in the panel, and others speaks very little, and he's doing the main talking, and he's a very strong man, a strong ally of President J.R. Jayawardena. So he asked me, Kulitilaka, give me another name for geotechnical engineering. So I didn't know, because geotechnical engineering is the subject area encompassing soil mechanics, engineering geology, and rock mechanics. It combines them all. So there's no other name for geotechnical engineering. I said, don't know. Then he answered, he said, petrology. So petrology is the branch of geology that deals with areas like origin of rocks. I said, no, sir, it is a branch of geology deals with origin of rocks. He said, no. I said, no, sir. So that is the end of the interview. Obviously, I didn't get the scholarship. So I believe everything happens for good. So after a few months, I got the scholarship offer from Monash University. Those days, communications are done through letters, or if it is urgent, you get a telegram, international telegram. One day, when I came to the office in the morning, this telegram was put under the door of my room. It asked a question, will you accept a scholarship offered from Monash University? So I immediately, so that is the way of communication those days. So I immediately responded yes, and then went to Monash in the following March. My period at Monash was very friendly, inspiring, and it was a smaller group of research students, only about 40 postgraduate students at that time. So we had a very interactive research environment. Staff and students worked very closely together, and there were research seminars once in a fortnight. So I was supervised by Professor Ian Donald, who was a great human being, great academic with a sharp engineering mind, a well-recognized classical musician. So at Monash, I studied the behavior of retaining structures using the finite element technique with some experiments on interface studies. So at that time, the commercial software were not available, so we were developing our own software to study the various construction processes like excavation, placement, compaction, etc. Now, this concept of C5 reduction factor in getting the factor of safety through a finite element analysis adopted in the modern software was the concept of my supervisor Ian. So when we do an analysis with the finite element technique, we get stresses and deformations, but no direct indication of factor of safety. So he said that if we reduce the C5 values gradually and get the analysis repeated, at one stage there should be failure indicated by large deformations. So he got me to work on this with the simulation of retaining structure behavior, and I got this result. And so another colleague of mine who was working in the area of slopes developed a similar technique for slope stability analysis. So that work is now incorporated in the modern software to get a safety factor through a finite element analysis. When I returned to the department after my PhD, that was after the insurgency period in 88, 89, and quite a number of staff members in the department have migrated to Australia. In the in the geotechnical section, only Professor Tennakon was there. Professor Raja De Alvis has gone on sabbatical. So we had two subjects in part 2 and part 3. I introduce new areas, upgrade the syllabus, and introduce new design courseworks into the subject. And a couple of years later, Anuruddha Pussavala and Ashok Piris also joined. Now, at that time, I had an opportunity to get a practical exposure to various geotechnical problems in the country. NBRO has done a geotechnical investigation on the proposed trace of the Katunayake Expressway. So the RDA wanted to do a design. So NBRO want to form a design team. So they invited me, and there was one expert from UK who was an engineering geologist basically. So I teamed up with the NBRO young engineers, and Dr. Sunil De Silva also joined, and did a design for the Colombo-Katunayake Expressway, embankments, leaving the structures, only the embankments, with ground improvements in by preloading the stone columns and so forth. So later, when the Kian first started the project, they were given our basic design. So it was not implemented because they didn't have enough money at that time. So also I got the opportunity to get involved in the cut slope stability in Southern Expressway in these two segments, and also in the construction stage of the Katunayake Expressway. So all these were done on a part-time basis, and with that I was able to get a lot of exposure to actual geotechnical problems, and with that many research ideas came through, and I could enhance my teaching very much, and all the examples that I do in the class comes from the actual projects in the country, so it was a very rewarding exercise. Now here I have summarized my research areas: improvement of engineering qualities of soft peaty clay, earth retaining structures, and slope stability, instability and stabilization. Those are the three main areas, and in that there are these sub areas, and then here is a list of names. So they are my final year project students who went on to do PhDs in geotechnical engineering and serve in Sri Lanka and various parts of the world. So some of them did master's research after that, but some went for PhDs directly after the undergraduate work. So five of them are in Sri Lanka: Shiromi, Asiri, Nadij, Naugamu and Nalin. Others are in different parts of the world. Sharing some pictures on the research conducted. This was the research on behavior of anchored earth retaining structures. Naugamu was finally a project, and so we created this model of anchored earth, a technique, economic technique of constructing retaining structures. Actually, RCDC wanted us to do this study because they have dumb sun walls without any design. So they wanted to find a design technique, study that protect in detail. So we constructed these model structures, loaded, and found the behavior, and through that developed a design technique. A paper that Navagama wrote on this, based on this final year project, won a competition organized by the Sri Lankan Geotechnical Society. He, along with Asiri, attended, Asiri, who did the studies on improvement of peaty clays, attended the first Young Geotechnical Engineers Conference in UK in year, I think, 2000. So these are some other projects that we did on bamboo reinforced earth retaining structures, and this on optimum design shapes of gravity retaining structures, soil nailing with Changamithanda, and more recent times the influence of metric suction on the pull-out resistance of the soil nails after acquiring a number of instruments which could do the measurements. And then coming into the areas of soft down improvement. So that is used in the Katunaik Expressway, Southern Expressway and so forth. So if we are to construct an embankment on soft ground, this has to be done slowly, allowing the soil to consolidate and gain in shear strength. So after that, if you remove part of the preload, it comes to an over-consolidated state. So with the subsequent construction of the pavement, settlements during service will be limited. So we studied the process of loading, unloading and reloading with the structure in the consolidation apparatus, and studied how the primary and secondary consolidation characteristics can be improved by that. So I have put the names of the research students who were working on that. Now that process takes time, so you have to wait for the consolidation. But if we mix the peat with the cementitious material like cement, there will be structural changes in the material, and the strength and the compressibility improvement will be more rapid. At that time, no one has done this on organic soil. There are actually only very limited studies done in Sweden on organic soils. Many studies were done on inorganic soils. So I got down some references and even a PhD thesis of a person who did that in Sweden. So we found that we need about 30% of cement to get the improvement to an adequate level. Then we started to see in the possibility of using the waste material like paddy ash on that, and so a number of projects were done on that. Also, we studied about the consolidation of the soil through electroosmosis without loading. When static electric voltage change is applied to a soil, water will move, there's a net flow of water through the cathode, and water will be extracted out from the cathode, that is consolidating the soil without application of a load. But what happens is at the anode there is oxygen being liberated, so all the electrodes will corrode within a matter of 3 weeks. So then we were looking for options and I found that there is research done at University of Newcastle upon Tyne developing conductive plastics. Adding carbon black, plastics can be made conductive which will not corrode. So I spent one sabbatical there, learned the technique, and after coming back did many studies of improving the soft gritty clays with electroosmosis. So these are some of the pictures I'd like to share. So what I can share is limited because of the time. Then talking about the Sri Lankan Geotechnical Society, I was highly involved with the Geotechnical Society. I had the opportunity to work with two distinguished professors, Professor Tureraja and Professor Tennakon. Professor Tureraja is the one we consider as the father of the field of soil mechanics or geotechnical engineering in the country. His work, his pioneering work at Cambridge in the development of critical state soil mechanics is well known. And he introduced the soil mechanics to the curriculum, engineering curriculum in 1965, and started the first master's course in soil mechanics in 1972. Professor Tennakon was his student. So they were the president and the vice president of the Geotechnical Society. So we could, they encourage the younger people like us to work hard for the development of the field of geotechnical engineering in the country. So I was a member of the executive committee since 1991, and so these are the other positions held held by me, and we had 3 international conferences in 2007, 15 and 21 with the renowned academics and practitioners in the field of geotechnical engineering from all over the world. And we conducted workshops to disseminate new knowledge on areas like pile draft foundations, unsaturated soil mechanics, ground improvement techniques, and so forth. And another thing that I am very happy to mention is we started this project, the competition called Project Day among young students, undergraduates doing the projects in the field of geotechnical engineering in the Sri Lankan universities to compete for a prize. We started that in 2000, and it is conducted uninterrupted up to now, and many who won that has gone to do higher studies in geotechnical engineering and are serving in many parts of the world. Sharing few pictures. So this was, we took Professor Delvin Fredland, a pioneer in the field of unsaturated soil mechanics, to Sigiriya after the workshop. A photograph taken with him. Navagamu has just completed his undergraduate course at that time. And then this is another memorable picture with Professor Peck. So in soil mechanics we talk about CERS and Peck. So Professor Peck was more than 90 years old at that time, so we was able to get a photograph with him. And this is the Sri Lankan delegation at that conference. You can identify many young known people there. We had a conference organized. These are some pictures from the conference that we had in 2015 with keynote lectures from people like Professor Fullers, Professor Indaratna, Professor Kerry Rowe, John Endicott, and Ken Ho. And here Professor Tennakon presenting a memento to Professor Fullers and some of the delegates, people involved in that. Then I spent 2 sabbaticals with NBRO in 2013 and 21. And assisted them in their landslide rectification work. So we team up with with geologists and trained a number of young engineers to do the designs on landslide rectification, making many site visits before and after, and discussing the feasibility of the proposed mitigation measures in detail. So a number of those students have done master's course with me subsequently or during that time. 2 of them have completed PhDs since then. Sharing some pictures of this improvement work we have done. So this is the rectification of the failed slope in the southern expressway at Velipanna, which was done with soil nailing, anchoring, surface drainage, subsurface drainage, and construction of a gabion wall at the toe. And at the crest, the steep slope left after the failure was stabilized by soil nailing and anchoring. So the surface was shotcreted after the soil nailing and anchoring. Subsequently, we thought of using more aesthetically pleasing material in the work. So in this work, we have the soil nails connected by beams, and in between introduce vegetation. So it will finally appear as a natural slope, so aesthetically more pleasing. So this is another project that I did with NBRO, improve the rectification of the slope at Ginigathena with surface drains, subsurface drains, soil nailing, and nail heads connected by beams and introducing vegetation in between. And this is how it looked like after the completion. Also, I got this opportunity through NBRO for the rectification of a failed retaining wall at Talada Maligawa. So that is a case of classical foundation failure. They have been cleaning this canal. After dredging the canal, there had been a heavy rain, so that increased the horizontal load on the retaining wall, and there was a foundation failure, catastrophic failure. This was not an ancient structure, so we removed the debris and constructed a reinforced concrete retaining wall there. So some pictures are shown here. Then I'd like to share this picture on another application of ground improvement. This is the Colombo-Katunayaka Expressway, close to the railway track. This area was underlain by about 4 or 5 meter thick layer of peat. So we did the ground improvement with stone columns, then preloaded it. So we can't construct an embankment. We preloaded with a retaining structure done with sandbags. And after treating, after ensuring that the settlements are small, we constructed this reinforced earth wall. So people traveling on the road can travel freely at 100 kilometers per hour because the settlements are all controlled. So that was the approach to the viaduct area. So doing a viaduct all over will be very expensive. By doing a reinforced earth wall, the cost can be significantly reduced. So those are some of the applications that I did with NBRO and then other organizations like RBA in geotechnical engineering. So all the experience I gathered was transferred to the students through in the way of research, design courseworks and various other teaching exercises. Also, I had the opportunity to get involved in construction of a number of stupas, so I just will present 3 of them. So this was a case of construction in a soft ground area. We removed the soft layer, which was about 2 meters thick, did a raft, and the rest of the structure was constructed on that, and it was to be filled up that level because it was a low-lying area. Then we did another arch structure. I got some advice from Professor Tishan and Mr. G. Videtilaka, the senior structural engineer, on the structural aspects. So it is to be done as a shell. So that's the framework for the shell. And so it used to be done on the top of a building, on the roof of a building, so a roof slab of a building. So we assembled it up at the ground level, and then knowing that it is in proper shape, put it up in the top level, on top of the slab. And so there is one layer of reinforcement, compression reinforcement, and concreted, and that was the finished structure. And we placed the pinnacle in the morning. This is the gentleman who funded the project and had a Pahan Puja in the afternoon, attended by many, as you see. Then this is the last photograph, the recent involvement in the construction of the Mihindu Saya at Mihintale. I was invited by the Nayaka Therodaya to get involved. Another student of mine, Rear Admiral Medagoda, was in charge of the construction with his Navy group. Chintaka helps me with the structural work here. Chintaka Mallikarachi Professor helps me with the structural work. So that was the shape at the start, which is to be restored to that shape. All this was developed by the Department of Archaeology. We found this Kalik chamber, the old chamber at the top here. So that was filled back with sand as advised by the Archaeological Department. And this was at this was on a sloping ground. So there had to be some foundation enhancements to be done. So I designed a reinforced concrete retaining structure on a certain segment, and the foundation loads are transferred to it and enhancing the stability. And then on the existing relic chamber, we did a new relic chamber with granite beams, 1 feet, 300 millimeter thick granite beams. We tested one at the laboratory, and this is how it was installed. And that was at the middle of the super. Then access to that through an arch tunnel made through arch. Through the arch section, provided the access to that part at the center. So this is how it looks like at the moment. Construction is still progressing. So that is how those are some experiences how I have made use of the opportunities came my way to in teaching, research, and helping in the construction industry. So my motto is I will site satusata wada karaminiti. So I will work happily always to achieve self-satisfaction without complaining about the facilities available or the workload. So in this process, I express my sincere gratitude to my parents and teachers for the education given to me, and my family, Chaya and children, for bearing with me at good times as well as bad times, and all my colleagues for their kind cooperation. And I will end up with 2 wishes. Sabbe Bradhani Prasantu, may all beings see the right way, and wishing that you will be able to move forward with great dedication and determination in all your duties. Manivatta Abhikkama. Thank you.
Thank you very much, sir, for your inspirational farewell lecture. Seeing your presentation today reminded us the lectures you did for us, the same font, same colors, but today a different aura and a unique message. And dear sir, your unwavering dedication has motivated us in our engineering journey. To convey our deep appreciation, I kindly invite Professor Atula Kulatilaka to return to stage and accept this cherished token of gratitude. On behalf of the Department of Civil Engineering at the University of Moratuwa, I warmly invite Professor Lalita Rajpaksha to join us in presenting this token of appreciation.
Thank you very much, Professor Atula Kulatilaka, once again, and thank you very much, Professor Lalita Rajpaksha. Now, as we move towards the final farewell lecture for the evening, I would like to cordially invite Professor Tishan Jayasinghe to introduce Professor Ruwan Veerasekara. So it's all to you.
Very good afternoon to all of you, our retired professors, senior professors, all the visitors and students. It's a great pleasure that I introduce an eminent academic, Professor Ruwan Veerasekara, senior professor. So, a brief introduction. Professor Veerasekara was one of the students of University of Moratuwa. He graduated in 1982, and then he joined the Department of Civil Engineering in 1983. Then he was able to get an opportunity to read for PhD at University of Calgary, Alberta, Canada. And that was in 1985. He completed his PhD in 1991 and returned, and then started working as a senior lecturer. Then in 2009, he was promoted as a professor, and then he became a senior professor in 2017. Professor Ruwan Weerasekara was a good leader, and he was a very active member of Building and Structural Engineering group. And he gave the leadership to that group from 2010 until 2017. He was also very active with Society of Structural Engineers activities, and he was one of the founder members. He served at many capacities, and in 2012 he became the president of Society of Structural Engineers. Society of Structural Engineers was set up in 1990. So 2015 was the Silver Jubilee, and for Silver Jubilee we had a grand event called an international conference called Towards Excellence in Structural Engineering, and that was held in grand scale in Colombo under the leadership of Professor Ruwan Weerasekara. And Ruwan Weerasekara was also a very good researcher, and he has published many research papers, refereed conferences, and so on. And also, he's also a chartered civil engineer. He became a chartered civil engineer in 2006. So, Professor Ruwan Weerasekara was associated with University of Moratuwa nearly 40 years, and I'm sure he has a lot to share with us. So I cordially invite Professor Ruwan Weerasekara for his address.
Okay. Head Department of Civil Engineering, Professor Ratnayaka and Professor Mrs. Ratnayaka, my teachers, and all the other colleagues, students, and friends. I'm delighted to be here this afternoon to address you on my eve of retirement. In fact, I have experienced here 3 other eminent professors speaking to this audience. So I have a hard time to speak now, because they have spoken about all these things, academic side, research side, and also consultancy, and so forth. So I will make use of this opportunity to fill in few gaps, because as others were saying, we will be giving a formal lecture later on this year as a last lecture. And then I must say, I must thank Professor Tishan Jayasinghe for introducing me, because he had most of the facts, and maybe there are a few things that were not said, but I think I must say that here, because I think in 2000, I had the opportunity to go to India to do a course in curriculum design and instruction material development. That is an area in education technology. I think, if I remember correct, Professor Ratnayaka was the Dean of Engineering that time. So he gave the full support for me to go to India along with another colleague in the electrical engineering department. He is now deceased, Dr. Ranjit Pereira, and we spent nearly 3 months there following this course. So what I thought was, rather than talking about my research and other experience today, I will keep that for this day that we will be asked to deliver later on. So I thought normally maybe I speak on subjects like civil engineering or maybe structural engineering. Today I thought I will talk about something else, and I thought I will talk about the subject educational technology. And then educational technology, again, I'm not going to cover the whole thing because that's a vast subject. And I thought I will touch on 2 aspects. One is to do with attitudes. Other one is something that affects all of us, continuous assessments. Okay, in one's career, normally we talk about ups and not downs. Now, I had a career which was full of ups, most of my school education and the university education. I also had a downfall at one stage. I was able to reach back to the upward trend due to 3 people. I think I must mention that. That is due to Professor B.L. Tendakon, Professor S.R.D.S. Chandrakirti, and then Dr. W. Samarasinghe. And they were very grateful because when I was having problems, they helped me. So I remember them always. And unfortunately, Dr. Samarasinghe migrated to Australia. Professor Chandrakirti, of course, was here till his retirement, and also Professor Ehun was here till his retirement. And while I was in the Moratuwa staff, I had the opportunity to interact with Dr. Chandana Veerasinghe, who was here on his sabbatical, and he organized the Transportation Forum. So I had the opportunity to have a hand in that. And then he was quite pleased with what I did for the Transport Forum. And the next year when he came here for a workshop, he asked me, Rohan, why don't you come to Calgary? So he said, then he asked me, what are you interested in? And I said, I'm interested in pre-stress concrete and bridge engineering. Then he said, he gave me 3 names and asked me to write. And he's followed up from the other end. And he helped me to go to Calgary. Otherwise, that time, it was very difficult to find foreign scholarships. Because of his support, I was able to get a placement in Calgary. So that was my story briefly. And after that, I did my PhD from 85 to 91, nearly 6 years. And then I returned to Sri Lanka, and then I was at University of Moratuwa. Okay, now let's go to the subject. Now, education technology is a vast field, and I selected this area, attitudes, and I selected this topic like this, attitudes to reflect and act. Now, before I talk about attitudes, I thought I will cover some basic items in the education technology. Now here, what I meant was, what is teaching? Now all of you, or most of you are teachers, so you know what teaching is all about. Different people might have different styles, different ways of doing it, but teaching is well covered. Then I have this area, what is learning? Now, we think whatever we teach, students must learn. Now, this is not something we should think about, because learning is defined in education technology that it should create a permanent behavioral change in the student. If that does not happen, then there is not a learning. There is only a teaching outcome, but not a learning. Now, as I said earlier, what is learning is, learning should result in a permanent behavioral change in the student. Then we are interested in another aspect, teaching and learning. Now, teaching and learning is a process, not a discrete event. Now, we think when we deliver this in a lecture, in some module, and that is it. It is not so, because it is a process. We'll go through some of these steps in that. In the systems approach, we have what is called the teaching and learning is described as, given in this chart, as an input, there is a process, there is an output, and now there is an arrow bringing back from the output back to the input through feedback. So feedback is very important. So when you go through this cycle, next time when you go through the process, we get a better product. So if you go through a couple of times, you will end up with a good product, which is what we aim at. Then we have what is called evaluation. Now, what is evaluation? Now, teaching and learning is also related to testing and evaluation, because this is connected to one another. And testing and evaluation is part of teaching and learning. Now, I want to deviate a little bit is, now I go to what is meant by evaluation. Now, evaluation, there are three types involved. We have what is called preparative evaluation, then we have formative evaluation and summative evaluation. Now, preparative evaluation is where we test at the entry level. So maybe we can think of A level, Z score, whatever, or aptitude tests like architecture, and something to work on before you start a course. So that is preparative evaluation. Now the most important thing is formative evaluation. Now formative evaluation is a process. Now that is something that happens in the class. Now we must do that under classroom conditions. Now most of us don't realize the importance of this classroom conditions. Why? Because student gets excited whenever you say it's a test, it's an exam. But classroom conditions makes him more comfortable. And that type of testing should be coupled in a formative evaluation. So maybe, for example, say we give a quiz. And quiz is meant to be done in the classroom conditions, so that you might think they will copy, but it doesn't matter, because we should not assign a very high percentage for a quiz. We can give something like 10% out of 100 for the quiz. The whole idea is for them to get in this formative evaluation process. And this improves the teaching learning process. And you can see that is something I find we have still not mastered. Whenever we say a test or evaluation, what we do is we do something like what we do for the final exam. We have, even questions are not properly designed. We try to give a test and student is stressed that way. So I think as my message to the staff and students here is to work under classroom conditions. And when it comes to a midterm or a final exam, then it has to be exam hall conditions. So we need to understand this, because the formative evaluation is supposed to be done by the teacher himself. Teacher can get enrolled in that, and that person should have the control. Now, maybe if you have a quiz, it's important that you display or post the answers. And then the correction, you can give it to a junior staff member or an instructor, that doesn't matter, but you have to set the marking scheme. You have to give the model answer. And that type of feedback is necessary, because then only students will learn from your quiz, which normally doesn't happen in our scenario, I think. And even other universities in Sri Lanka, I'm sure they don't practice this as a formative evaluation. Then summative evaluation is something like where we use to finally give a grade. And that is something we are doing very well. We have final exams, and that is something we are proud of. Now, talking about evaluations, I thought I will touch on the major abilities concerned. That is, there are three major abilities. One is called cognitive, second one is called affective, and third one is called psychomotor. Now these are the technical terms used in this education technology, but what I have put in brackets is something not exactly the meaning of these three terms, but something we understand. When you say knowledge, maybe you understand to some extent what it is. And when you say attitudes, you understand that to some extent. You say skilled, you understand to some extent. Now, if I elaborate on cognitive abilities, now there is the most bottom level is the knowledge. The next level is comprehension, right? Next level is application. Now you can see when we give problems to students based on application, students struggle. That is because that is a higher level of evaluation. The analysis, same thing, maybe my own subject, when you have analysis, they take time to understand. Similarly, synthesis and evaluation, so there is a hierarchy involved. And there is the various concepts we have for cognitive abilities. Then the second one is, I said, affective abilities. Now again, affective abilities, we normally, I mentioned that earlier as well, something like attitudes. But that is not the right term to use, because this means a lot of things. Now here, receiving is a very basic idea. Now people just listen. That is receiving. Now if I ask a question, if a teacher asks a question, our students don't respond. Now because that is a higher level. This is also a hierarchy, then valuing the lecture, or maybe organizing and characterizing. These are terms that are used in this scenario. We have to be mindful of that. So we are operating at the very bottom. In the earlier one, cognitive abilities, we are mainly dealing with knowledge. Now here, affective abilities, we are dealing with receiving. Now, the third one is called psychomotor abilities. Now this is a bit hard to understand. The terms are very clear, but exactly what they mean is something we have to work on. So these are three areas that one could develop, and that is when it comes to psychomotor abilities, we can develop that by having a rating scale 1 to 10. But cognitive abilities, we can give a mark, not 1 to 10 or maybe 1 to 100 or whatever, what we normally do. But this second one, affective ability, is very difficult to evaluate because it is personal to a great extent. So people don't like when your inside is known to other people. So that is the reason why affective domain abilities could not be evaluated easily. But sometimes we have ways of doing that by using cognitive ability and psychomotor ability to evaluate affective abilities. So that's an indirect way. You can design questions like that. Now, since this area is not clear, affective abilities, I thought I will explain this like this. Some terms that I use which are easy to understand to us. Values, feelings, attitudes, interests, sympathy, empathy, discipline, concern for others, industriousness, regularity, and sincerity. Now, we do that to some extent. Now, discipline, what do we do is we give a small percentage, right, for attendance. 5% or 10%. We should not give anything more than that. And then another thing is, I want to highlight here, is attitudes. You can see how far we have come to this point to describe attitudes. It's only one aspect and not main aspect. So that's why I selected attitudes. And look at this. For students' development, we have to have a comprehensive development, comprehensive evaluation. Then only our evaluation becomes complete. Otherwise, we are recognizing only one factor. So, if you want to evaluate somebody properly, we have to look at all three aspects. Now, at this stage, I just thought, since I'm interested in continuous assessments, just to highlight that, why we do continuous assessments. This helps teaching and learning process and provides immediate feedback. And also it motivates students to study regularly and then make evaluation comprehensive, involve teachers in evaluation of their students. Now, maybe when I indicate like this, people don't get the real meaning, so I have a small chart here. Now, this is half a semester which I have identified. Start to the reading week. And there we test that period because that is what is called phase test. And that is where the midterm should be carried out. Now, very often, I think I remember when we started the semester system, we were asked not to have midterms because students find it difficult because whenever you say exam, they get scared. But we have to design the midterm in that fashion so that students are not affected in a bad way. Then talking about quizzes. Like, you need not give quizzes to each and every section. You can give one or two at selected points. And also, I said quizzes, don't load them heavily. That is, you don't give them high percentage. Then it becomes very reasonable because it's not demanding. Then the areas to cover within that half of the semester, you can give assignments. The assignments are really based on take home. So when you say take home, our students might copy. They will copy. But that's why we should not give a very high percentage for take-home exams. Right now, we can't give a midterm as a take-home exam, a final exam as a take-home exam, because they are heavily weighted and we have to be mindful of that. Now, I have a message for the students here, because they always think evaluation means a difficult thing, a test. So I managed to get this, what is called a Chinese proverb, and that is the message to students. That is exactly a summary of what we should be doing. You hear it, what will happen? You forget. If you see it, you will remember. At least you will remember that was there in my note or something like that. Then, if you really do it, you learn. So, and understand the subject. So, don't think memorizing is going to help students. Memorizing is very temporary. It may last one day, 1 week, and that's it. Now, another thing I said earlier, which I want to elaborate, attitudes. Now, there are well-established idea about attitudes. Good attitudes for all. That is, first one is ethics as a basic principle. Then the second one is integrity, that is honesty. Third one is responsibility. I think if you think of our grandparents and parents, they had these attitudes. Now what has happened over the years is everything has got politicized and we have lost them, right? And that is what has happened. Then the fourth one is respect to laws and rules. Maybe at a university, maybe in the society, maybe even at home, there will be some rules and regulations which we have to observe. That is a good attitude. Then respect to the right of other citizens. Now, very often we don't care about the other person. We do things without thinking of the other person. Now, that is a bad attitude. Then, sixth one is work loving. Whatever you do, you must do with dedication. You must really like it, enjoy doing it. Then the seventh one is strive for saving and investment. Now, all the people had this idea of saving and investment. But today, if I say investment and saving, you won't agree with me. I'm sure I also don't agree, because things are so difficult, so we can't save and invest. But remember, most of you here, I think, are Buddhists. Lord Buddha used to say this: out of your income and assets, you spend only 1/4 of it. Other 1/4, try to use it for the development of the industry, and then the other half for future use. Right? So you can see all the people had this background. They used to do this. And now for us, maybe it is next to impossible to do it. Then the eighth one is will or super action. Now what does that mean? That means whatever you do very well. Right? You do very well. And that way, that is a good attitude. And the last one is punctuality. Now today, we don't take these things seriously. But ancient time, not very ancient, but maybe our forefathers said that when they say punctuality, it is a very serious thing. Even when we were small, when you say punctuality, it's very serious. But today, we don't have that attitude. So you can see all these attitudes are not difficult to develop. So if you have some idea about that, you can improve at least some of these if you can't improve on all of these. So that way, attitudes can be improved. Now today, you can see we have politicians who have actually we are lost in the whole process, because we can't trust anybody, because they are not having good attitudes. So this is what I heard at a lecture. From that I quote: requirements for a good politician must have an IQ level of at least 120. So that means there has to be some kind of learning. Then honest. Now honest means today's politicians are corrupt. But what I'm trying to say is, in future we should look for honest politicians if you are to improve on this situation. Then articulate. You should be able to use your limbs and then express your views. Then the other one is to do with, it should be responsible. And then finally, ability to debate and convince people. Now, why I put a who here after that? Whom are we going to select? Inflation. So those who have these 5 attitudes should be elected to office. And then only we will have well-rounded people doing politics. And that is what we should try and do for the future at least. We should not just do it for the sake of doing what we are doing today, right? So we have to think something new, and that is what is expected of this. So a well-rounded person should govern. That was his conclusion. Well-rounded people, that is the people who are having this kind of attitudes, should govern. Right? So that is basically what I wanted to say. Now then, I talked about attitudes. Now there are good attitudes. Now some countries have adopted good attitudes, and its people also have adopted good attitudes. Now this is how this has developed. This has improved with time. Now for example, if I take a country like Japan, Japan was completely shattered after the Second World War. Now today, Japan is the second largest economy in the world. Now how did they achieve that? They understood that their attitudes should be changed. And changing the attitudes, they developed this today's state. For example, if I tell you, now Japan has only 20% of land that is you could cultivate. 80% you can't do any cultivation. They don't have resources. So what do? They import steel and then manufacture various items, cars, vans, so on, and then export. So Japan is like a country which is like a floating factory, what they are doing today. So like that, they have done things in that fashion. That is how they have been able to achieve today's state, and we should follow things like that. Then also Switzerland. Switzerland is a small country. They don't have enough cocoa. They have a very small area of cocoa, but they produce world's best chocolate. Similarly, they produce the best wristwatches, and also Switzerland is the safest and best country to invest. We know about Swiss accounts. People have safe accounts, and that is because Switzerland is a very safe country. So likewise, I will not go into other ones because time is limited. So all these countries are very young. Maybe they have about 200 to 300 years of civilization. Then they are able to achieve all this. But on the other hand, if you consider countries like Sri Lanka, countries like India, Egypt, now these have civilizations dating back to 2,500, 3,000 years. But still, today we see they are having the situation where we are still poor countries. That is because of nothing but the attitude. So if you change your attitudes, you will be able to achieve this. So I think that is what I want to tell today. I will discuss about my research achievements when we have the lecture in 1 or 2 months' time, and I will focus that during that time. So thank you for your attention and attitude. Thank you.
Thank you very much, dear sir, for your words of wisdom on teaching and learning. You have always aspired us to strive in our engineering journey. To extend our heartfelt gratitude for you, I hereby request Professor Ruwan Weerasekara to be present back on stage to accept this token of appreciation. On behalf of the Department of Civil Engineering of University of Moratuwa to award our heartfelt appreciation, I cordially invite Professor Mahesh Jayavira. Thank you very much, Professor Ruwan Weerasekara once again, and thank you very much, Professor Mahesh Jayavira. Once again, I would like to sincerely thank all 4 lecturers bidding farewell today, not just for the years of service, and also for the lives you touched, the careers you nurtured, and the dreams you inspired. As quoted by Eduardo Galeano, history never really says goodbye, history says see you later. Ladies and gentlemen, shall we give another round of heartfelt applause for Professor Malik Ranasinghe, Professor Anura Nanayakara, Professor Atula Kulatilaka, and Professor Ruwan Weerasekara.
As we draw near to the conclusion of this momentous occasion, I stand before you with a profound sense of gratitude and appreciation. This symposium has been a testament to the power of collaboration and shared knowledge, and it is only fitting that we extend a heartfelt thanks to all those who have made this event a resounding success. We take immense pride in recognizing the hard work and dedication of everyone who contributed to the success of this event. To express our gratitude, I invite the Chair of the Organizing Committee of the Research Symposium 2023, Dr. Luminda Gunawardana, to deliver the word of thanks.
Good afternoon to you all. Professor Mrs. Chinta Jayasinghe, Head of the Department, Emeritus Professors, 4 retiring professors, Professor Malik Ranasinghe, Professor Atula Kulatilaka, Professor Anura Nanayakara, Professor Ruwan Weerasekara, the eminent professors to whom this symposium is dedicated, senior professors, and all other academic staff members from the University of Moratuwa, University of Peradeniya, University of Ruhuna, University of Jardhanapura, University of Jaffna, and the Open University Sri Lanka. Participants from the National Building Research Organization, distinguished guests from the industry, academic support staff, non-academic staff members, and my dear students. It is a privilege to deliver this vote of thanks on behalf of the Organization Committee of the Civil Engineering Research Symposium 2023. First and foremost, we would like to thank our chief guest of the event, Mr. Daniel Bood from the Canadian High Commission. His presence adds the prestige and significance to the event, and we are truly honored to have him here. Secondly, on behalf of the entire university community, I extended our heartfelt thanks to 4 retiring professors. Throughout your academic career, you have been guiding light, a source of inspiration, and a rich repertoire of knowledge for all of us. From all our hearts, thank you very much, sirs. Next, we would like to thank esteemed keynote speaker, Dr. R.C. Karunawardana, Director General, National Building Research Organization, and session chairs for sharing their invaluable knowledge and insight with us today. Your expertise has undoubtedly enriched our understanding of the field of civil engineering, further benefited our students. We are also deeply grateful to the Vice Chancellor, the Deputy Vice Chancellor, Registrar, Bursa, Deans, and head of the departments of all faculties of the University of Moratuwa, librarian and works engineer for their support extended to make this event a success. I sincerely thank all academic members from other universities, DICB members and ISL members for gracing this event with their presence. It is an honor that you accepted our invitation and spared your valuable time despite your busy schedules to be with us today. Next, we would like to thank all researchers and scholars from the University of Moratuwa and the NBRO who presented their research findings during the various sessions. Your enthusiasm and commitment to advancing the civil engineering profession by sharing your insights are truly inspiring. A special word of appreciation goes out to our sponsors and partners, INSEE Cement, Nippon Paint, Lanwa Steel, ICC and ELS Construction, whose generous support made this symposium possible. Your belief in the importance of research and your commitment to fostering collaboration with the Civil Engineering Department are instrumental in our progress. We extend our heartfelt thanks to the head of the department, Professor Mrs. Chinta Jayasinghe. Her guidance, unwavering encouragement and commitment to the success of the event have been instrumental in elevating the entire symposium into new heights. We also would like to thank organizing committee, including the symposium co-chairs, conference secretary, organizing and publicity group, editorial board, 3MT challenge organizers, graphic designer, editorial assistant team, senior staff who committed to raising sponsorships, senior treasurer of the Civil Engineering Society, technical support team, all academic, non-academic support staff, volunteers and maintenance staff who have worked tirelessly behind the scene to ensure the seamless execution of this event. Your dedication and attention to detail have made this symposium a resounding success. Last, but certainly not least, our gratitude extends to research assistants, instructors, students, and other participants of your active engagement and thoughtful discussion throughout the day. Your questions and contributions have added depth and diversity to the conversation, making this symposium an exciting event. Once again, thank you all for your presence, participation, and passion, and have a wonderful evening. Thank you very much.
Thank you very much, Dr. Luminda Gunawardena. Ladies and gentlemen, as the chair of the organizing committee, he could not thank himself. But it is our duty to thank Dr. Luminda Gunawardena for his commendable service to make the Civil Engineering Research Symposium 2023 a glorious event. He was indispensable to kickstart this event as he was constantly involved with ensuring the quality of research presentations and abstracts. His dedication in this regard ensured that the captivating researchers you saw today reflected the exceptional caliber of the Department of Civil Engineering, University of Moratuwa. He was also vital in overseeing the logistics of today's event along with other senior lecturers of the department. Ladies and gentlemen, can we have a good round of applause to appreciate the chair of the organizing committee of Civil Engineering Research Symposium.
As we draw the curtains on this enlightening Civil Engineering Research Symposium 2023, we would like to extend our heartfelt gratitude to our esteemed retiring professors, Professor Malik Ranasinghe, Professor Anurana Nayakara, Professor Atulakula Tilaga, and Professor Ruwan Veerasekara for their dedication, wisdom, and tireless efforts which shaped the very essence of our department. With immense gratitude, we bid farewell for these pillars of knowledge and extend our warmest wishes for their well-deserved retirement. Their legacy will continue to inspire future generations in the field of civil engineering. Thank you for your invaluable service. And on behalf of the Department of Civil Engineering of University of Moratuwa, we extend our warm wishes to all the presenters, wishing them a bright and a prosperous future. As we reflect on the core purpose of this session, it's about sharing knowledge and gathering here today, fostering more comprehensive and high-quality interpretations and outputs. I want to express my heartfelt gratitude to your enthusiastic participation.
With optimism in our hearts, let us keep pushing boundaries, fostering innovation, and working together to shape a brighter future in this journey of discovery. Once again, we sincerely thank you, ladies and gentlemen, for joining us in this sensational event today and taking your time to be here with us to make this event a thriving success. Signing off as your host for this momentous occasion, I'm Dineth Wijesekara.
And I'm Dulanjali Thoradaniya. Have a great evening and enjoy a long weekend.
Ladies and gentlemen, I would like to invite everyone to come here to the stage to take a photograph.